Perfect. Thanks. 4, 5, 6. Ah, 1, 2, 3. Okay. That's a little bit hot, so I'm gonna turn this on. Ah. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. E. Okay. Ah. Do you want more? It's okay?
I think it's almost time. So hello everybody. It's very nice to see you for the first Conflung in person, but second edition actually. And it all started a bit more than 3 years ago, I think, when we were working on that configuration language at my place, and we wanted to talk about it, but realized that there was no real venue for that. And so we said, why not just create one? So I just sent random emails to all the language creators, and Jürgen, who will come soon, I hope, and Mark, the other chairs, that did SEConfig, which was a similar event and configuration 2 years before. And everybody said yes. So for the first thing, we were like 7 people in the committee, which was a bit much, but still was really nice to see. And yeah, I think it was a success, at least from my perspective. So it's really cool to do the second edition now. And we will listen to Thomas, who will talk about Docker Smell and their impact.
Hello, everyone. Is the microphone working? Perfect. Today, I will talk to you about a small study that I did on the impact of Docker Smell. I was a bit curious to see what's happening on Docker because it's quite popular in companies, and but it's loved mostly because it's loved by developers, according to Stack Overflow. It's the most wanted configuration of programming language, and the most loved one. But when we dig a bit deeper inside the projects about Docker itself, we see that the knowledge of how to create a proper Docker file is not really well known by the community. According to Jürgen, 84% of 70,000 Docker files contain some type of violations, at least on open source projects. And when we compare Docker files created by experts compared to a normal folks on GitHub, there is 5 times more violations inside open source Docker files compared to, for example, Docker file created by the Docker organization, which is quite a lot. And so I was a bit curious to know what type of impact those Docker Smell can have on the project itself. And this, I identified kind of 3 types of impact. Mostly, there is the image. You can create bloats inside your Docker file. You can reduce the reliability, and you can reduce the security of the project. But for this talk, I will mostly focus on the image size, mostly because it's the only metric that I can really measure reliably. And basically, and I will divide the talk in 2 main parts. One, I will discuss on how to detect those smells and repair them. And then the second aspect, I will analyze what is the impact of smell before and after by removing the smell, basically. And I decided to detect and repair instead of injecting a Docker smell because I do want to contribute to the community and provide additional knowledge. Just having a tool that can display the smell and say, oh, that is a potential fix for you. But yeah, let's dig in the detection and repairs part of the talk. There is multiple related work that try to do some type of repairs or detection of smells inside the Docker community. We have some master theses that try to fix misconfiguration. We have some human in the loop repairs, but most interesting, there is an ICSI paper of 2020, which try to understand and learn DevOps artifacts in Docker. And I want to talk a bit more about this paper because I will inspire myself of this contribution in order to create my study. This paper worked mostly with 3 different steps. The first one is parsing the Docker files and bash. It's quite traditional, but what is the interesting part is they increase the abstraction of their models by injecting information about the commands of the Docker. For example, if you apt-get install, it will identify that you try to install package, and you can identify easily which package you install. And it's based on this annotation of the model, you can relatively easily do queries and create some rule-based analysis to identify the smell relatively easily with relatively clear patterns. And for the evaluation, they basically look at GitHub and try to find a bunch load of Docker files. In this case, they will identify 108,000 different ones. And they also identify Docker files created by gold samples, mostly from organizations that are used to write Docker files. In this case, mostly Docker, basically. And then they wrote 23 different rules to detect those smells. Those are the rules, and the interesting part of it is that they kind of identify which rules are visible or not in expert Docker files, and that way they can create a confidence level on which rules is problematic or not. And this we have a good set confidence, and we can see that some of the rules are really respected in gold samples, while it's not respected in the general community. They have create kind of a model of what rules should be fixed or not. In my work, I kind of inspire myself quite a lot of this contribution, and I mostly for the bash command annotation, because most rules are related to some commands, and just having this augmentation of the model is quite interesting. And I also use the rules that they presented. But I kind of improve a bit the contribution by including more rules, by also being able to repair those smells. Also, I can completely re-implement the approach and to be completely AST-based. That way I can reconstruct the source code, I can do the modification of the AST. This is a bit more reusable by the community. I also support like nested commands like sudo apt-get. That way I can also still analyzing it, and I can also support some conditions and so on. And in order to compare a bit the performance of my tool compared to them, I compare the precision recall of the both tools, and basically we are both good. But more interestingly, I did the detection and the repairs on a big data sets of their data set plus mine, and then I compared both the data sets, and I show that I succeed to repair most of the smell, with the exception of one of them, where I was a bit more protective, because I knew that this rule would break the build if I fix it too aggressively. And here you have the top 20 rules detected. This is mostly related to installation of package, npm apt-get install, and the use of caching. In Docker, you need to remove the cache in order to reduce the Docker image, and you need to do it in one single line, which is really not something that people are used to do in interactive bash. And that's why we see as such, let's go back to this slide, such a gap between the knowledge of practitioners, of normal people that are using bash, and people that are doing Docker. And we can see in this column which rules is a common practice in interactive bash compared to what should be applied in Docker. And we see that most of them are no. That's where the problems of sharing the knowledge between what you should do in Docker and what is actually done in practice is a bit problematic. Yes, I wanted to do a quick demo. It's not super impressive, but I think it's quite nice to see what the tool looks like and what I was aiming to do. I wrote this tool in TypeScript, mostly to be able to portability and sharing information, and also to integrate in Visual Studio Code. And basically, we have a Dockerfile on the side, and then we have all the rules that have been detected, and you can actually patch it. And it's also quite nice to see the extracting some knowledge, but also all the type of AST that exists, all the type of annotation that we extracted from the Dockerfile. For example, we know we have literals, we have apt-get package installed, that we can extract just by querying this annotation, and we get all the package that actually install inside the Docker. This is quite easy interface if you want to parse Bash and Dockerfile, for example. That's basically about the detection and repair that I wanted to present. Do you have any questions, comments right now? Okay. Oh, good. This I can move to the study part of that what I did. There's the goal. There is two main goals on this study: is kind of analyzing the impact of the Docker smell and identify which smell are more likely to cause the most impact. And also wanted to kind of get the perspective of developers, because if the developers don't care about those smells, if you don't, there is kind of no point of fixing them. For that, I had to create a new data set of buildable Docker image. I look at which would Dockerfile contain at least one violations. I only find 13,000 of them. And I only succeed to build 6,000 of them. This is already quite a big problematic of rebuilding Docker image of random repositories. And after that, once I succeed to build the Docker image, I do apply automatically the repair of the smell, and I build it, and 369 of them are failing due to my repairs. And this is the tables of which type of rules introduce the most regression inside the building. The first rule is mostly due to because I installed package without the recommended package, which surprisingly doesn't break that many builds, only 312 on the 6,000 of them. It also means that developers are relying on recommended. This is relatively optional. This is maybe something that to investigate in the future to see which package are actually needed, and maybe to declare them explicitly in your Dockerfile to increase reliability. Also have some issues by once I remove the cache of apt-get, and it's still used later on Dockerfile. It's one for basically developers don't respect the good practice of installing all your package in the same single lines and then using apt-get update and then install and then remove your caches. If you remove the cache a bit earlier and you try to install something later on, your build will crash. This is something that will require more advanced refactoring that I didn't support yet. It's planned in the future. Now I discuss about the impact, mostly on the size. On the 6,000 Docker files, and we have a bunch of issues, and I succeed to measure the image size before and after. And basically, by using my technique, I succeed to save 277 gigabytes, this 5% on average of the complete Docker images. And this is the compressed size of Docker. It's not the uncompressed Docker image. And we see that our median is quite low with 1.1 megabytes, but with some really huge one with 6 gigabytes of saving for some image. This is not revolutionary. It will not save a lot of space for a lot of projects, but for some projects it's really useful. And I will discuss a bit some examples on open source project. Yeah, and then also look at a bit Docker image. When you build a Docker image, you want to deploy it on Docker Hub to make it available, and you want to reuse it and deploy it. So I kind of look at what are the impact in terms of bandwidth. and we see that I have like identified 1,600 images that are actually deployed on the GitHub, and I have something like 4 billion downloads. And if we consider the safe saving, I would save like 40 terabytes a week just on 1,600 image. This is quite interesting that even small changes can have relatively big impact on terms of bandwidth, and I do expect that something at Google scale with much more built and much more bigger registry, this type of impact can increase even more. That showed quite a bit of potential. I was quite happy with that, and I decided to open a bunch of pull requests to see a bit the feedback of the developers. I opened 35 pull requests, but one of the projects has been removed since. I have 34 now. Thank you, open source projects. I select a bit randomly cherry picking a project by looking at projects that are accepting a contribution. I don't have a long sign up of license agreements and things like that. Only had to do it one for the number 26, who took almost a year to get merged because I had to sign documents and then sign it again and finally be in the Jira list. Just having Jira issues to say, oh, we should look at this, and then finally they merged it last week, I think. That was my victory. We have quite a lot of variety of projects, from small project with 2 stars and a relatively big project with 6,000 stars. And the image saving is from gigabytes of saving to few data save. Yes. This will have from few percent of saving until like 10, 16, or 40% of saving just by applying those simple smell repairs. And developers was pretty happy that that's some comment that I received. They say, oh yeah, that's pretty nice contribution. Can you also apply it on my base image, because that would save, would apply for all my projects. Also, you teach me something about Bash. That's pretty nice. This is my initial goal of introducing new information to the community. It's working relatively well, and people seem to be really quite happy. I only had 2 reject, mostly because they say, oh, we already have Alpine version, we don't really care about that, or it's already in production for somehow. That basically, what I'm taking of that is that developers really care about those changes. They consider it when they know about it. And the only reason that I get rejected is because I already implemented it. The main takeaway of this study is that smells can relatively be easily patched, because there is not much really complex things in those smells, and the patch that you can do is relatively straightforward, and we can find a bunch of examples on GitHub, and you just follow what developers are doing. We still need a bit more to be a bit more fancy in terms of analysis to be sure that the patch doesn't break the build, or do more advanced refactoring, like grouping all the apt get installed together and identifying what will be the impact on the project. Also, this Docker smell introduce quite a lot of bloats, like around 5%, but this can relatively be easily mitigated. And most importantly for me is that developers care about those changes. I was expecting a bit more reluctance about the smell, because when we talk about smell to developers, most of them say, yeah, we don't really care, it's just false positive. But in this case, they seem to be quite receptive about it. Thus maybe this type of smell are relatively precise enough and with relatively low false positive and really quite actionable that the developers really care about it. And also, my other takeaway is that developers don't know the good practices. And that's having tools like that kind of give them what they should do relatively straight in a direct way could be quite positive for them. Yeah, my next step for this type of work is kind of try to predict predict the impact of a smell. So I do a static analysis of the Docker file and say, oh, you identify those smell. I predict that you have 1 gigabyte of bloat inside your image. Because I realized that providing this information to the developer really motivate them to actually do something about it. And just say, oh, fix that, and without providing the feedback is problematic. Also plan to apply some additional rules. Identify some interesting one that I want to do it, mostly in security. I realized that developers are still using a lot of HTTP inside Docker image, especially to define the registry for the package. Does it mean that you could really easily do injection of malicious content inside Docker image, which is problematic and surprising. And also, I would like to find a way to analyze the reliability and security impact of those smell. But I'm not sure exactly how to do that. If you have some ideas, just let me know. But probably will more like a case study, and we'll see. And also, I want to share that I have 2 open positions at TU Delft. One about the testing and automatic maintenance of Docker. If you know someone that would be interesting to do that. And also, we are starting a new lab with JetBrains on introducing more runtime information inside the IDE. You see also someone, if you know a PhD student that wants to do some runtime analysis and patch generation or feedback information to developers, just let me know. Yeah, that's basically the end of my talk. If you have any question, I think I have a few seconds right now to answer them, otherwise it will be a bit later on. And thank you very much.
Thanks a lot. Yes, we have a bit of time for questions, but also keep your questions written down because we have a dedicated time at the end. But if anyone has an immediate question.
Okay. Yeah. So thank you. That's a really cool talk and a super interesting perspective here. Can you say a little bit more about the fix space? So what do these fixes look like? Are they mostly sort of semantics preserving? Are they sometimes more complex?
They're pretty simple. They don't always preserve semantic. Look, for example, if you say, I want to remove the cache, if you install something at runtime, you can have a problem. But, or if you remove the recommended package, if you depend on it, your runtime can actually crash. That's why I need a bit more advanced analysis, not only on the Docker file, but also on the application. And there is quite a lot of debloating tools for Docker image. And this I would like to use a bit those approach with maybe coverage, kind of also with some dynamic information. But most of them are quite safe, like removing cache from npm, because normally in PM when you install it in the root folders and also in your repository. You can remove one of them to save space and stuff like that. Yes.
How much discussion do you see about this in the pull requests? Like, were there people like, hey, I have to check what you're actually doing here? Or were they like, oh, this looks simple and good?
Most of them just click on merge without any comments. Some a bit more advanced project kind of say, how can you analyze if we really don't need those dependencies? And some of them ask me to remove, for example, the non-recommendation. They ask me to remove that specific patch. And you consider just keeping the one from NPM, keeping them from pip, and just removing the one from installation of the recommendation. Because they kind of, some people know a bit more about it and just a bit more careful, and also depend on the complexity of the project. The project that asked me that was really low level, compilation based, and this compared to just a web application that just provide content.
Okay, very cool work.
Thank you.
Thank you. I think we can go with the next speaker, Davey Newell from Google, who will talk about measuring the impact of configuration on code, if I understand correctly.
Sorry about this. I have somewhere I can get my mouse back, right? Get the mouse back onto my other screen. What's the Wi-Fi?
Uppercase. Uppercase, everything uppercase. And uppercase.
The H in the right spot.
Yes.
And all uppercase.
Oh. Nope.
Still, yep.
Yes. 22.
We all sympathize that it's, typing of an audience is hard.
Yep. Alright, well. We'll go with this. Nope. Yeah, but I need to get it back over to this monitor, and my mouse is not letting me do that. Alright. Good enough. Alright. Thank you, everybody, for putting up with that. My name is David Newell. I'm a senior software engineer working at Google on the configuration safety team. And I wanted to talk to you about the interactions between configuration and code, how each one affects the other, and kind of how to measure and understand if the two are working safely together. First off, though, I want to start with a story. So back in 2012, I was living in and working in Manhattan, consulting at a financial trading firm. And August 1st, I come into work at a reasonable time in the morning, and everyone's talking about this company, Knight Capital, that was just down the street from us. And the outage that they just had and how they had just ruined the markets, and everyone asking, could this happen to us? Could we fall into that? And researching this a bit more for this, this is just a comedy of errors. So the New York Stock Exchange came out with this retail liquidity program where the big clients could get a preference. And Knight Capital was one of those and decided we are going to reuse the flag that to turn this on that had only been used about 10 years ago for a now defunct testing program that is still in the code base. And then they go in and update 7 of their 8 servers. Not sure what happened to the 8th, someone just forgot. In 2005, or before 2005, there was a quantity function that could limit how much this testing program did, but it wasn't used in 10 years, so that got removed, but the testing function did not. So whenever they turn this on August 1st at 8:01, they get a bunch of emails saying this 10-year-old program, something's going on with it. It's testing only. It's 10 years old. They don't care. Not a problem. By 9:30, the trading on this retail liquidity program starts, and the 7 servers that were updated work properly, and the one that wasn't, this extra testing thing, PowerPeg, was meant to move the price in testing, so it bought high and sold low, just to keep moving that price until it got to the right point. 9:34, the New York Stock Exchange reaches out to Knight Capital and says, hey, something's going wrong with your servers, you should figure it out. All of 4 minutes. And so, of course, great, Just turn it off, and we're fine. They didn't know how to do that. So it kept going. Eventually, they figure out what the problem is in that it's new, it must be the new stuff. So they roll back the 7 working servers to the code base that has the one bad one. This whole thing lasts about 30 minutes, 30 to 45 minutes. They end up holding on to 6 billion worth of stock across 150 different companies that they didn't really know what to do with. One company I saw in particular, Wizard Software Corporation, started off the day at 9:30 a.m. at $3.50 a share, and then by the end of this, about 45 minutes later, it was trading for almost $15 a share. So 4x jump in price, a little bit more than that, over less than an hour. What happened here? Well, they had some code, and it just fundamentally changed the way their configuration worked. Flag used to point to one thing, now it points to something completely different. But it works the other way as well. The next year, Google had an issue where the code was running. It was a well-used library. No real problems with it. But there was an invalid configuration that started using the library now in a different way. So in one of these, the code changes underneath the configuration, and the other one, the configuration changes how the code is run. But these were both 10 years ago, right? That's not a problem anymore. It's actually kind of gotten worse. I mean, now we have a lot more stuff in the cloud and containers, and you have to configure all of those, and you can change how much memory or what addresses everything points to. And so I'm not exactly sure this drop in 2020, maybe with all the COVID, no one is rolling out new servers, but we'll see if it starts to creep back up again. It grew pretty quickly before. Some recent ones, this year Spotify had an issue. Normal Git maintenance, but while their servers were down, they roll out a new DNS configuration. When they come back up, it's propagated to every server. GitHub had one earlier this year. Configuration incident, they caught it quickly, roll it back. The rollback fails. Cloudflare had one, another network configuration. All of these this year. So this is still a problem. But so how can we measure this? How can we track where things are dangerous and where it's not? Well, in code, we have a set of practices that we should also be applying to configuration. Things like code review and whatnot. But we also have some metrics. Now, if these metrics are perfect, it doesn't mean your code is perfect, right? If you have 100% code coverage, doesn't mean there's no issues. But if these metrics are bad, there's definitely a problem somewhere in there that you don't know about. All right, if you're running around with 5%, 20% code coverage, who knows what the rest of that code is doing? And we can come up with some of these specific to configuration as well. So distance from definition, number of usages. Imagine you have a dry run flag supposed to stop writing to the databases. Well, if you have to remember every time you're trying to write to the database, check if dry run, log, else, write to database, at some point you're going to forget. The engineer who was writing this isn't thinking about the dry run flag. They're thinking, I have some data I need to write out. If we move this all up to the front, in your main function, if dry run, fake database, real database, then no one has to think about it later. But also, a lot of these same metrics that apply to code can apply to config if we think about it in a certain way. So I'm going to focus on code coverage. So here's the example we're going to look at real quick. We have this flag connection. It has a couple different types, TCP, UDP. And we can see it's used once. It's used early. That's good. If we add a new one, we just increase the case statement. Probably should have a default, but screen size. Let's say we have a test for the TCP one. Is this flag well tested? Is the code coverage for this flag good? Well, no one would test that var connection equals flag.string. What do you test? How do you even set that up in a test? Yes, the flag exists. Doesn't really protect you from anything. But if we test the individual case statements, then we know we can see here one of them is tested, gives us about a 25% test coverage rate. Not great, we should add tests for the rest of them. And then we can feel good turning this flag on into any of these conditions. It's probably well tested. So how would you do that? Find the flag where it's used, find the test coverage there. If it's passed into a function, is the body of that function well tested? The return values of that function, or maybe you make an object with the flag, are those well tested? Is the methods of that object well tested? And kind of repeat this to an arbitrary depth till you think I've actually captured where the flag value is used. All right, if you open a database, I want to make sure that I'm opening the right database, but once I have that, I trust the database library is going to work as it should. So we tried this, we did this. How did that work out? Well, it did. We preferenced telling people only when we were sure something was poorly tested. So we looked at the results, and the ones that we were clear on saying you should add some more tests here worked, that was true. But it's kind of hard to parse a language kind of from this side somebody wrote, and now we have to go through and understand, and how far do we test something to know if it's still the flag under test versus some result that no longer needs to be tested. And this was just for Go, which is a fairly simple language in terms of syntax. If you're trying to spread this out, even if you just have front end and back end, trying to apply this to a UI as well, you've got two languages. If you've got multiple back end languages, Java, C++, whatever, trying to parse all of those, it becomes increasingly complicated and just more work. But I was thinking, while preparing for this, I've heard all of this about LLMs being able to parse programming languages, to write tests, to change comments into code, or the other way around. So I thought, can it do this as well? How well can it understand the layers of flags and how far they get passed in? So let's find out. So here's the test code. I'm going to paste this directly into the LLM. So scroll by, so take a look now. The only flag we're looking at is port. It has a lower bounds, and then gets passed into this make call function where it has an upper bounds, and then we just have a fake even, odd, connect, don't connect. And then there's a lot of fatals if anything doesn't go exactly right. We have a test for this, but the test is only even, odd, and only for make call. There's no reference to port here in any way. All right, let's see if, all right, please get a little, that's just going to be fuzzy. That's too small. Okay, well, so I paste the code in here and ask, where's the flag used? Look at the functions it's passed into, look at their return values. Tell me everywhere it's used. It starts off very simple. Good job, it knows the language. Declares the flag, easy enough. Parse the flags. It knows what a flag is, I guess. Direct reference, lower bounds. That's easy enough to get. Make call as well. Again, directly passing in the flag, easy enough, but now it's able to step into make call and understand that port is now renamed outgoing within the function. And it gets the upper bounds and then the fake connection. So LLMs have a fixed amount of space you can for input and output. So sometimes you kind of need to say continue. And so here I ask it, what about the return value? So it keeps going, make call, and then it'll go through all of these failure cases. All right, so it knows that if it's actually connected, it's going to error out, and then a successful message. So now, I ask it about the type completeness. Tell me what are the valid values of port. So checking if it can understand all of those conditions that it already told us about. So it gets the lower bounds. It understands the upper bounds, again, being passed in and the name changing. And it understands that it needs to be even. So it's able to catch all of these conditions. All right, and the last thing I ask is, how well tested is this? I paste in the tests and say what tests need to be added for this to be well tested. So it reads this existing test cases first. It's worth noting I ask it where the port flag is well tested, and it immediately says you have the even odd tests for make call, and it understands the upper and lower bounds testing needs to be added. Oh, so there's the upper bounds. And then, yeah, boundary test for minimum valid port. So this was able to go through, track where the port is used in various functions, understand those functions, look at the return values, kind of parse all of this, tell you what values were useful for the flag, tell you what tests need to be added. So how could this be improved? There we go. Well, first off, this is very wordy, and it doesn't make a lot of sense to go in every time and sit there and wait for the response and type in, tell me about this flag, tell me about that flag, continue with the return values. So prompt tuning can help out with this to shorten it down into something that you could automate. It's easy to parse flag names out of a file, find the flag name, put it into some template, send that up. Get your LLM to respond in something less verbose so that you can parse that again and have some useful results. But like I said, there's the limit on the input and output for the LLMs. So this would naturally get better over time, but I question, if you have full production level code that you're trying to paste in here and tests and getting passed through multiple files, how well this would still hold up. But at least for a demo for here, it seems to work out. Right? Well, thank you very much.
Hello. Thank you. There is a bit of time for questions. Yes, Marcel.
Question that comes to mind immediately using LLMs, how would that scale at the Google code base? I mean, does it, or do you anticipate?
So you can use, LLMs are kind of expensive. This is a nice thing you could do kind of offline when resource usage is low. Mm-hmm. And you might want to do it like on every change, and then it gets more expensive. That's just kind of where you're putting the resources and if this is protecting you from enough to be worth the resource.
So one comment for the first part of this analysis where you see what are the conditions.
Yeah.
I did some analysis for Istio, like very similar, but I used SSA instead.
Mm-hmm.
And I was able to get like 95% coverage, like from the Go code, getting all the expressions that basically to validate. So to know what the ranges are, what are the valid ranges, what are the valid inputs.
Okay.
Just FYI.
Yeah, good to know. Thank you.
Thank you. Other questions? You okay? No? Nice. Sorry.
So I assume, you didn't mention it, so you probably didn't try an AST approach. Like, like you wanted to try the LLM approach for this. It would be interesting to see if an AST approach, well, like Marcel was saying, for like it gets. I imagine it would get pretty good coverage for simpler things if the LLM would be more helpful as the file has more indirection towards the actual flag values from the start statement, right?
Yes. So I did actually use the AST approach, and that's the results that we got. That was actually working. The problem is parsing all of the different ways flags are created and used. And so it's kind of an ever-growing problem.
Yeah.
So it works. It just takes time and effort.
I see. So at that point, like the LLM is almost like a heuristic, where it's maybe even simpler
Yeah.
computation-wise.
Yeah.
Interesting.
Yeah, I worked on the LLM BART just for this talk, just to see
Yeah,
if that would
yeah.
work as well.
That's cool.
Thank you again. And we can have the next speaker. I don't know who it is because there's like 6 authors. And it's about justifying configuration in code using justification diagrams.
Great. This is going to be interesting. Yeah, this is going to be interesting. I'm sorry for the people I cannot see. I'm too small. So, yes, hi. My name is Corinne. I'm here to present, yes, configuring is good, but have you ever tried justifying? So, quite a subversive title for a configuration workshop, but here we go. First of all, thank you, David, for actually introducing exactly like a use case for what I'm going to say. So, first of all, my team, so I'm Corinne, I'm from NTS in Montreal, Canada. I've been working under Sébastien Mosser, who's been at McMaster University and works with 2 interns that we've collaborated with, Aaron and Disha. And we've also benefited from the expertise and ancient knowledge of Jean-Michel and Mireille, who are working in France. So, as the title says, yes, configuration is nice, but it's insufficient. What we're trying to say with this is that configuration without justification creates problems, and a lot of problems, and sometimes even death. So a few, and actually that's true. So actually a few examples, like in 2021, we've all seen what happened with Facebook, or all of Meta actually, when it suffered a 6-hour outage, and that was because of a DNS issue. Another example, in France, Orange, the biggest telecommunication provider in France, suffered an 8-hour outage and disrupted its 112 services, which is equivalent to 911 in America, and because it updated its call servers. And then more recently in Canada, where I'm from, Rogers, our biggest, well, one of our biggest telecommunication provider, also actually deleted one filtering rule in its systems, and it actually flooded its own systems. So then it suffered a 15 hours outage, disrupting also 911. And I think the Orange one actually might have been implicated in the death to 6 to 10 people because the emergency services were not reachable. So all these incidents were actually caused by configuration errors, and mostly they were all avoidable, and that's how can we do better, actually. So we need to understand the why behind configuration. This is critical to what we're doing. We understand that deleting a filtering rule doesn't seem like much, but if it ends up causing deaths, then there's something to do here. Yeah, we need to make the justification explicit to better understand why things are configured the way they are. Those incidents would not have happened if engineers had understood more deeply the legacy system they were working with. Why is the configuration this way, and why can I not change it right now? So when I'm talking about configuration, of course I'm talking at large, but specifically for this case, I'm going to be talking about YAML mostly because my field of expertise right now is pipelines, so I'm staying in my lane. So this is a Docker Compose first version of a CI/CD pipeline. This is their first version in 2020, actually the 3rd of April 2020, for the project Docker Compose. So that was over 3 years and 6 months ago, and actually more than 80 commits ago. So like maybe now someone at Docker could explain to you what's happening here and why they made those changes, but certainly in 5 to 10 years, nobody will be able to tell you exactly why they made those decisions. And that is a problem. So how do we go about this? How do we justify and make sure that everybody knows why we're doing the choices that we're making? So how do we do that? We could reverse engineer commits messages. That's exactly what a colleague of ours is doing, Bentley Oaks at Polytechnique Montréal. But that, of course, I've been doing that for the most part of the 3 last years, and it's a hassle, it's long, it's difficult, it's super error prone, so let us not do that. The only reason why Bentley Oaks research works is because it's working with Linux commit messages, and Linux commit messages are extremely standardized. What else? We could maintain documentation in parallel to source code and configuration. But again, that doubles the work, and there's a high risk of mismatch. And if we're really honest, like eventually engineers are just gonna stop doing it and go for the code. So let us not do that too. So what can we do? Well, we propose to focus on justification and then eventually add implementation details to it. And then eventually we could automate configuration generation and validation. So how do we go about this? We want the how to support the why and not the other way around. We want to be able to not configure first and then explain why we did it. We want to understand why we're doing things and then go about how we're doing it. So justifying is, those are my papers, anyone who want to see them, but I've been working with justification diagrams for a couple of years now. So they were introduced by Thomas Polasek in 2018. They're designed for software accreditation and validation, actually. We reworked those a little bit to go with DevOps pipelines as of 2021. And I've created a visualization tool available on GitHub. So generally, how they work is fairly straightforward. At the top, you have your conclusion. What are we trying to do? What's the end goal? And then you have, in green, you have strategies. So how do we go about justifying this? How can we prove the conclusion that's going to be on top? So under there, you can have sub-conclusions, which are the result of other strategies and so forth, until you get to the leaves of that kind of tree, which are supports. So what are the physical, tangible proofs that support your conclusions? Sadly, those are still documentation. Those are still just more paper that you can add to your project and that nobody will eventually read. So we're right back to what we were saying in 2. And yeah, this sucks. We don't want this. So then Jean-Michel Bruel had a really great idea. He said, what if justification were operational? And we all took a moment and said, what? What are we saying? So we're going back to what we're saying here in 3. Focus on justification, add implementation details, and then automate configuration generation and validation. How do we do this? So when we went to do justification diagram for another research, we made a simple DSL, which was very heavily based on Plant2ML because we hoped it would be eventually part of Plant2ML. That is long gone since, but that's what it was, so it's still there. So we simply had some, it was fairly straightforward again. So we had the support, the strategies, and they all had like aliases if we wanted, and then labels if we wanted. Simple links. Anybody who's done UML here sees the resemblance. It's exactly the same. And yeah, that's the language that we implement to do the justification diagram that I showed you just earlier. So now, if we wanted to make it operational, then what we could do would be to make it so that we, instead of having supports, so the leaves, the tangible proof that you could have at the bottom of the tree, instead of that, what we could do is have evidences. So what are evidences? Evidences would be, again, anything that you could produce that would be tangible proof of what you're doing. For this language, we just went a little bit more with semantics. So instead of having those arrows that we just use in UML, we moved away from that and just went with verbs. So evidence is, it's labeled. This support actually supports this strategy and so forth. Yeah, so this is nice. But what if we could push it a little bit further? What if we could add patterns to those? What if we could create patterns that could be reusable and eventually composable inside those diagrams? What if we could define a pattern as any support or evidence that would be used to support another strategy and then another conclusion and so forth? Well, in that case, we could have patterns which are an abstraction of what we were going to do. And then obviously we'd have implementations. So we'd have an agnostic pattern that would be able to just say, I need any kind of evidence to support this subconclusion, this strategy, and then go so on. And then we could add this implementation to it saying, okay, for this case exactly, I want to use, I don't know, YAML, I want to use XML, I want to use anything, actually a Jenkins file, who cares? I want to use this language to implement this justification. This is how I'm going to do it. But see, we are severing the link in between why and how. We're making the why extremely explicit so that we understand why we're doing things, so that any engineer would come up and want to update that configuration, so the how we're doing it, and would have to go through the why, so would have to go through the justification to make sure we are understanding why we're doing everything. So using this, it would be super easy. So I went way too fast, but in any case, so what's next? Like I said, justification diagrams were originally proposed to be used for accreditation in railways and avionic industries. So what we're trying to do here was to prove that to get this accreditation, I need the software to do exactly those steps. And this is a way to prove that those steps are implemented in the code at exactly those places. We reuse those for DevOps pipelines to say that I want this pipeline to be able to meet those goals. So here is each step that goes towards that goal. But actually, this could be applied to any configuration use case. Anywhere you can have a configuration and a why you're doing things, and then how you're doing things would be probably implemented. So the tool that we're using right now, it's called JPipe. It's in development. We're working with students from McMaster University. It's an open source project. Anybody can go and see it on GitHub. Please come and try your hand at it if you want to just try stuff. And I want to make a shout out to Nirmal Chaudhary because he's been maintaining thanklessly the repo for a year now, I think. So thank you so much. And yeah, we're really interested to know what you guys think about this.
Thanks a lot. And we already have a question.
Thank you.
Thank you.
This is my probably favorite topic.
Mm-hmm.
Why do you think it's configuration?
I think configuration is a problem. I think there are others.
No. What I mean that everything you showed before, it was nice,
Yeah.
but it was not configuration.
Okay.
It was all code.
well, code to make configuration.
Well,
If I do it, if I define a YAML file to define
So-
a pipeline, this is what I'm doing.
so I think one of the issues we have in general is that there is no clear distinction between code configuration and data.
Okay.
And every time when we are talking about configuration, we are looking at some evidences, whether this thing is a configuration, data, or code, and depending on our perception of this thing, we are choosing different tools. And for example, for your YAML config, I would call, yes, you're using a configuration language, but actually you're writing code.
Okay.
And if you're writing code, you should behave like you're writing code, so you should do other things we are doing when you are writing code.
That's interesting. We're going to look into that. Thank
So,
you.
yeah, and that's one of the issues which I think we don't have a really good theoretical support, how to distinguish between configs, data, code, and why and when we should use one and another.
Thank you.
Yeah, so we exactly discussed this matter at the DAX Tool seminar, so but maybe Jürgen want to speak about it.
No, I just want to follow up on your comment here. No, Jan is right. So we had a DAX Tool seminar earlier this year where this unclear boundary between what configuration is. So I wanted to follow up with you on this one here. Would you consider configuration only if it's a more simplistic key value pair? No. Okay. So can you maybe expand on your definition of where you draw the boundary between what is a configuration and what is then code that is written in a configuration language? I think just having that discussion point, I think, is interesting.
Well, I'm not sure, first of all, it's the right venue to discuss that, because it's getting more theoretical. I don't have any evidence and support right now, but from what I feel about that, the configuration is something which changes the behavior of the base code, but it's not being executed as the part of the serving of the main functionality. Basically, you are feeding something into the main code, and the main code serves users. So it executes what you want to achieve. And for example, in this particular situation, when you line up multiple commands in your CI/CD pipeline, you're executing the main code, what you want to achieve. And that's why what I'm saying that, yeah, I know that the border is blurry. There is no clear way to say, okay, this is exactly the code, this is exactly configuration. But in general, that's kind of my perception of this. And the data is something you cannot execute.
So actually, if you look at the definition of configuration management as it was originally developed by the US military, unfortunately, they're pretty darn precise about what configuration is. And it is indeed also code. It is much more than just key values. But it's very close to what you're saying. It's basically anything that sort of can change the behavior of the process that you can sort of set outside of the normal development process. I'm butchering this completely because it's also much wider than just software. It's not only software, right? It's also machinery. And yeah, yeah. But anyway, my next talk dives into this. The next talk, which is my talk.
Yes.
So the spaces that you expect this to be useful in, have you gotten any like feedback, or have you like shown it to potential users and stuff? Or
No, this is the very first time we're showing this outside of the university. So,
cool.
But we would really love to find other use cases. Docker Compose was one interesting because it's a huge project and like it's starting to have a life of its own. But going about maybe finding bigger project, maybe an industrial project instead of open source would be really nice. Yep.
Yeah, it does look really cool, especially for the purposes of not having to just use git blame for
Exactly.
for all outages and stuff.
Can I transition this into the discussion part? Okay, so I was a bit late this morning, so I don't know if you introduced the workshop at all. So hi, I'm Jürgen. I'm one of the co-organizers of this workshop. Earlier this year, we had a DAX Tool seminar where I see a bunch of familiar faces, so thank you for coming again and also giving talks. The purpose of this workshop is to talk to each other, right? It's not about having specialized talks. This is just let's say, to ignite the conversation. But I feel like this is a really good segue into opening up the conversation to everyone here and to see you know, given what we heard today, you know, what can we say about configuration? And I thought we had really cool talks today. I want to piggyback on your talk, which I found super cool, and posit a potentially controversial question. Should it be harder to introduce configurations into a code base? Which I think, you know, any sort of formalism that this last talk sort of proposed here introduces, you know, work that is worthwhile doing, right? But it also becomes tedious for people to do this. So they're like, okay, should I really introduce this configuration? No, because I have to justify it. I have to formally introduce concepts to justify it. So maybe in general, just a question to the audience, should it be harder to introduce configurations into our software systems? And then we go back.
So I generally would claim that nothing should be made harder artificially. But I think generally the discussion of treating configuration or that configuration as explicit debt, that should be more the focus. So I think there shouldn't be harder to introduce anything, but it should be harder not to reason about your technical debt that you have in general. And having configuration that is not used is just debt.
Yeah, I think it's similar to what Daniel said, but the problem, I guess, is that we make it so that it looks like to be light to add configurations, like just a few options, but in the end it can control quite important properties of your program and what it does, and it should be treated as adding new code, not necessarily made harder, but properly treated as part of the code.
So as a general philosophy, I think it's always good to try to not have more configurations. The less knobs, the better. But it's really hard to make it harder, right? Because if you make certain paths harder, then people's like, oh, let's just hardwire a constant in code. That's also configuration, right? And then so it's not so easy, I think.
Yeah, my motto is configuration shouldn't exist in general.
You'll make a lot of friends today.
Yeah, that's why I'm here. But one of the things which I was thinking of is why do we have configuration in general? Like, what is the purpose of it? And why people decided this particular property is better to keep somewhere on the side? And my current think about that is that it's an ability to scale people. Like the complexity of the system code plus the config is supposed to be lower, and we can let different group of people to focus on different problems. For example, we have an expert who is capable to work on the code, and they don't know how this code will be used. So in the configuration, it's a way how we can scale these people so the experts can focus on the problems they know and care about, and the developers might just not think about all of that and just use something as a tool and use configuration to tell how this code is supposed to work. But I feel like we don't have enough theoretical foundation to build all of that, and it's all based on our speculation, at least from my feeling about this problem.
So there's one blog post that everybody in this space should have read. It's like very old from Mike Hadlow, but it's kind of whimsical, but it's pretty accurate. And I've been at Google for like 20 years, and I've seen this happening several times. So it's called the configuration complexity clock, and it shows how people think about configuration in a corporation and how it changes over time. So you see indeed like these fixed values within a configuration, right? Like hard-coded, and then let's get a rule base, and then let's get a DSL, and then like, oh, that's too complex. Let's go back to code, right? And like you see the circle over and over and over again, right? Like also, should it be a programming language or a DSL? That's an eternal cycle, goes back and forth, and it's hard to break out of it. But at least it's good to understand how different people can think differently about configuration, and usually it's a zeitgeist within a corporation, right? That majority of people think a certain way based on past experiences, and that's quite important to understand. Anyway, it's a good read, Mike Hadlow.
I think that's a good point, especially in terms of we're talking about should it be harder to have people make configuration languages or add configuration. Like I think, I'm not that old, but like, I think it's pretty evident that people use configuration because people find it useful. Like anywhere that, any company that exists has created probably several configuration languages just from the inevitable hard-coded values to, oh, we need one additional feature, and then that spirals into becoming its own language, and as you said, the clock, it spins around. And so I feel like instead of getting people to not write configuration languages, we have to accept that people continuously do this for a purpose. And like having people better understand that these configuration languages are probably going to exist, and just evangelize the better practices for them seems like a better, like, or a more successful proposition than just like getting people to say, oh, like, let's not use any configuration anymore.
Yes, I mean, I think it's unavoidable because it's like an input. You don't want to recompile your Unix kernel because you want to disable IPv6 and v6. And yeah, I think the only thing that we can do, because it will exist and people will do, is we try to make good tools and good language for that. And you know, when you see like the first config language, I haven't used it a lot, but I've had a lot of, I mean, I've heard talks about Ansible, for example. And I think what's dangerous is that you pretend to be YAML, but you have like programming construct in it. And I think what you can do is to, you know, try to either make it very simple or accept that this is something more, but not pretend this configuration and do some kind of half-hidden Turing-complete language inside. I think there is a talk about that, right? Yeah, right. And yeah, it's a bit like, you know, PHP was very useful to a lot of people, and it allowed, I mean, I wrote PHP when I was younger to make websites, but it was a language that wasn't designed by language people, and I think it showed somehow, and at least my personal stance is that we can try to bring things we learn from general purpose programming language into the configuration space. Sorry,
so, I mean, I from what I've seen for usages in config in Google, I think we also need better categories of config, probably more, because there are configs where a program takes in a particular value depending on whether it's running in a staging environment versus production. I don't think I can go in and say remove that configuration, right? That is absolutely needed. While there are certain other things where flags are used to release features, which are supposed to have a particular lifetime, but we have all this configuration mixed in together. We don't know even the purpose of the config. Maybe if we had like better categorization, better modularization of configs based on their like intended purpose, and maybe something like environment-based flags shouldn't be even human editable. There should be some other system that should be based on whether it's a staging or production, automatically sets the flag. And if you're adding a flag that is not falling in any of the predefined categories, there should be a system that says this should be difficult for somebody to add, probably, right? So.
Anyone else?
I want to piggyback on something Alex said earlier, which resonates with me, where it's sometimes about choice of adding variability to the system. And I think there's a community that I hope someone is here today. Is anyone here from the software product line community? Software product line. It's a whole like sub-community of software engineering, and they deal with so-called product lines, which deal with variability, and it's out of like automotive software, where you have like tons of configurations and how you can produce variable software, right? That you know, if you have a car, then you add on 10 flags, and you have this kind of car, and if you add those 12 flags, you have a different kind of car, right? In the end, it's about choice and customization, and I feel like it starts off with a flag because you want to have a choice somewhere, but then you want to give people more choice, and then your language evolves to introduce that choice by people who are not experts in the system, but know how to configure those systems, right? And then as we go and make these languages more complex and more expressible, we get into Turing-complete or similar realm, which makes reasoning about these things more complex. Where we go back to your talk, right? The other question that I have here is to all of you, should we allow the most expressible forms of configuration as, well, that's the controversial part. I see you, shaking your head. Or what kind of expressibility can we allow if we pair it with the right reasoning tools? If you can reason about the complexity that we introduce. I think you already have, yeah.
Yeah, I mean, should keep it short now, but we have, so when we designed GCL at Google, there were two big lessons from previous configurations, pre-GCL. It's like, don't do more than one layer of inheritance ever, and don't compute in configuration. So both of which went down the drain very quickly with GCL. So I'm sorry, I'm giving my apologies.
You were
there. Yeah. And so basically, like I think it's possible to, so we also had this idea, like initially wanted to do is like you can actually separate code from configuration by pushing the code to the server. So that's a pipe dream. Like at Google, we thought we could do it because we own the binary, so we can control what goes in there. But from a social perspective, it's not possible because people might want to add options that are not the people that write the binary, and then there's friction and all that stuff. So you have to do computation in the configuration layer, whatever that is. But my sense is just don't, still within the configuration layer, separate the configuration from the computation. There's also computation and configuration, but don't use a DSL for that, basically. It's possible to, with logic programming, you can separate it out easily. You can leave the holes and have this interleaving between execution and configuration. So that's my stance, basically, but not a new one for many people here, I guess.
Any other thoughts?
Well, you mentioned the car industry and so on. I'm not from, my name is Boris Magnusson. I'm from Lund University in Sweden, and have been following for many years what became Sony Mobile, but it was Ericsson and Ericsson Mobile, and God knows the many names they had. And it was a small company in the beginning. It was started by 15 people from Lund University or Lund Technical University, so I knew a bunch of them, and have been following their work on how they achieved what you were talking about. In the beginning, it was just a few models of their mobile phones, but very quickly they have a couple of hundreds, because they have development ones, and they have different radio bands. They have different facilities, different cameras, different vendors or operators that would use them. They would have their own games on them when they were delivered, or their own splash screen. All of these are trivial, but if you multiply them together, you get hundreds and hundreds, and you need to test all of them. So that basically went out of hands. They started with having a kind of script, and so this is not, this is more how you configure, put things together, rather than make every individual part work differently. For example, you may have a hardware thing that was connected to one pin on one configuration, but another setup was the same software, same hardware, but another pin. So you have to have parameters that is not related to the functionality as such, but from the hardware guy's side rather than the software guy's side. So all of that comes together, and they try to in the first round, they try to make it in different files. So they described these parameters for each build. But that quickly went, after a few hundred of these, and they have to try to get them in sync, it was sort of, they decided, well, we should have all of it in one file so we have overview. And when I got one of, and this is proprietary, so they didn't, I was looking from the side and tried to help them in one way or the other. I got my hands on one that was 5 years old. When I got it, it was 5,000 pages. And it was all repeated. And it was absolutely no way I got any kind of overview. So at one point, they were behind, and they have to switch to Android. And I don't remember how many years back that was, then that was panic. So they quickly have to do that move. And they said, we don't want that scrap. I mean, so the 5,000 pages were at least 5 years more development into it, so it couldn't be printed anymore. And nobody knew, I mean, all of it. I mean, the idea was that when you make a new model, you would take the old configuration and change whatever needed to be changed. And the things you didn't understand, you just left there. So it was, I mean, so they decided that, okay, when they started with Android development, they would not do the same mistake again. So they would put the configuration in the code. So then they had no, no way of finding, well, in principle, yes, but in reality, they had no way of finding where is the configuration anymore. And you know where they ended up. Yeah.
So you have your own experience with the complexity.
Yeah. So they only did one circle, but so I think this is most of the talks here, and I'm new to this crowd, have been focusing on what I understand, software. I mean, how do you instrument software, how you configure software as such. But if you take the hardware concepts into it as well, then perhaps the difference between code and configuration is clearer, because we don't really mind the hardware, so to speak. We just have to interface with it when you do that kind of gadgets or tools like cars and mobile phones. But that, so there is a clear view of what is a configuration, whether that thing is needed or not in this version of the product, so to speak. But there are also parameters burned away. But maybe, I don't know if any of you here or have looked into that kind of complexity or that kind of, well, yeah, some of you. So I think that
it's actually a common problem. It's not a problem which is only with hardware. It's every time you're trying to drop your code into an environment. Like the typical approach right now we're just describing the environment in the config file. Everything is great. What can go wrong? And then the environment changes and no one knows what's happening. And the code is not aware about this as well. So the radical idea is to write the code like a gas. So the environment is given and code is just working in the environment. And if you don't support this environment, the code doesn't work, and throw the exception. So for example, any model which, any code which is supposed to work in the cluster management tools or like your containerized software, etc. So like, what is my port? Where should I connect? Everything is being provided by the config. But what is actually will be other way around. The environment will tell the code, hey, this is your endpoints. Go connect to them if you want to. Or this is how much memory you have. And then the code can actually decide, okay, I cannot work when I have less than 10 gigabytes of RAM. So that's kind of inversion of control which solves this problem that you need to define 1 million parameters for your environment. The environment tells your code how to talk to it.
I mean, I find that is a very interesting idea, but I'm wondering whether it's really solving the problem or just moving the problem, because now you don't have to configure anymore the software to match the environment, but someone still has to provision the environment, so you just move the responsibility. Perhaps you reduce the duplication, but still someone has to come up with this configuration of the environment.
Yeah, it's actually it's totally partly moving it. It is a reasonable strategy to sort of like there's this no configuration mantra, but this is only solving for one part of configuration, right? Like you have also so configuration is also policy. So another department saying like, yeah, sure, you have developed a server this way, but you cannot store this in this region or whatever, right? And that's inherently another, there's another team that's determining that, right? And you have to bring this knowledge also together. Yeah, no? All right.
Yeah, so talking about validation, so in my understanding, we can think of configuration like a compilation process where you write your configuration in some configuration language that has some abstractions, and in the end you produce the ground values that will be used by the program or the software or anything you want to interface with. And so maybe when we think about configuration, we're thinking about what is this transformation and the relations between how can we express the language and how can we express the values and how they are processed in the end.
It's a very interesting point, because that's something I agree that when you develop in a config language, it's really more like compiling than evaluating, because you touch the code each time, you evaluate on like fixed inputs, you get a result, and when you want to change it, you have to change the code again. That's the whole point of configuration, and that's why configuration can grow to language and be interpreted / compiled by I don't know, Terraform or whatever. So I think that's a very fair point. Yes, Alex.
So it's back to the discussion: what is config? Is it config? Is it code? Is it data? What is it?
My next talk will go that.
Okay.
I guess that's a hard question that we try to define. There's a notion of, it's a cross-cutting concern also. I think that was a point that was routed, that's something that is not local to one code, but that impact your server implementation, your database, and that's why it's so hard to manage and to prevent failures, as opposed to nice functions, localized that you can type or whatever. But that's a very difficult question, and especially with modern tools, the delimitation is blurry. Should we call something like HCL configuration when it's almost now a proper language? That's good questions. Yeah.
One aspect, configuration can also be dynamic if you include like admission control as part of configuration. So if you really want to analyze programs, so basically what I'm saying, if you really want to analyze programs pre-deployment, there's dynamic components to it as also.
Is it a database?
Not necessarily. Yeah.
So we're almost at the end. If someone had a question that they couldn't ask, maybe now is the time. I think I have one for David. Like the thing with LLM is that often they hallucinate some results. For example, I use Copilot, and on medium-sized code base, in Rust, sometimes they just suggest methods that don't exist, although it looks like they could exist. And it's a bit frustrating because this stupid LSP could see that right away, but this fancy LLM couldn't. And so when I saw your talk, we have someone at Twig who work on liquid Haskell, which is like refinement types. So you annotate your code with precondition or postcondition, but it's not part of the language. It's commands, so you can just ignore them, but then there is an additional checkers that can run and try to prove the things automatically. And I just wonder if maybe the two could go together, because a proof assistant or a model checker is something that is very strict. So you can check that what the LLM spits is not totally stupid. And maybe that's also a bit about justifying configuration, but I don't know if you've thought about or you've imagined like trying to generate the precondition with an LLM and then putting that into a model checker or something like that.
So I hadn't thought about generating preconditions specifically, but I have heard talk about using the compiler to help with the hallucinations. Let's not respond with something in whatever LLM you use if we can prove it doesn't exist beforehand.
Okay, so it's time for coffee. See you in half an hour.
meet you in person. Hello.
Command F1? Yeah, I think that's how you change display settings. Does anybody know this?
Oh, there we go.
No, it's not. Not working? It's not working. That's why I wanted to do this earlier, not tonight.
Can you present it from Google Slides?
It is Google Slides, but it's going to the wrong screen.
You can choose it when you can, yeah, there is a drop down. There is a drop down on the present.
Present where? Can somebody help me maybe?
On slideshow, there is a drop down on the right, and you can pick which monitor you display.
New
PDF.
We got the PDF. I lost everything.
Oh, there's a camera here. Okay. I didn't realize. Okay. All right. Let's do this. Okay.
No, I lost my window.
I think it only works if you actually plug it in, otherwise it will blow off the screen.
Yeah, but let me first find my window.
You want to present from Safari?
No, I want to present from Chrome. My Chrome window is gone.
Yeah. Because I think the drop down is only in Chrome, right? So
You need to get to your screen connected.
I know, but let me find my window now. Because I had to close them, everything's gone.
Oh no. I have also Apple.
We're recording all this,
right? Is it actually recorded or live streamed only?
That's a good question.
Sorry. Sorry, is this recorded or live streamed only? Both. Okay. All right.
you go to the screen settings and stuff.
Yeah, displays.
I didn't know how it works.
It's going to take a while. So what I want to do is...
You're updating everything.
Yeah.
Is this a config issue? You have to plug it in. Yeah, open settings.
Plugging in is a Boolean configuration.
That's Google.
But I don't want to mirror it. I want to go to the...
And then if you go to this, you can see, refresh the page.
Restart the laptop.
Turn it off again.
You might have to exit the building and come in again.
It's not available. Yeah. So what I want to do, I want to close these windows, all temporary full screens, so there's only one left.
All right, this is gonna take some time.
Maybe you have to restart Chrome to get the information that you connected to the screen. Yeah.
So
That will solve this perhaps.
now all the screens are gone. Now,
Yeah, because it's on this screen. I mean, you can move it to the other screen, but you won't be able to see it.
that's okay.
Yeah. Yeah.
No,
No, it's not.
it's not showing.
I'm going to have the same trouble.
It's even worse behind the desktop.
It's just on the desktop, it doesn't, you know.
Here we go.
Can we take another computer?
I don't know.
I don't know. Maybe you should try to restart Chrome because this might you might not. I think that's why you might not see the new screen.
Oh, we saw something. Yeah. Move it again.
When you drag something
Yeah, there we go. Oh. Nice. Nope, nope.
I wanted to get rid of that bar, but it doesn't. All right. So annoying. Can I get rid of this? There we go. Good enough, huh?
No,
Yeah.
you can put full screen.
What?
No, you can put it in full screen.
No, that doesn't.
It's working well enough.
Yeah. All right, so in this...
Now I need to get my pointer back to this screen. I don't know what.
You're here.
Other side.
Ah, there we go. Yeah. Sure. That was not easy.
Okay, welcome to the second session, which is the ex-Google and Google session, basically. So we have Marcel kicking us off, who's one of the co-organizers, but he's going to talk to us about the configuration continuum. Take it away.
That's extra embarrassing being one of the organizers and not have my digital setup. Anyway, I should have used the break more, more better. Yeah, so 2 years ago I talked about Q as well, was virtual then. So there I talked about the mistakes I made at Google with the designing of GCL, and again, my sincere apologies for everybody that has to put up with that crap. But you know, like it's still used a lot at Google. It's a large language, so I guess it has its uses. So I talked about so what mistakes I made, how we address it in Q. It was a lot about sort of the model of cumulativity. So this time around, I'm going to talk about a little bit on what is configuration, right? Instead of focusing on Q too much, there will be Q examples in here. But it basically explains more about the principles of Q and like what it does and what it tries to solve and why is it important and that kind of stuff. So, so here's a tweet from Kelsey Hightower. So what's interesting about this is, we talk a lot about declarative configuration, and our mind is very often then like, oh, it's some YAML file or whatever, right? But here you can see the way he talks about it, that it's a much more operational and dynamic thing, and configuration actually encompasses much more than just a few data values, key value pairs or whatever. So let's try to see if we can find configuration in a real life system here. Some of the people that were at Darkstool already know this example. So we have here a very simple Pong server where people can send a ping request and get a Pong back. Of course, it's very important that we audit all of this, right? So there's a database with an audit trail. Then there is an open policy agent with some authentication, right? Because we don't want everybody to send ping requests, right? Like it wouldn't be good. And then we have some Terraform, like setup that can actually deploy these servers to a Google Cloud platform, right? So where do you think the configuration is? Well, very obviously, the Terraform configuration is a configuration, right? Like I think there's no dispute about that. Also, if you look at the Pong server itself, right, this is a binary that might have some configuration, some values that people might set, right? I think there's not much of a dispute there either. But where else? So let's look at the database. Of course, the database has to be set up and configured. But what about the database schema itself? Is that configuration? Well, let's assume it is for now. We can see later why this might be or why you might want to consider this as configuration. But here on the left-hand side, we see a table schema definition for this database. And on the right-hand side, we see the equivalent in Q, more or less. So you see that Q allows you to capture this schema like pretty much verbatim at what it is. There are some Q-specific things here, you don't have to worry about it, but basically this is the schema, right? So, so we have a method. That should be string 100 here, like in reality is get post, but should be string 100. Comes back later. And then there's a timestamp, which is a sort of type, right? And that's really it, just a schema. So where else is there configuration, right? So we already talked about the configuration of the server itself, but let's look in the server code. Is there maybe configuration there? So of course you can have flags. That's our obvious configuration elements that you can find in code. But we also have this Go type called audit, which is remarkably similar to the database schema you saw earlier. And if we want to encode that, so on the right-hand side, again, we have Q. And this is basically the schema in Q, how it will end up being. And you can already see there is a discrepancy between the Go schema and the database table schema because the strings are of different length, for example, right? So you see here that even though it's you know, like a data type, there is a possibility for error here if you don't you know, consider what the database schema is really like. But we're not done, right? So we also have this policy definition for OPA. It's something very, very simple, right? We just say if you have an input method, it should be get. So for the Go server, I can tell you, right? It would support both post and get. But in the policy, we say like, no, in this case, we only want maybe certain users, but in this case, all users, we only want them to be able to use the get method. So very simple. On the right-hand side, there's one way to do it in Q. There's many ways to do it in Q, but this mimics what Open Policy Agent does to the most extent. So you could say that this is actually also configuration because it puts constraints also on how the system can be used. Can be validation, can be policy. So now the writers of this, developers of this system were very nice to also publish an open API definition of their service. And if we take a look at this, you could argue this is also configuration, right? This is more at the other end of it. So we have the open API definition. And then on the right-hand side, we see the Q equivalent, basically. So one thing that's interesting here is, so in the open API, we only have the get defined here. So you see the equivalent in Q. And essentially what you can now do in Q, right? Like we could also say, okay, let's put the policy for this open API in Q rather than in, so I'll go, oops. So you can put the policy definition in Q rather than in Open API, OPA, right, like Open Policy Agent. So this is another way of putting that restriction in, right? So here you can see that sort of the domain is a bit blurry between the schemas and the APIs and the policies, right? It's all sort of like this continuum, if you will, of configuration. So. Yeah, so basically the conclusion of this here is that configuration is really everywhere, right? You have it at all kinds of different levels of abstractions. It all interacts with each other. And it's actually, you know, there are some possibilities of errors here if you don't keep this stuff in sync. So why is this important? I don't have to put much, you know, spend much time on it because a lot of the speakers already mentioned that today. We have lots of outages. So basically over 50% of the outages are configuration related typically. So one thing that's interesting to add here, what I've seen, there's a lot of research I've looked at. I've also spent some time at Google and the SRE research team looking at configuration or outages in general, but also configuration related outages. But also if you look at other research, this 50% number, 50 to 60% seems to be pretty constant. But the type of configuration outages that you see are very different. So most of them, for most of the research, it's just simple values that a server doesn't support that people specify. So at some companies, let's say at least, this is not the case, right? Like they don't have these errors almost at all, right? Like the configuration errors tend to be much more complicated. So my observation is a little bit is like you can, as a company matures more and sort of gets rid of these simple configuration errors, also the systems tend to become more complicated, so also the configuration errors tend to become more complicated. But this 50% number seems to be pretty stable. Yeah, so in general, this is also addressed in other talks today, right? Like the testing of configuration is quite important, right? And it's often sort of neglected compared to testing for software. So what can we do about this, these outages? Well, again, validating, testing, typing. So policy enforcement is a tricky one, right? Because policy enforcement often has a dynamic element to it. So this is often used as an argument, we cannot do anything about this pre-deployment, right? But really what you want to do is you want to, this is also was a point in my last talk, but you want to fail as early as possible, and the popular term for that nowadays, I'm sure this will fly over again, but it's shifting left, right? So you want to fail as early as possible. And the argument for policy is because it's dynamic, you can't, but we really think you can. Actually, you can do that. You just need to think a bit differently about it and structure it a bit differently. So one thing that makes this more complicated is that configuration is a cross-cutting concern, right? So what you see is that with most engineering, you have like these components and you build this in this pyramid fashion. You build smaller components, you build larger components from these smaller components. So in configuration, it doesn't really work like that, right? Like you have different departments that all have their opinion on what this configuration should be. It comes in from all these different angles, and there's no real natural order or layering to this configuration. So if you try to impose this natural ordering, you get this combinatorial explosion for no particular reason, and it just makes things harder, right? So, and then the other thing is these different levels of abstractions, right? So if you really treat policy and schema and data all as something different, you can make your life quite a bit harder. So what do I mean with levels of abstraction? So here I see a hierarchy, which we call the Q continuum, with types, API, policy, validation, templates, data. These are all different aspects and different angles of configuration. I'm sure there's much more. You can come up with tons more names, but this is sort of a ordering, arguably in order of increasing specificity going down. That is not the reality, though. The reality is more like this, right? So it's often very unclear what exactly is policy. I mean, maybe if you write things in Rego, it's very clear this is policy, right? But very often, if you then look, and I've seen similar things in GCL, for example, if you look at assertions versus the templating, very often that contains the same data. So there's a lot of overlap between templating and policy or validation, for example. To give you one concrete example of this, so here we have, let's say a little configuration that, or template, you could say, right? Let's say A must be an integer, B is A plus 10, right? So what is this? Is this validation or is this a templating, right? You could say it's a template because if people specify A, you automatically compute B. But you can also say it's validation, right? Like if A is specified, then B must be A plus 10. Right, so it can be both. If people specify both A and B, then all of a sudden it turns into validation. So here you can see it really goes in both directions. And this is so Q is not something unique and new. This is like a 30-year-old technology where it was used in natural language processing. And the key element which they mentioned, what is the nice property of this graph unification is that constraints are templates, right? And you can really use them in any direction you want. That's a nice property. So one element of this cross-cutting aspect of configuration is that you really want order independence, right? Like you really don't want to get this combinatorial explosion by having to apply order to all these different aspects. So having something that's commutative is quite important. And this is where you see that traditional software engineering really departs a bit from what we call configuration engineering, if you will. Because like inheritance and overrides is something that's quite common in software, but we think it's really a bad idea to do this in configuration. Hey, get down. Oops. So what is Q? So Q basically addresses this by introducing this lattice-based model of configuration, right? So we have types R values. Basically, it doesn't really distinguish it. It's very fluid between the two. All configuration is defined in a partial order, which is a lattice. It's constraint-based. It's a constraint-based language, essentially. It's also aspect-oriented. I'll come back to that later. It's very composable, right? Like this was, when we did GCL and for some bad reason decided not to use unification in the beginning, it's like, well, but it still needs to be composable. I really don't know how to make things composable without using unification, quite frankly. But yeah, because we use unification, it is a composable, and you know, by some definition of composable. So of course, so like where it is commutative and associative and idempotent. Q is also a propagator network. If anybody's interested in computation models, but that's sort of the wrong conference here. So here's a nice, this makes it a little bit more concrete about the Q continuum. So at the top we have a type, at the bottom we have a piece of data, in the middle you have something that is somewhat in between, right? So this is like a short visualization of Q. So this is at the structural level. Here you see it for specific values, right? Like you can have string number, but you can also have regular expressions and all this kind of stuff. And this is all ordered in this lattice. So numbers are arbitrary precision decimals. That's another big problem we did with GCL. Like don't use 64-bit integers because you will actually run out in describing things. And also it's floating point. Let's not even talk about that, right? Already mentioned that. So how does this all look like in Q? So how would you actually express the different aspects in Q, right? How do you model this? How do you even think about bringing all these different pieces together? So one idea in Q is that you say like, well, every aspect of configuration, whether it's a tiny little element or like, you know, some schema, it all has like this place in this namespace, right? Everything has an address, if you will. And then once everything has a place in the configuration space, you can just use you know, your standard aspect-oriented programming techniques to assign things in place based on patterns and stuff like that. So here you have an example of a very simple service. We have a ping and pong and any combination of environments, production and development. And we have a deployment and a service. This is modeled after Kubernetes, but it could be anything. It's just some permutation of a bunch of variables, and you have all these different configurations, right? So let's say we now want to set the Pong deployment in production, right? So the address that you see is up there, right? Like it's msprot deployments Pong, and then we have some arbitrary set of values that we want to set at that location. But what if we now want to set both production and development, right? So here we see this is like a Q annotation for wildcard in the second position. So this say for any production and environment, or for any environment, so production and development, we want to set something for the Pong deployment, right? So basically you have this pattern matching for selecting you know, elements within this tree, you know, often more than one. So here you have two wildcards, right? Let's say we want to say something about deployments in general, no matter what it is. Like maybe we want to say, you know, you have to monitor or whatever, enforce certain monitoring policies. Then the SRE team that is responsible for monitoring says, like anybody here that launches some deployments, we want them to set some monitoring. And you could specify it like that, right? It's just a matter of setting the wildcard. So basically another way I sometimes say you can think about it is, if you have JSON, which is a tree of values, if you will, you can think of it as a sequence of path value pairs. And then you can generalize the values into types, and then you can also generalize the paths into pattern matching within the tree, basically. So back to our example, right? So we've now shown how Q can basically, how you can compose all these different aspects together in this single space. But the example had no Q, right? It was all like Go and database tables and all these kind of things. So like, okay, great, right? Like, do we have to move everything to Q? So, right, the idea is that Q can serve as this sort of interlingua, sort of this intermediate representation for all the configuration space. This, of course, is a lot of work, right? We have a bunch of these adapters. It's sort of depicted here, what we plan to do, what we have done. So Q is basically data lock equivalent. So it should be quite straightforward to look at the holes in the configuration, convert it to SQL, all these kind of things. So it makes integration quite feasible. Rego is essentially data lock. So one nice thing you see, if you picture this continuum where you have all these different types of configuration, you see that policy was sort of at the center of it. So policy is really the aspect of configuration where they most sort of grapple with needs to combine from different cases, and there's overlap. So you see that in the policy language world, almost all of them are logical programming languages, right? Because there you can really see you benefit from that the most. But we argue it should actually be logical programming across the spectrum. So how can you then do this with Q? You can basically put Q in the middle, right? Like you can basically suck out or extract all these information you have in all these different things. You have adapters for Go, you have adapters for all these other things, right? Terraform is essentially JSON. You can suck it in and then basically put it in this single bin, right, based on the namespace and see, does this validate, right? Are there any inconsistencies? So we use the order independence here to just dump it all in. So a little bit about the Q community. So Q, we talked about configuration now, but it's really used for many other things. That's probably the largest use case is composable workflows, which if you squint very hard, or especially with the definition for configuration I gave here, is just configuration. So ML pipelines, API generation, that's where Istio uses it for. So they get all these different aspects, validations from different parts, and then combine it together and output. It's a little bit less elaborate than what I make it seem now, but then output APIs. Somebody also encoded the US text code in Q. And the reason there was also the logic programming aspect of it, that you can, you never know how you want to use it. So sometimes you want to input this, sometimes you want to input that, and then you can just pivot around it, and you have, you can create a library for however you want it. I don't know if they also implemented AMT. That would be tedious, but for the Americans here. So these are some of the users. It's actually an old slide, or there are a bunch more now. This is the team. So like Daniel, Roger, and Paul, they have been working on modules, like having creating a nice module to allow for a nice module ecosystem. Aram and I are here at the conference, so if you have any questions related to Q, please come ask. And then there's Dominic. He's off right now, so not able to answer questions. I don't know if any time left. I think I spent 5 minutes on the 10 minutes on the slide setting up. But.
Let's thank Marcel. I think we have time for 1 or 2 questions. We can eat into our Q&A in the end, right?
Hello, my name's Savita, and I'm a first-year graduate student. But I was wondering, with the whole Q system and the spectrum and that, do you see refinement types ever playing a role in how you look at the continuum? Because you can kind of have a constraint and a type all in one there. So I was just curious if you.
I have not looked into that, but I would.
Okay.
Happy to, or Aram did, okay, there we go.
Yeah, so refinement types are an interesting alternative. The thing is, our type system is actually far more related to set theory than type theory. And we think that programmers and engineers kind of understand, it's set theory plus first order logic, which is something that most people understand as opposed to something like refinement types. And when we introduce refinement types, they're very different sort of strategies that we have to provide. We have to have a termination algorithm for type checking, basically. So we introduce refinement types. Depending on the specific refinement types, solve all kinds of questions that can be answered. And we also are interested in producing useful errors to the programmers, which is something I think refinement types kind of lack when they have a type error.
If I can just one thing on this matter, in fact, I think you do validation, right, more than type checking. I mean, it's blurry, but in configuration, you often want to do validation because it's just sufficient and much more easier. And in fact, runtime validation with predicates, it's just pure managed refinement types. It's the same. I mean, you have the same expressivity, but it's way easier to write and to handle. And my question was related to policy, because you talk a lot about policies in Qtools, and from a distance, it seems like if you can do it on the code, it's not very different from validations. How do you differentiate it? Is it a notion of locality versus?
Basically, it's quite a blurry distinction, right? So one sort of aspect of this is that you can say, so validation. you know, if it really pertains to that API in general, is usually made by the team that sets up the server, whereas policy is really something that's done cross-organizationally. Like there's another team that decides like these users cannot access this, or like if you show it in this country, you're not allowed to show this element, or basically something that's defined outside of the team. But it really is a blurry thing. And also if you look at admission control, there's often a dynamic aspect because you have like roles and all these things that change behind the scene, right? It's not really static configuration. And you see also if you look at system initiative and then also we hear it from a lot of users from Q. It's like, yeah, this is all nice, right? Like this Git base, but configuration is not static all the time, right? Like you need to have this dynamic component. So policy also tends to get more dynamic, but it's very, very blurry. Yeah.
Okay, thanks.
Alex, can you, where is it? Yes. You can set up. In the meantime, if there's any last question for Marcel? Okay. There's one in the back, right? Okay, no? Okay, then go ahead.
I think it's related to your last answer, and I wonder if Q has anything to talk about those kind of runtime values, because with Nickel we've made some proof of concept used for Terraform, but the thing is that Terraform has actually two languages, right? There is a static one, and then there's the things that you can do on computed values that are not known when the program runs, and so it's a bit annoying because then you cannot use normal, I guess, Q interpolation or something like that. You have to encode that and then AST. Yeah, so I wonder if Q has any way to handle those kind of only known later values.
So we do use this commutative, let me put my laptop down. The commutative nature here, right? So there's several models. So one of them is this Q tooling layer, right? Where you say you can evaluate Q, and then you have processes on the side that basically read values and fill it in and make it increasingly more specific. And there's this thing called tools flow, which basically can analyze, okay, where are the holes in the configuration, where it's fully concrete, then we can run these processes and just keeps filling out. But this happens outside of Q, right? But it uses this property that it's commutative. We do want to make it a bit more principled by introducing function signatures, not functions, but just the signatures, so you can be very explicit about the data flow.
Because what I want to do usually is, like, for example, I want to access the first. If you want to access the first byte of an IP and you're using another language in front of Terraform, you cannot really do that because, I mean, that won't work, right? You cannot compute the first byte of your IP in your front-end language. So somehow you have to do that symbolically and then produce a JSON that actually Terraform can do a Terraform interpolation inside the JSON. But yeah, my question was around, is there any mechanism to do those kind of symbolic computations that, when you export to YAML is not yet computed, so to speak?
So I'm not what? Oh, yeah,
I mean, I think a good model is to think as Q being symbolic by default, and if you have a concrete value for symbols, then you get a concrete computation, otherwise you get a symbolic computation, and this is completely fluid. And if you only know about something that's symbolic, you can always use the computable part of it. So come to your example now. You said something about IP values. Now in Q, IP values are just a string with the predicate that validates it. But you can imagine there being some sort of other representation of IP values where you, for example, have the first byte. You can and you don't know the other bytes, for example. You can definitely compute on that. So you don't even have to extract it or anything like that. You can just refer it directly. As long as something is known, it can be used. If that makes sense.
Yeah, thanks. Something I was thinking about, but we don't have right now. But yeah, just kind of, I mean, to have a notion of different computations on which you can do computations, but you just keep the AST, basically push the operation inside.
Yeah, I mean, in Q they're just holes, right? Like there's no need for...
It's different. I think it's different because, I mean, the stage that when you evaluate the program in Nickel or in Q, the holes are feared, right? If you need to produce a YAML, your holes are feared. But this is different because you need to produce the symbol, hole, and then you are...
Okay, let's move the discussion for later. I guess there's a lot going on here. But at this time, let's welcome Alex. He's going to talk about LSP in configuration languages and how we can support developers in using configurations. Take it away.
Yeah, awesome. Yeah, so this is a talk on utilizing the language server protocol to inform and teach users about configuration languages. And I'm Alex, and I work at Google, and I work at Google on the GCL team, the language that everyone has been talking down, which I will talk down also, so don't worry. Yeah. Yeah, so let's just start off by going over what the LSP is. The LSP is Microsoft's language server protocol. It defines the protocol that that's used between a text editor or an IDE and a language server. And a language server defines the semantic features of a language, such as go-to definition, what is available for autocomplete, and find all references, and some others that we will cover later. There's like at least like 20 or more LSP methods that you can implement to do a lot of different things. And the reason to use an LSP is because almost all modern IDEs and text editors support it, and that's where most of your users or all users in general are editing files nowadays. And it's not just Visual Studio or VS Code or IntelliJ. It's also Emacs and Vim have extensions and plugins to support them. And another reason that you should do this is you don't have to write front-end code for like extensions on or plugins and stuff for IDEs, as us language developers don't like to do that kind of stuff. Yeah, so I will go over the GCL language a little bit. We've heard the horror stories, but now we will see some of the actual code. So the GCL language is a Google internal language, and that will be important for later. But it is declarative and dynamic, and what that means is like what you see usually is what you get at the end. It's not like you're calling a main function and that's going piece by piece. There's a lot, like GCL is one of the most used languages at Google. I'm not sure if I'm allowed to say that, but it is, and the reason is that it does a lot of different things. And the way that it can do a lot of different things is that there are a lot of different versions of the language. So you might be writing in 5 different versions of the language in your day-to-day job, and you might not necessarily even know that you're writing all of them are like at the base of it, GCL. And importantly, it's almost no one's main language. Like no one is sitting there every day writing GCL. They write GCL when they have to write GCL, and when they're told to write GCL, or when something breaks and they have to change the GCL file. And so similar to most configuration languages, developers occasionally use the language. It has drastically different paradigms from their normal, like everyday languages. And how the GCL file is evaluated or used is almost exclusively defined outside of the file. Like nothing here is saying how these values are used in an actual program that's using the configuration. Oh, I forgot one of the last bullet, but I talked about it, so that's what is important. All right, so how are we using the LSP for GCL users to help GCL users better use and understand the language? So one of the big issues with GCL, of many, is that GCL doesn't really have a type system. I mean, it has a lot of different type systems, but it doesn't have like one real type system. GCL has like 3 really popular type systems, and then for like the hundreds or multiple hundreds of dialects, a lot of them have their own little type systems as well. And so as a user editing a GCL file, if you're writing in one dialect, that's why you might not know that 2 different dialects are both GCLs, that like they're evaluated differently a lot of the times because the type systems for those dialects are very different. The type system is not visible to the user. Like the user will not see types. It's usually defined in the interpreter, where like the two different parts of the interpreter that are supposed to do the same thing will do different things. So like if you use the code in one way, in a different way, the type system is different. And then a lot of the type system is done on output post-processing, like when you get the output of the configuration. And generally, users rely on tutorials or documentation to write their file or to edit their GCL file, because none of the type information is in the file itself. And what this really means is that users copy and paste all their code because they have no clue what it does. And they have no clue how to write a file. Yeah, so that's a lot to try to fix. So the real way to fix it is to add a real type system to GCL. And that is a goal we have, but that's probably going to take 10 years or more. And obviously, we want to integrate that into the IDE. But in the meantime, as was mentioned earlier, we want to shift left. We want to move the hidden semantics of the language and the multitude of dialects into the IDE so that the user understands what's happening as they're editing, like in the way that they actually use the code or interact with the code. And the way that we want to do that to start is by providing the shape of the configuration that they're expected to output where they're actually writing it, and provide the documentation for the things that they're trying to write. Let's see this. Oh, okay, actually, this is a good thing. So this is not a real GCL dialect. I had to write a fake one, so if it looks really like not good, it doesn't make any sense, that's why. But yeah, so we are opening a GCL file. We are told to edit a front-end service. But when we just open it, like, we don't necessarily know what any of this does. Like, it's long, like this is a small GCL file comparatively to most, and it doesn't expand to the right like most do. So we're editing the GPU of this front-end service, and we're told to increase the memory of the GPU. And we get there and we're like, 2. What does 2 mean? 2 doesn't mean anything. And so we're like, I guess we want to increase it, so let's go to 5. Like, is this a percent? Is this like a multiplier? Like, sure, let's just try that and see what happens, right? And see what happens is not a good thing for configuration. And so what that really means is people are going to have to like look up documentation. If it exists, it usually does not. They're going to have to ask around, because that's how things generally are defined, as word of mouth. Or they just don't look it up and they just fill something in. And so if we look at the same file with some like semantic features embedded into the LSP methods, it's a little improved. So as we open this file now, we can see these things that are underlined. The underlined words are document links for the LSP. And what that means is that if you control-click on the underlined part, it will either take you to a portion of code or it will take you to an external link. And so the reason we are using this method is that it brings users to the attention that there exists documentation for these fields that they can read about and like to help them understand the things that they're doing. So if we're going to do the same thing that we did in the last thing, change the GPU requirement of the front-end service, we go down to the front-end service. I don't know if it shows it there, but we're in the front-end service. We go down to GPU, and if we want to read about what the GPU values are doing, we now have a link we can go to. I wasn't going to create a fake website, so it doesn't go anywhere. But also, if we hover over the field itself, now we're provided the field information of that. And so we now know that the 2 means 2 gigabytes. And we're like, okay, I know what 2 gigabytes is. And like 3 gigabytes sounds reasonable. So we're going to increase it to 3. And this is a pretty simple example. but let's say we are also told to add CPU requirements. Under GPU, one might expect CPU to exist. So we press enter, and now we're provided the expected fields that were expected to output for the configuration in this file. And so we know that CPU is a thing. So we can enter on CPU on the suggested field, and we're suggested now the subfields of that shape that we're expected to fill in. And as you can see, it also now provides the information about the field on the right-hand side. So the, whatever that field is, I can't read it. It's an integer, but it told us that it only takes 1, 2, 3, or 4. Now that could be embedded in other parts of the language, but it's important to have it in the documentation as well. And we go to the same thing that we had for GPU, right? Minimum memory or something memory. But this time it said it was in kilobytes. So we're going to do 128,000, I think, kilobytes, which is 128 megabytes. And to us now, we understand the difference between those two numbers, the 2 or the 3 and the, oh, that disappeared really quickly. Oh God, is this going to work? Go. We understand the difference between these two numbers, and when another user comes into this file later to edit it, they'll be able to understand the contextual difference between those two numbers also, because they can hover over and see, oh, this one's kilobytes and the other one's gigabytes. It makes sense why one's much different than the other. Yeah, so what we're trying to do with this is reduce the ambiguity in how users fill in their configuration. We want to remove the ability for them to do things that they shouldn't do by only suggesting things that we know that they should do. And from this, we hope to reduce outages from misunderstandings, like that gigabytes versus kilobytes, and stuff like that. That's where a lot of configuration issues come about from. And we want to also reduce the time spent learning how to read and write the languages or the different dialects, because that's like, we want to improve, we want to reduce the time that people spend in these languages because it's not their main job. And so we don't want them to have to spend a whole day reading the documentation for this, the new dialect that they're trying to use. And this also provides the dialect owners the ability to have more control over how users use their dialect in the editor by providing these this automated way of showing them the type system information in the file. Because we generate it from the actual dialect implementations themselves. Like, we don't want to have, like as someone mentioned earlier, you don't want to have the two sources of truth because they could go out of sync. So we generate all this information from the source of truth itself, and then it's reflected to them in the IDE. And for how it has improved users' experience, we have noticed since implementing and pushing this to our users, we can see how all of our users interact with this because all of the users of this language are in Google. So this is one of the nice things about it. We can see that hovers went up 50% when we implemented the semantic assistance, which is like the doc links and stuff like that. And autocomplete acceptances went up by 30%, which leads one to believe that these are helpful suggestions to the users and helpful information that we're providing. And after using them for certain dialects, users started pouring in requests for additional dialects that they use to have support in this system. Another issue that GCL has that I mentioned earlier is that it is a dynamically scoped language, which is bad. If you don't know, lexically scoped is the way to go. Here's an example of the dynamic scoping. In the return field, the helper, when it tries to output return.info and it calls helper, you can see above that helper calls something called base website, a reference-based website. Base website is not lexically available to helper. But when it's called from the return object, a base website does exist there, so it knows like dynamically it is available. This is bad. We don't want users to use this. We want to disable all dynamic scoping for GCL, which is not possible currently. But we want all future code to not have dynamic scoping. And so by just implementing the LSP methods for lexically scoped values, we push users to actually like write lexically scoped code. Like if we're trying to write the same function that we saw before, we go here, base website is not available to us in the lexical scoping. And so we're like, oh, maybe we shouldn't use base website. So now we know we need to have some base URL that exists in the lexical scope that we can then append to. And now this, the autocomplete shows us the lexically scoped value, and we're like, okay, that works. But base URL is empty, and we want to put something into the base URL, and we know we need to do that when we call helper. And so this is going really quickly. And so when we fill in base URL, we now are suggested the lexically scoped base website from that tuple. And so now, after using the LSP features, we push the user to write better lexically scoped code and go away from the bad things. Yeah. And so the results, it's hard to get user sentiment on this because we don't know if they would have written bad code previously before they submit good code. But we do know that like go-to definition use skyrocketed after we enabled it. And we only provide lexically scoped go-to definitions. And we also had autocomplete of references be used much more higher than we expected, which also implies that people are using lexical scoping more often, hopefully. And in conclusion, the LSP can be useful for many things, especially for configuration, because a lot of things exist outside of the file itself for configuration languages. And so moving that information into the editing experience, we have seen to be a positive experience, a positive improvement for users, and a way to test new versions of language features that we want to add, like the type system stuff. Yeah, and of course restrict the bad parts of the language that we hope to eventually remove and cut away. Yeah, and that is it. Thank you so much.
Thank you, Alex. Okay, we have the first question already. There we go. Marcus, you want to set up?
Do you do anything for telling users about provenance of values, like where they come from, if default values have been overridden, all these kind of things?
Yes, we can give them the provenance if it is not a default value, if it's been set somewhere else. We can take them to the original field that it was set from. We haven't, like, default values are a thing that we want to do in the future. Oh, sorry. But we haven't gotten to that part yet. No.
Hi. Yeah, that's very cool features. The examples that you showed, they showed like LSP features that most of us, I guess, saw in other languages already, like the IntelliSense stuff, for example. But recently, especially, there has been like tons of ideas and extension requests for LSP for fancy visualizations like trees, graphs, whatnot. Are you also thinking into some of the new stuff, some of these complex visualizations to leverage these for GCL?
Yeah, we have been trying to, like, debugging of a configuration language can be really difficult, right? And so we've been trying to move a version of our debugger into the IDE experience via some of these new things, because we don't really work, the GCL language, it wouldn't work with like a
Nice talk. I guess if you were to consider refactors based off of, so if you take your dynamic scoping example and you have the information that says this variable is not in scope, kind of suggesting a refactor to code written like that, would that be something that is still within the LSP, and is that something you've considered, or would that require like an extension?
Yeah, so there's another issue there that this is a basic example of dynamic scoping. The bigger issue is if there was a variable that was lexically scoped, but there's a closer definition that's dynamically scoped. At runtime, it'll use the dynamically scoped value and not the lexically scoped value. And so that's where it really becomes an issue. But yeah, like that's the thing that stops us from being able to use the refactoring tools and stuff like that, is because of the dynamic scoping.
Yes, thanks for. I think that's a very valuable addition, because you can add all kind of fancy type system or have something like Haskell, but if the only error you get is something is wrong, you cannot. So I think this is much more valuable than some other more fancy stuff. I wonder, one interesting thing I think with a language like Q or Nickel or DAL that tries to be the lingua franca of configuration is that what it brings is you have only one LSP, and somehow it is configurable or extendable thanks to types and contracts and whatnot. So you said that you extracted the thing from dialect definitions. Is a dialect specific to one application, or is there a lot of, I mean, if I want to write my new service and it has like custom configuration fields, how hard it is to write some kind of specification for the LSP to action?
So we, like, to allow for the different ways that dialects are implemented, like I created like a API where they just have to define like a basic schema of how types are evaluated in the dialect, and then automatically fills in all the LSP methods for them after they implement like the 2 or 3 methods of the API. Yeah, and then but no one does that, so I actually write all the definitions for each of the dialects, but you know.
All right, thank Alex again. Now we have the last talk in the session, another Google talk. And Mark is going to talk to us about language evolution. Very exciting.
Thank you. You're all my hostages before lunch, so I hope you're paying attention. Otherwise, I won't give you lunch tickets. So thanks for coming. You all came particularly to my talk, I hope. And I'm going to talk about how we at Google, we started with a configuration language. We had its challenges, and we've been able to very gradually improve on some of the aspects and doing it in place. Right, so a little bit quick overview about GCL. I'm not going to dive into the language. Other folks in the workshop will go into more details. It's a declarative functional language, and it's used to generate protocol buffers. The schema, the dialects that Alex was talking about, most of the time they're a protocol buffer definition. There are ways to augment that and provide additional information, but most users don't. It was created in 2003, so 20 years this year. Yay, happy birthday. And the first couple of years, because the usage was relatively low, they were able to roll out a number of significant changes to the language itself. Its usage grew very quickly, and very soon it became impossible to change. For folks who are, some folks might have already seen this XKCD, where a user is complaining that the developers broke their workflow because they've stopped the CPU from overheating when the spacebar was held down. So no matter what your language or system does, some people are depending on that for their workflow, often in critical ways. Same for GCL. There were a bunch of things that the maintainers deemed as misfeatures, but users are either depending on that particular behavior or had worked around it. So if you fix the bug, their workaround would stop working and their system would start misbehaving. So if we wanted to change how it behaved, we would have to coordinate with every single user who was depending on any particular behavior. And that very quickly becomes intractable. So there were a bunch of things that people wanted to change to improve in GCL. Many attempts were made. Some were new configuration languages. Others were systems that targeted particular use cases of GCL. They all basically failed. And some of the two I wanted to highlight here are languages. One had better semantics, but with different syntax. They weren't able to figure out how to roll it out. The other one was better semantics, but they kept the same syntax. If we don't change the syntax of the language at all, surely we can make a change to how it behaves, right? Right, everyone? That also didn't work. Basically, it came down to they were better, but not better enough to justify all the costs of migration. To break it down a little bit, how we sort of rationalized what didn't work versus what worked in very small text. If you want to change GCL in this case, or for most systems, most configuration or programming languages, to a different one, you have to rewrite all the code that's necessary to rewrite. If you change the syntax, you have to rewrite a lot. If you don't change the syntax, you have to figure out very specific changes that are even subtler to detect to behave under the new language, under the new changes. This is very expensive to do manually, but sometimes it can be automated. So, but those first few attempts weren't able to solve this problem. Second, you have to rewrite all the tools that work with the code. The systems that take the configuration and do a push to production, or change the user permissions, whatever it is. You have to rewrite all those tools that work with those. So a lot harder, but often you can find those. There's ideally a countable number of APIs that you provide to your users, and you can find a user rolling out your change can find all those cases and say, oh, this was running the program in version 1, now run it in version 2. A lot harder to do, a lot harder to coordinate, but still, okay. We can still see the top of the mountain that we have to climb. The third one, even more challenging, and if we had a solution for this, we should use it for better applications and changing configuration languages. You have to rewire everybody's brain. If you change from an old system to a new system, everybody has accumulated knowledge about how to interact with that old system. And if in the new system the knowledge doesn't carry over, that's often a cost that most people are not willing to pay. So how do you solve for those when you're trying to make an improvement? Then there's other things that I included about how to make it easier. You have to need a way to verify that a change is correct. Not all the uses of configuration we had that out of the box. For some of the, this is going to be a dexterity check on me. If I can click on that button, yes. Thank you. So not all the systems that we wanted to change had that ability, but we were able to add it. At the time when those two attempts to change to replace GCL were created, those weren't available, so that was a significant barrier to making any improvements. And finally, you need to be able to do it incrementally. If you have open source, if you're open source and have users in different companies, not all of them are going to be migrate at the same time, obviously. Google, we have the mono repo, and we have many teams using the language in different parts of the company, and they work under different constraints, so they don't want to all deploy your new version as soon as the bits are ready from the oven. You need to be able to control the rollout, and in case something happens, you want to provide a mechanism for them to revert back to the old behavior. So these 5 problems were not solved for those earlier attempts. And additionally, so that's why they failed. But we still felt that there were improvements that we could be made to the ecosystem, to the configuration ecosystem, by changing the language, changing the tools available, that made it work for us to keep exploring. So number 1, GCL, some programs in GCL were so large, needed so much memory, so much CPU, you couldn't buy a workstation with a motherboard that accepted enough RAM chips to run the program. And sure, you could plug in a bigger disk, but still, the limit of that, you pass it and you hit a productivity barrier way before that, right? So that was one problem. Another one was complex semantics that people have been kicking the dead horse for a while already in this workshop. We thought we could make them better. And the third, for reasons, the earlier dialects of GCL used many more APIs that were available, resulting in slightly different semantics for several of those dialects. So building tools that worked with each particular dialect was impossible to do because you'd had to basically mirror all the options and all the combinations of wiring the APIs together if you were to provide, say, a debugger tool, for example. So these were the problems we were aiming to solve within the constraints from the previous slide. And our breakthrough idea, how we did this, was let's just focus on fixing the critical problems and change as little as possible. So how do we, what we arrived at is let's keep as much of the language as possible, copy all the bugs from the original implementation, reproduce the behavior, but just change the implementation and see what that would enable us to change. The result was we were able to have a much faster implementation. We call it GCL2 because numbers. It turned out to be 10 to 100 times faster, 10 to 100 times more memory efficient, just because we knew what the result was, so we could optimize and implement it in a different way. Some of the complex semantics were improved. We tried to limit that because, again, to the previous slide, change as little as possible. If you try to fix a lot of bugs at the same time, that makes it harder to track what behavior changed because of what fixed. So we tried to limit that. And we picked a few of the APIs that were available and just focused on those and ported folks over to these reduced set of APIs and built facades for a couple others and deprecated a small handful of them to sort of keep the ecosystem simpler. So why did GCL2 work? We avoided rewriting all the code as much as possible by matching the semantics of the original. We reduced the number of APIs that we had to deal with and made them compatible or wrote facades to work for some of the use cases. We avoided rewiring everybody's brain. Good. Sorry if everybody was looking for a sci-fi solution for some other problem you were having. I don't have that. We did that by the language changes that we made were focused on things that we speculated with high confidence that were not in people's mental models. So edges of the language where people rarely understand, they always have to look up or even don't look up how they work. They just say, I'll just run the program and see what happens and try to guess, to rationalize what the output was. So in those corners of the language where different features interacted, we saw as an opportunity to change the behavior. And that proved correct. We built mechanisms for verifying the result was unchanged, and that made us a way for finding, oh, this program behaves the same or behaves the same with this change, we can switch it over. And we built a mechanism to do it incrementally. We switch over that program. If it behaves correctly, it continues to use a new version. If it doesn't behave incorrectly, we made a mistaken assumption, we can revert back and then debug and analyze what the problem was. So that's why it worked. And based on that approach, we still have other things we want to improve on the language, on the ecosystem, and we're going to do it one small change at a time. From what we call GCL1 to GCL2, there were a number of differences all baked together for reasons. Now that we have a sort of a better platform to make changes on, we're doing it one change at a time, one bug fix at a time. we're focusing on simplifying the semantics of things that users find error prone, things that are easy to make mistakes with, like dynamic scoping, and adding constructs and other replacement that are easier to use. And we've used these techniques to roll out several changes in the last couple of years already. So it's actually worked out. The GCL2, for context, took us about 10 years to roll out completely. And in the past couple of years, we've rolled out like 5 to 10 smaller semantic changes. So the one remaining challenge is when there's an output difference, it's hard to tell what the cause of that difference was. You change the interpreter somewhere in the evaluation, something changed, one branch was taken that was different, and the result is now you have 10 times the RAM. You have to find what the behavior change was that resulted in the different output and track it down. That can be very hard when the programs are very large. Even when the programs are small, it can be very hard. So to flesh out a little bit more how we're doing it, because we have a mono repo, we're using what we call large-scale changes infrastructure. For anybody who hasn't read the software engineering book, I highly recommend that, and there's a particular chapter on large-scale changes that is very relevant to what we're doing. It basically has the high-level strategy about what we're doing and how we do it. We have a tool to validate each effect of a change on the whole, and we can run it on the whole repo. We have a pipeline that basically takes all the source code in the repo and applies a change, and we can use that to identify, oh, this set of programs are not affected at all by the semantic change, correction, don't appear to be affected. The evaluation path might actually change, but the result doesn't change. So if the result doesn't change, we assume that it's safe to move to the new version, and we move it and see what happens, and do that over and over again. We're prioritizing changes that simplify the semantics because analysis is hard with some of the semantics that we currently have, and we have the theory, which seems like it's on track, that if we pull out some of the complexities, the remainder will be easier to analyze. And the output, when there are output diffs, those are still hard to debug. So when we make a change to the language, we try to make a change that when the behavior changes, it produces an error. Because if you produce an error, that's often easier to track where the problem happened and what the possible, you got a value that was unexpected, and now you can say, oh, and the fix for that is out of these set of actions instead of just the output at the end change, which could be arbitrarily caused by any other change. And some language recommendations to sort of stoke the fire based on what we've learned. I don't know how this would map to the language that you folks design, but with GCL, we have a bunch of constructs that are sort of interact with each other in basically arbitrary ways. So you can't really reason about a feature based on how it's formalized. You have to say, oh, when this feature A with this feature B are used together, the result is this thing. With this other feature C, it's this other thing. And basically you have to test all the combinations. So avoid that. Make your language constructs orthogonal, easier to reason about, formalize the semantics for them. Avoid constructs that do too much. One of the more complicated ones for users is how reference resolution in GCL works. It has this combination of things, including dynamic scoping, that it basically tries to keep searching until it finds a value that works. It's kind of based on unification and with backtracking, but users, how it's implemented, find it confusing. Another tip, keep the APIs narrow. Ideally, an API that takes a full program and then returns you pure data. That's basically the basis for the validation tools that we have, and it's also the basis for the diffing tools that we offer that other folks in workshop will go over. Prefer semantics that are familiar to users. So because most users we found are not doing configuration as their day-to-day job, they rarely tend to develop expertise, and we found they would prefer to use constructs that are familiar to them. If you try to come up with something that's very novel, that might be very cool, but we found that most users will just not try to learn them. They'll copy-paste something until it works. And when it doesn't work, basically they'll often give up and try something else. So if you try to give them something that's very unfamiliar, that'll be tricky. Again, make it copy-paste friendly and write formal semantics for your language. Your future self will thank you a lot. And that's all I have.
This was the last talk in this session, so I think we can sort of transition into the whole discussion for the whole session. Maybe Marcel and Alex, if you want to come up also, so people have you in their purview. Any questions for Marcus directly?
Hi, I thought this was a really interesting talk, but I know you mentioned like you tried to work with like some of the concepts that are kind of at the edges of like your user's mental model. And like, I know this is an internal tool, so you have a better idea of what that looks like, but I guess if I was wondering if you had any thoughts about like how you can do this more empirically for something that's like a wider language, like I guess like looking at page metrics for like a certain like documentation parts or something like that.
So if you have metrics, that is obviously useful.
Yeah.
For a lot of the things that for me personally, it's very intuition based. I have very little patience for things that are hard, and that is very useful for this particular domain where people are interacting with what we call casually. They will try to figure it out quickly, and if not, just do something that works for them. So based on that rule of thumb, if you have to read 3 pages to understand what a feature does, that's probably too much. Anything beyond 3 words is risking it. So it's very intuition based. If you give me something, I'll try. You can put it up on the display, and I can empty my heart out.
Yeah, I wonder if you have any plans to add any kind of typing, validation, schema, specification, because I guess, I mean, the consumer could do that. It has some problems, but you could say, okay, that's not the job of GCL. But to circle back with the LSP thing, I think it's very useful because then you can shift left all kind of verification. And for example, I know that it's not very config language, but Luau, which is a game language developed by Lan Jeffrey, has a very sophisticated type system. But he says nobody uses it because those are mostly kids developing games. But what is really nice is that it can do very advanced type inference, for example, in the LSP. So yeah, I wonder if that's on your plate.
That is on the plate. How we're thinking about our user base is, while the end users who are writing the configurations and configuring systems don't tend to develop the expertise, there's an intermediate set of users building infrastructure, building dialects for the other users. And those can have the motivation to learn the language more deeply. So that type of construct, that type of functionality, we're aiming at those intermediate users because they have the motivation to make their systems easier to use for their own users.
To be more specific, like we want our type system to ideally, obviously, we want all the dialects to be able to just define their semantics in the type system itself.
Yeah.
Which will be very difficult. But
yeah. But I guess you don't want your user to config to write types, and I think we totally agree on that.
Our hypothesis is that's unlikely to work.
Yeah. That's a good goal.
Anyone else? So you had a point on your last slide that you sort of brushed over a little bit. I want to hear more which is the formal semantics part. Want to write down your formal semantics. Can you go a bit more in depth on that? Specifically, is this something that remains in documentation somewhere, or is this something executable in a proof system? Like, what do you have? What do you envision there?
Anything helps.
And what specifically do you see as the benefit of having that as you're going forward, evolving language?
It's the main benefit I see is sort of better documentation. Is this behavior of the interpreter a bug, or was it intentional? And if you take the time to formalize it, you can more often spot cases where the different features interact in weird ways, and proactively choose what the behavior should be on those interactions, either at the time you're designing them or later. So I didn't mention this in the talk, but for implementing DCL2, we didn't have the semantics of the language. We had the C++ implementation, which is great. But it sort of left us guessing a bunch of the time, was this the intention or is this a bug? Users find it confusing. We, reading what the behavior is, find it confusing. We can't write documentation describing in prose, this is the behavior when you use this and that together. So that was sort of, again, to our intuition that indicated that this was unlikely to be what was desired, or even if it was originally, maybe it's not what we want now, given how it's being used. So having formal semantics makes it easier to think through that.
Yeah, there's one other.
Defend yourself.
Yeah. No, well, first of all, I did start formalizing it very early on, but it was like, we're a startup, we don't have time for this. It's like, but there's another benefit from formalization is that you'll just find more like the truth, right? Like, what are the simple constructs? What are the, because by formalizing you would have seen the complexity of GCL quite quickly, but it's much harder to see if you don't have a formalization. You can just identify, get a much better feel of what's the right thing to do and what's not. Yeah, that's unfortunately. I think somebody in the New York office formalized it somewhere.
Yeah, that's one person in our team. Yeah. Yeah. Yeah.
But
they survived. It's a miracle.
Yeah,
life support for a couple of years, but
yeah.
If they ever leave,
looks pretty daunting. Yeah.
And we weren't able to fully formalize it. There's still a bunch of areas where the trade-off between trying to formalize it, you kind of have to come up with new constructs in the semantics to sort of represent this, how it's implemented in C++, and in order to keep it in your head while thinking through how it interacts with the rest of the semantics, that's sort of less useful when it's something that specific and not as familiar to other folks.
So if you were to have a clean slate, right, theoretically, would you say that starting off with the formal semantics is what you would do?
Probably.
Yeah. I mean, how is the trade-off here between being pragmatic in the sense of, well, you want to develop a language, and it sometimes is easier to do just implementing certain things versus like actually declaratively writing down a formal semantics?
Well, so maybe not like fully write the semantics and like spend a year in a bunker like crafting math, but the user experience is also important, I guess. Yep. So it would be more of an iterative process. Like, here's what I would want users to be able to write, and how I would expect it to behave, and then based on a couple of examples, see, oh, this is sort of how I want the behavior, and then go to the math and think through how it could work.
It also kind of makes like a promise to the user of what will be available, and like has to be available if you're going to implement those.
One reply to that? Sure. Yeah. So there's also a midway way, I would say. Like if you have the so what we do in Q, we have this lattice, right? Of the types are all like sit in this sort of static lattice, and if you introduce a new feature, you can, without even looking at the formal semantics, you can see, does that actually have a place in the lattice? And very often it does not, right? Or it doesn't fit, and then you know, like, you shouldn't even go there, right? Like, if it doesn't have a place in the lattice, it's pointless, right? Like, you're getting into a, world of pain if you do that. So, that's a very easy way of sort of, you know, like preventing going down the wrong path.
I also have something to add to this. So it's, if you have a formal semantics, yes, you have to do the effort of writing the semantics, but you also get some unexpected benefits. For example, to some extent you can generate different sort of interpreters and be assured that different interpreters operate in different ways. Whereas, yeah, it's super easy to write code, but if you need to write a different interpreter, for example, just like the next version of the language, for example, it's basically you don't have like a good argument why is this compatible with the old ones. So yeah, over the life cycle of the language, I think we believe that it helps with this sort of thing, basically.
Yeah, and even if it's not fully formalized, because no current language is fully formalized, like Haskell or Camel or whatever, it's just too complex and too big, but you can have a core part of it that is formalized. It's just, and another thing that can alleviate, I think, is, I mean, at least when you introduce features, often you don't implement it that way, but you can think of them as desugaring to the core language, and so you don't have to touch your core language as much because it's all compiled down to something. Like, for example, the core language of Haskell is actually pretty simple given the complexity of the language. It's like a polymorphic linear number calculus.
And also there's, coming back to partial formalization, is even if you don't have a fully formal semantics, if you have a semantics of the algebraic properties that the language has to conform to, that's enough, for example, just to reject different features and sort of things like that. So even if you don't have the semantics for the feature themselves, you have the semantics for the combination of feature, and you know how they would work, for example, which help with compositionality and stuff.
All right, any last 1-2 questions or discussion points you want to add? Yeah.
I guess that's a question for more or less all three of you. I'm a bit stoked by the dynamic scoping. So I guess also 20 years back, people already used languages that agreed on lexical scoping. So how did that happen? Was that an implementation mistake that...
You don't have to ask that, it's mine. To be honest, I don't remember. It was something, so with the original design, we did use graph unification like Q, and there it would not be dynamic scoping, but there were certain use cases, and it's probably documented in like the one of the languages offshoots of GCL that's called Flabbergas, where especially SREs, there was much more of a following, like, yes, no, we do need dynamic scoping. And it had something to do with just the software engineering part of managing some features, which had some benefits. But in the end, it clearly didn't weigh up to the lexical scoping part. But there was a reason for it. I just forgot what the reason was, to be honest. But
Power.
I think it's not totally absurd with the merging model, because you have what you write is a small part of the configurations that will be inserted in the biggest part. And so you're tempted to say, I'm going to use a lot of module options. You know, in NixOS, for example, you are in this huge fixed point with a lot of modules, and you want to open port on the firewall and so on. So I'm not saying it's a good idea, but it can be not totally absurd to ask yourself, how do I really want to redeclare all these options? So I know that will be in the final result. So I can just use it because I'm defining a part, really just a piece of the configuration. But
it's like a mixture with like a macro kind of.
Yeah.
It can reduce verbosity quite a bit.
Yeah.
Yeah. Part of the challenge of removing it is lots of people are relying it, at least on certain occasions, intentionally. So if we were to replace or remove it, we'd have to come up with another way of doing having the same or similar result.
Any last question before we head out to lunch? All right, let's thank all our speakers again, please. Okay. Thanks all for being in the session. A very wonderful session. We are going to be back at 2 p.m., so enjoy your lunch.
So I didn't quite get the last part. So you say, like, if you have a new implementation, right? Like you have to
everything works best with Linux, right? I hope it will make sense to everyone.
All right, thank you all for attending. So I'm very excited. There's another talk about Q. With this, I'll give it over to Éloi. And, go ahead.
Okay, so thank you. I'm Éloi. I am a postdoc at IMT Atlantic, and with my advisor Jacques Noyer. And for a year now, we're looking a bit about what we call programmable configuration languages. So Jacques, looking at Q, we were intrigued by this underlying formalization of feature structures, which we didn't know about. But yeah, we didn't know about, but was, as Marcel said, it's a formalism that was used by computational linguistics since the 1980s. And Jacques remembered a language called Life, which has an interpreter called wildlife, and uses these feature structures, and it is a general purpose programming languages, and it has these feature structures as first class. And in Germany, it evolved in all the Oz language, which does concurrent constraint programming. So this is the plan of my talk. So I will spend a bit of time to introduce the terminology of feature structures by slightly growing in complexity. And the first part, mainly, I will show example of JSON and JSONet. And slightly, I will show some example of Q and Life and introduce the types and the sorts and what are side terms. And finally, we'll see what we can learn from this and where we go from there. So in the beginning, we have these JSON. So right, this is just simple JSON files, which is actually just a tree. We call this a feature tree. So the feature here is the label on the left of the column. So name, first, and last. These are features. And the values on the right, there are values, and there are only leaf values. And they are simply typed. We can have strings, integers, etc. But no types. This is just static JSON, and we cannot do much about it. So what can we do with JSONet, for example? Oh no, for the first thing I want to mention is the representation of this tree. We have these two kinds of representation where we label either the nodes or either the edges of the tree. We call the first one that we call them terms, and the second one is actually the feature trees. This is what we'll talk about. So what we can do with these trees in JSONet, we can merge them with the plus operator, and here we have two trees with distinguished features. So when we merge them, it's simple. We just unify. We just identify the roots, and we can add new features like that. It gets more complicated if we have colliding features. Here, name is colliding with the name on the top, and we add a middle name to Jane, and contact, the preferred contact here, is another value of 1 instead of 0. And what will happen here is that we kind of embed the two graphs together. We match them by features, and the semantics here with JSONet is simply to override the subtrees completely. So another thing we can do with JSONet, and we want to do with our configurations, is to have references within the tree. So here what JSONet does is that essentially it has the $sign that is the label of the root tree, and by projecting this root tree, we obtain references, path references, by projection. And the self keyword is for local roots, but you only reference structure by going to the root and going down with projection. Last thing with JSONet is functions. So here we have a helper function getAdder, which is a call to a function,
and the function is defined outside of our data representation. So we are moving from the data representation world to the functional world. I won't say too much about this now. And so the semantics of functions is reduction. So the call of the function gets reduced to the value. So what Q does different is that it have the features are scoped. So you can access features which are neighbors or parent features. And we also have the same path, the path references. And the semantics of these references are copy. We actually do a copy of the node that are below the feature that we are referencing. But this is not the only way in life. What we do is for references we have logic variables. So here I reference x in 3 places, and they unify seamlessly. There is no copy. It's a unification process. And you see that the structure of the program looks the same, except that we have this @ sign here at the top, which we'll see more about it. But this is what we call a sort, and features are sorted. So let's look at. So we know now that Q has this built-in type hierarchy, and put it simply. It is just symbols that are ordered, have a built-in order. And with this type hierarchy of basic types, what is good is that it extrapolates to order on structure. So we have this subsumption relation, and all structures are ordered. What we can do with this, so just a small example to illustrate. We have a schema patronym, so the dash is to close the structure, meaning that we cannot add new fields. So I have two schema definitions here, and I can kind of instantiate them by making a copy of it. Here I have a new object which has the feature Jane. And the name is a copy of patronym, and we specialize it by adding a middle name. And here, contrary to JSON, we see that the feature just gets added because of the subsumption relation. Values are only refined. So it is a copy mechanism, and actually we need this copy mechanism to make multiple instances. Because if it was logic variables and co-reference variables, we would change the schema by just instantiating one value. So this is not what we want. We want actual copy to make multiple instances of a schema or a type. So going more into life and sorts. So what are sorts? There are just the labels that are on the node, and the user, the programmer in life, can declare any symbol to put on the top of the node here. So here I have the sort Jane, and I have the features, the feature attached to the tree, and the tree has a label called Jane. And the name has a label called patronym. But here, apart from the co-reference versus copy reference mechanism with the variables, essentially it's the same as before, as in Q. But what we can do with sorts is that we can actually declare a sort and attach to it a feature structure. Just making some kind of real typing. So here we have the patronym with the colon sign, and with this definition I can have this variable j, which has the sort Jane, which is just declared. We don't need to declare it specifically. We just put it in the top of the tree, And name and Jane has a feature name, which is a patronym, and the patronym on the name of Jane will be constrained by the sort that is defined above with the actual features first string and last string. And with this sorts and distinguishing the declaration of sorts and the features that are attached by it, we actually have we can do general induction. We have induction mechanism. So here's the simplest example with lists. And here and with the declared sorts, we have this operator to say that one sort is a subsort of another one. So it's explicit subtyping, which is nominal. It is explicit subtyping. And with this definition, we can instantiate our list. And here I have a list which is extensible. So I have a variable L, which I first attach it a consort with a head value. So this is the first value. And then later on in my program, I can specify the tail of the list by adding a new value. And here I attach to the tail feature the x variable. And variables are globally scoped. So I can further in my program refer to this variable and specialize it further. So if we try to do this in Q, well, Q doesn't allow this structural cycle, which is an option. And if we do it naively, we don't think too much, we can easily have problems by doing induction. But this is normal. And actually, there are many ways to do induction and recursion with Q, but nothing general, nothing standard. But we can do it if we're willing to. So what is actually life? So quoting from a paper, life is a trinity, meaning it has these 3 dimensions of types, functions, and relations. So we saw that users can define their types, but users can also define functions that works by pattern matching. And also we can define predicates that works like that works by unification. Because essentially life is a subset of Prolog where the terms are what I called psi terms, so feature trees with labeled roots. And with this, okay, this failed on the last compilation, but what, yeah, completely. It's about the underscore. Yeah, I changed the case and the underscore failed. But what I mean here is that a psi term, so everything is a psi term, is a feature tree with a labeled root, and depending on the context of the declaration above, a psi term can be interpreted as a type. This is the first example, as a function. GetOther is just getOther is a sort, is just a label, and we attach it parameters. And parameters are just a list of feature structures. So it is just one feature structure. And we can also have predicates, is valid other, which has another semantics, but it's all psi terms. So a bit more about describing features. So we talked about inheritance and structural and nominal subtyping in life. So we have induction, but since life is a null programming language, it would be terrible for configuration. For example, it doesn't have the closeness mechanism, and it's really a basic, a very small language that is really expressive, but you really have to implement everything if you want to do a configuration language based on life. but it gives some insights. So since it is a subset of Prolog, what we can do with this? Well, we have queries, unification, relations, predicates, etc. And moreover, we have these control flows. So for example, with disjunctions and backtracking, and when I look at this, I think that with disjunction in Prolog, you can enumerate the solutions one by one. And with backtracking, you can look where the value was instantiated before, etc. So I'm thinking debugger, I don't know. And it has read-write functions for outside world and modules and things like that. And we have also functions in life, so we can define our own functions. And we have many built-in functions to manipulate the psi term, to manipulate the data, to look into it, and to make transformations to it. And it has this nice mechanism of residuation that allow to call a function on a variable that is not yet instantiated, and the function will be evaluated when the value gets fully instantiated. And this is powerful to implement many things. So if we look back at Q and in a more general sense, programmable configuration languages, we can try to identify what are the types, what are the sorts of our languages, and what are the functions and what are the relations. So in our understanding, so in Q, we have these basic types which are ordered, so they are basic sorts. The struct, I believe also it's some kind of sort. And we interrogate about the annotations that Q has to put on the label of the features that allow some kind of control on how the merging operation takes place. We can say that a structure is closed, or we can say that a field is private or optional, etc. Are there sorts? Are there types? Are there kinds of sorts? This is not yet clear. We don't know. And what are the predicates of Q in our understanding again? So the basic predicates and, or, and if. Q doesn't have the not operator, but maybe it doesn't need it. And so it has this great addition that is nearly impossible to implement in life without using functions, is this unary constraints and validators, which allow the programmer to give one expression to a binary operator, just making it a constraint. And when a value gets unified with the constraint, it triggers the validation of the constraint. And this is really great, and this is really great. And the validators here, like max fields, is just the general mechanism to call constraints that are written outside of Q. And what about field constraints? So here is the features. They have kind of their types. So Marcel talked about wildcard. These are predicates. Yeah, I think so, but I'm not sure. This is complex semantics actually, for us actually. And so what are the functions of Q? So I believe it's the E part, the execute part. So functions are everything that is outside of the Q language. So we have the standard library that we can call from Q, but we also have all the tooling with the CLI, the Q CLI, and we have all these different formats and transformations of our configuration. The FMT for formatting, evaluation, VET for validation, trimming. All these are some stages of evaluations from the configuration that you've written and an output that you would like to have. And it has the Go API. Okay, so this is what we think of functions in Q. So looking back at these three words, I think life can give us some some intuition about the interaction between the data and the computation. So how much we would like to embed, how much computation we would like to embed in our data description language. Because here, for example, Q, so it mixes types and values, but it also adds some relations, some predicates with constraints, etc. And it also has some functions with the outside world, with talking talking with the outside world and making transformations, which are sometimes very useful for configuration. And it can give basis for specification and basic terminology. So what do we do with this? So our work for now, we try to implement an executable semantics with the K frameworks. That is based on, so you write rewriting rules, and you have this stack-based state machine that you can program. So you can actually execute your rewriting rules. And so we started a really small implementation of kernel Q, which can serve as an alternative implementation of the specification. And it is like live, but with copy mostly, which live doesn't have embedded in the data description. So for now we have we have type hierarchy, definition of structure, embedding, projections, and doing this was already really not easy and quite complex semantics to think about. And we don't know exactly yet what is a value, what are the exact definitions of the evaluation stages, what is a def, what is a vet. We're not completely sure about everything about this. So yeah, thank you.
Yeah, thank you. Very, very interesting. It might be interesting for you and Aran to talk after this also. But any questions? So I have one. So as you mentioned that life has this more bidirectional, I call it from my
co-reference. We call it
co-referencing or binding from the which is very different from the unidirectional just references that Q has, right? So how much do you think the semantics or modeling Q with life still applies, or how much does that cause a problem?
Well, so life gives us the framework, so the framework to think about, but the copy semantics is different because you have to implement the interpreter, and it's different. But I mean, what I think is that maybe Q can also look into unification and variables, and maybe we can do with it. But yes, of course, the two variables and copy semantics are really different. But the point is not to implement Q in life, but just to give the framework and see after that how can we build the Q semantics, which is formal, and life gives us the intuition of how we can do that. Yeah.
So just as an additional point of information, so implementation-wise, or the way you can think about it is if you have to copy semantics, and basically every node that gets copied in basically gets a new identity, whereas if you have the co-referencing, you're basically
it's a binding, so there is only one value.
There's one value, and that makes a huge difference. Like that's sort of the key of the.
Yes, and maybe of course it's different, but maybe we can look at some algorithms that may be useful, but since it's different, maybe not exactly, but.
No, definitely very interesting. Any other questions? No, then I'll ask Ruben to come up. Oh wait, Aran.
So I don't have a question per se, but some observation. So in Q, it's yes, it's a copy. It's not a bind.
but it's also, if you think of structured instantiation as a sort of calling convention sort of thing, it's essentially called by need. It's not called by copy. It's really called by need, and as needed, we make copies.
Yeah, and this is complex.
Yes. And you mentioned that you don't know how to formalize values. I don't know either.
Yeah, it's true, but we can identify the minimal syntax to identify what is the core semantics that we would like to formalize. And this is looking at life teaches us what to do with this.
I will also point that what we have optional fields and required fields are not types in Q. They cannot be made types for technical reasons, which is unfortunate.
Yeah, but if you think types and values, I know,
yeah.
Okay.
All right, so next I'll introduce Ruben, so another entity from the now famous, I guess, Darkstool seminar. So it's almost like a Darkstool reunion here, I would say, but Ruben, take it away.
Okay, thank you. So good afternoon, everyone. I think the title is kind of self-explanatory. We're going to talk about Ansible and how it's probably Turing complete. I should qualify this as probably. I'm not going to formally prove anything. But I'm going to show you some code examples and tell you why it probably is. But first off, I'm going to show you how Ansible should actually be used in practice, how you would typically write actual Ansible code. So that's a file on the left, a playbook. And there's a couple of tasks in there. So you have, I don't know if my pointer actually works on this one. Let me check. Oh, okay. So you've got like 3 tasks here, right? First one, install some packages in Python. There's the package action, which is, I mean, you can kind of think of these as function calls, right? So you're calling the package function with a name and a state, and the name actually indicates which packages that you want to install. There's some other pip action that installs some pip packages. And basically for each of these steps, they're executed in order, and Ansible is going to execute them on all of the machines in some infrastructure or some cluster that you have. So basically you can configure like actual machines with this language. Of course, I'm calling it a language. It can be used for configuration management, for automation, for infrastructure as code, but it's not a programming language, or at least that's what Ansible wants you to think. This is a tweet from 2019, so yes, it's still a tweet, not an X or whatever it's called. I think this guy is like a some PR person for Ansible, and he's really shouting at us like it's not a programming language, it's just automation, right? Then this guy replies, well, what distinguishes it from a programming language? It has programming language constructs, such as variables, for loops, conditions, do-whiles, exception handling, etc. I haven't seen any proof that it's Turing complete, but I wouldn't be surprised. And well, 4 years later, now I'm here, which, I mean, I'm not going to show you a proof, but I'm going to give you the intuition why it probably is. Now, before I can go into that, I have to explain some of the language features that we'll need to actually interpret these code examples, starting with variables and expressions. So here we have one task, which is going to debug some message to the screen. And the message is a string. There's a template expression in there between the double braces saying x plus y. X plus y are references to variables which are defined at the bottom. And pretty much this is going to do 10 plus 15, 25, right? Special about Ansible is that there's a lot of different ways that you can define variables. I'm not going to introduce all of them. I did that 2 years ago at Conflang the first time. There's 22 different ways. We're only going to be looking at one. And expressions are also a bit weird in that they're lazily evaluated and can lead to some other issues. Again, not really the point of today. Secondly, there are also dynamic variable definitions. These are the ones that we're actually going to need. So we have a set fact. It's an action which takes the names of variables as arguments and then expressions that define the value that those variables need to have. And then you can dynamically define these variables. So in this case, again, we're going to define a variable called result. We're going to evaluate this expression. It's going to be 25, the string 25, not the number, the string, because again, these things are template literals or template expressions that are embedded in strings. And then later again, we can define, or we can print the result of this definition. This variable is now a global variable. It's defined in a global scope. And again, the sum is going to be 25. So that's not all. There's also conditionals. So you can conditionally
do certain things. For instance, you can check in a conditional with this when colon construct that the result is even or odd, and if it is even, you're going to print the sum is even. If it's not even, the task is going to be skipped entirely, nothing is going to be printed to the screen. Of course, you can also dynamically, conditionally define variables with set fact, but not really too relevant right now. However, there's a final thing that I need you to understand today. It's include tasks. This is dynamic inclusion of a file that includes some of these steps of these tasks. That can be used to modularize these tasks. So again, we have the same example as previously, but now we are dispatching from another file, including this dynamically. And when I say including this dynamically, I really mean it's entirely dynamic. So it's going to execute every task up until this point, and then only then it's going to parse the file and actually load in all of these tasks, execute the tasks, etc. You can also put conditionals on them. And one thing that is it's used for sometimes is that the file name that you're including is going to be parameterized by an expression. For instance, you have install underscore and then the operating system family name. So you might have different tasks for a Red Hat operating system or a Debian one, etc. Now, if you can do if you can do dynamic task includes, what is stopping you from doing recursive task includes? What if a file includes itself? Like in this example, you have at the bottom an inclusion of the file itself, and then of course it's going to include itself, and it's going to do that again and again and again and again and again and again and again, right? And it's never going to stop. Actually, Ansible is implemented in such a way that this is not going to lead to a Stack Overflow, so this will indeed run forever, pretty much. Now, fortunately for us, we can do conditional inclusion, meaning we can put a bound on the inclusion of this file. So we can, for instance, in this case, we're printing a message that we're going to decrement x. We're going to use setFact to dynamically define x as x minus 1. We actually have to cast x to an int because, again, it's a string. And if x is not 0, we're going to include ourselves again. If x is 0, we're going to skip this part, and then we can print that x is 0. And if you run this, you can actually see at the very end here, this thing is skipped. So this is where the loop stops, right? And so now you have created a recursive loop where you're decrementing x all over again. And that pretty much opens up a whole can of worms, because if you can do this, you can also write a factorial, right? You can do an iterative factorial where you're dynamically defining a result, which is pretty much your current result. If there's no current result, we're going to use a default of 1, and then we're going to multiply that by n, at the same time also decrementing n, as long as n, of course, is not 0. Once n is 0, then we can stop. If n is not 0, we're going to loop again, and, well, that's your factorial. So here you've implemented a recursive or an iterative factorial via recursive inclusion in a language that is not a programming language. Now, of course, you can go further. You can also do Fibonacci. It's a bit more complicated. So basically, we're going to be using a stack here. The reason why is because Ansible variables cannot be defined in terms of itself. So you have to store, unless you use setFact, but that, of course, overrides the previous value. So you need to store these values somewhere on a stack. So we're doing kind of stack-based programming. And then we have our recursive Fibonacci, which, well, to calculate the Fibonacci of n minus 2, you have to push something on the stack, rather like actually your previous result. And then pretty much it's a Fibonacci, right? It's just recursively calling itself over and over again. It's actually looping between these two files up until the point that your base case is reached where n is 1 or 0. And again, we need this stack for the Ansible semantics of not being able to actually define a variable in terms of itself. So, okay, we can do factorials, we can do Fibonacci, that's all nice and all, but can we do more? Can we do something stupid? And yes, we can. We can write a scheme interpreter in Ansible. This QR code takes you to a GitHub repository. It is a limited subset of scheme, but it supports closures, higher order functions, recursion, apparently also consoles if you implement your consoles yourself. I haven't bothered with it, but this guy over there, Bram, he submitted a pull request 2 days ago to show that it also works. I'm not going to show you exactly that it works. Just trust me on this. I haven't prepared for a demo, but maybe later. But I'm going to highlight some of the things of the implementation of this scheme interpreter. So according to Koen, the most important part of a scheme interpreter is lambda expressions and closures and function applications. So if we encounter a lambda expression, we can create a record. The record is a type value, so the type of the record is a value, it stores a value. The data type of that value is a closure, and then the closure has three properties, namely the parameters, which are the formal parameters of your lambda, of course. You have the body of the lambda and, of course, an environment, otherwise you cannot have a closure. So now we've created a closure record in our Ansible scheme interpreter using this set fact construct. And then when we need to evaluate a call expression, I'm not showing you how we detect call expressions. We have an entire parser implementation for scheme in the Ansible interpreter as well. I really don't want to explain this one. But maybe during the break. Yeah, actually I do. Like, this was a weekend project, by the way, right? I mean, it's not like funded by anyone. But first, of course, we evaluate our arguments, recursive call to, eventually recursively does some evaluation and you can get your results. You push those results on a stack again, because stack-based programming. You have to evaluate the operands. Could be a lambda, could be a name, could be anything. We're going to assume that it is a lambda, or rather a closure. Could also be a built-in that's handled separately. And then finally, we dispatch based on the type of our callee, which we hope is, of course, a closure. And then when we do that, we need to call this closure, of course, as we all know from the Structure and Interpretation of Computer Programs book. We need to extend our environment. We need to create a new local environment with a parent environment. The parent environment is, of course, the definition environment of the closure. And we have to bind our formal parameters to the actual arguments that have been given in the call that we just evaluated. Then we can recursively evaluate the body of the lambda in this environment and then finally destroy it. And we have done our function application, all in a language that is not a programming language. Now, of course, it's not trivial. There are some challenges or why you should not do this. As I mentioned already, Ansible thinks everything is a string because template expressions are strings, so we need to do a lot of casting. The entire thing is filled with casting to int. There are complicated variable semantics. As I mentioned previously, there's 22 different rules in which you can define variables. They have very weird semantics that we need to kind of struggle with. I'm an opponent of the set fact construct, but this is the only way you can actually do it. And then finally, there's also, they have conditionals, but they don't have else branches in those conditionals. So either you need to specify a conditional and invert it every time that you write another task, because otherwise it's just going to fall through, or you do some weird, ugly dispatching based on the dynamically constructed file names to do include tasks. So those are the challenges, so please do not do this. On the other hand, please, PRs are welcome. There are some limitations. We are missing a lot of built-ins. There's no consoles. I don't think we even have a division right now. There's, of course, Scheme is known for let bindings. We don't really support many of those, if any, I think, but that was not the point. Mutability is also something that we're currently still missing, but it is work in progress, but I just didn't find much time anymore. Garbage collection, if anyone dares, and for the real crazy people, there's call with current continuation, which again I don't really recommend. Now, thank you to reviewer B of Conflang, who wanted a proper proof that that Ansible is Turing complete by simulating a Turing machine. I hope that I've given you the concepts to implement this yourself. Again, the GitHub repository is public. You can create pull requests if you wish. Now, you might be thinking, okay, this guy is crazy. Fair. But also, yeah, sure, Ansible is Turing complete, so what? Right? Does it really matter? Now, there are a couple of questions that I, in my own research, want to answer, like, does this Ansible script contain some security vulnerabilities? Will the configuration that is being deployed by this Ansible script be correct? Might there be any variables that are not defined in this Ansible script, or even does it terminate? Because this question, especially the last one, is generally undecidable now that we know that we can actually recurse. On the other hand, we've also done mining software repository studies with some of these tools that we've created. On 25,000 GitHub repositories that use Ansible, there's only one single repository which didn't terminate, or might not terminate, which did these recursive includes. That was probably even a bug, so I don't think this was really intentional. Now, so what? Well, good question. Now I'm going to end with some food for thought. First off, okay, we have these recursive task inclusions. I don't think it's by design. I think it's very much accidental. Should we prevent this in Ansible itself? Is it worth the effort of preventing people from doing this so that your language is not Turing complete? And on the same topic, is there any value in your configuration management language being Turing complete? I would like to hear your thoughts on that. Now, if you can write a scheme interpreter in this language, I think that is a sign that your language is too complicated, especially if it takes me this much effort to do so. And of course, Ansible takes a lot of inspiration from proper programming languages. You have your variables, your expressions, do, whiles, loops, conditionals, etc. Why bother with the DSL? Why bother using YAML with some special semantics? Why just not use Python with function calls and provide some library of functions, kind of what Daniel is probably going to be talking about later, Pulumi, etc. And then finally also, okay, why not embrace these programming languages, but at the same time, Ansible scripts lack a lot of common language features. We need to use stacks to do all of these things. There's no function calling mechanisms. Should there be functions in Ansible to make my life easier? So those are my final questions. Would love to hear some discussion on that, and other than that, thank you.
Yes, thank you, Ruben. Any questions? Jan.
So just as partial, at least, ideas about Turing completeness, I think that in general it might be a bit overrated. I mean, the question of Turing completeness and decidability in practice are not always exactly what we think. For example, DAL is not Turing complete, but you can encode a command function, so it doesn't give you any bound on the running time of your program. But it does prevent stupid errors, and that is something that is interesting because, for example, in Nix, infinite recursion is something you encounter often because it's a complex fixed points. And so I think that Turing completeness in itself is not truly an interesting property to discuss. You can discuss if your thing can terminate in a finite time or in a reasonable time, or maybe in Q, for example, this gives you decidable analysis on some property of the language. And those are interesting property, but I don't think Turing completeness per se is more of a branding for I mean, there is a blog post by Gabriela Gonzalez, the author of DAL, about that, and she herself tells something like that it's more like a part of a nice property, but more than a branding itself. And for Turing completeness, Nickel is Turing complete, and we did that because, at least in part in Nix, you need sometimes to parse things like very simple file format, but still, I'm not talking about parsing bash, but still handle structured data in a recursive way. And even if it might be doable in something expressive like DAL, it's just a huge pain. So we try to provide the basic combinators so that you don't need recursion when you don't have to, like maps and whatever non-Turing complete language provide. But it seems like for something it's just way simpler to not be Turing complete. That's my stance.
Thoughts on Turing completeness. I would definitely agree with you that it's probably overrated. And for example, if you know exactly what your configuration is, there's relatively little value in Turing completeness, because if you have, for example, an infinite loop, you're not going to wait forever. But if it takes too long, you're going to rewrite your code. You give yourself a bound how much time you can spend executing this thing, and you're going to write your configuration. You're going to fit in the bound. I think the question becomes more interesting when you consider compositionality, because if you do not know exactly what your configuration is, you have multiple sorts of configurations which have been independently tested by different people in different environments. I think it's quite nice to have some sort of guarantees what happens when you put those things together. in a system that might not be, it might run as a sort of a batch job or something that's not even observable. Although also, as you said, that doesn't necessarily mean there's any sort of a useful bound on how long that would take to execute. But so you know, it's still up for debate. But yeah.
Just as one comment on there, so Carpenter's book on feature structure shows a really nice example where you have two obviously non-recursive graphs that if you combine them together become infinite. So that is possible, that kind of stuff. Yeah.
Have you seen people using the Python API of Ansible on the FES to do what?
Personally, not that I know. So I don't even really know of a Python API to Ansible. I know that there's you have a command line interface, and I'm assuming that people can also write their own scripts and possibly import Python. Actually, wait, no, what am I saying? Of course, I've used the Python API of Ansible in my own projects. I use Ansible to parse Ansible, or rather the interpreter itself, not Ansible code. I'm not that crazy. And of course, there's also a lot of people actually write Python plugins for Ansible, right? So it's the whole kind of concept behind the new collections thing. So for instance, if there's like AWS machines that need to be managed there in the AWS collection, that's just a bunch of Python files where people can write proper programming code. And then make it possible for us to just write normal tasks that execute some action. So that definitely happens. Possibly, I'm not entirely sure. I can't really give an answer to that.
There are definitely people writing configuration in Python, but yeah.
If I'm not mistaken, Facebook doesn't have a configuration language, and they're writing all the configs in PHP. So probably that's one of the solutions for this problem. I just want to make a comment that you can treat the configs as a DSL for your application. Basically, you are telling application what to do in a very specific way. Mm-hmm. And surprisingly, to your point that should we use a proper programming languages, like this particular resolution of the problem will not get rid of DSL. So people will still need DSL and still want to use DSL because they want to create a situation when they don't need to think about a reason about the whole program, they want to reason about a small portion of it. And I know one language which actually embraced it, mm-hmm. and the language is Scala. And I wrote in Scala, and I still survived. The problem with Scala is that their type system is Turing complete. So when you're creating a type in Scala, you can actually have a chance to emulate Turing complete system. And their build system is actually Scala as well, SBT. Mm-hmm. You don't want to use it. It's not very pleasant experience, but well, it's possible. Yes, people can do that, and people can survive.
I think on the level of like configuration of a binary or something, definitely people are writing configurations in different languages. What I was really meaning with this last point is like if we go back to an actual proper example of Ansible code, this one. Like in a sense, like this package thing is just okay. Call a package function with the name Borgsys packages or something and the state present. These are just function calls to functions of which you don't see the code, but then in the backend it's just Python pretty much. Technically, you could probably just import these Python functions into an actual proper Python file and then use proper language semantics to use variables and expressions without all of the Ansible cruft around it. So maybe we should like really on the level of machine configuration instead of like single software configuration. That was more the point here, if that makes sense.
Okay, thank you. So if there's more questions, we have a Q&A session afterwards, and I'll give the floor to Jan, who's an author, co-author of the Nickel language, which has a lot of similarities with Q as well. Go for it.
Oops. Traditional. Okay.
Thanks. So yeah, I'm Jan. I'm working at Twig in the programming languages and compiler group. And this is joint work with Daniele Palombi, who was an intern at the time at Twig. And, whoops, I don't want to see that. We are working, we have been developing the Nickel configuration language. It was born out of frustration and dissatisfaction at the time with configuration management. We also do DevOps work, for example, for industrial clients. And you know, this kind of thing with Ansible, this is the case for a lot of ad hoc configuration language when you need to learn the HCL or the dialect for this stuff. Well, I mean, it feels like you could use the same abstraction and idioms in all of the languages. And also, a lot of them, including HCL, if you look at the very first version, seems to start from something that is more or less YAML and then have more and more hidden, sometimes not so hidden, programming features in it. So in a perfect world, I think configuration should be JSON, but this is not the case today. I think to handle like Kubernetes deployment, cloud deployment in general, build systems like in Nix, there is too much complexity right now. And so if you have to use programming, at least do it right somehow. So we couldn't solve all the issue of configuration management. So I mean, you have a lot of things to do, but at least as a language people, we think like we could act on the language part at least of this. And the developer experience, we talked about LSP before, I think is a huge thing. So this is the motto that I wrote someday totally randomly on the websites. But yeah, the idea is that Nickel is to bring in abstractions and nice things to handle complex configurations. And the data model is basically JSON plus functions, like in order to derive data from other data, to do a bit of data processing. And in Nix, it's really, really annoying not to have typing. I mean, users complain about that all the time because you never know what your function is accepting. You have to read the doc and often the code, actually. So we wanted typing, at least for those like functions computations. But for configuration, as we also discussed before, I think validation makes much more sense because it's mostly static data. So typing doesn't buy you much. Typing is about flow of property across function and computations. But there you can just do validation and call it a day, and it's much more powerful because write a static type for a port number is really hard. Write a validator for a port number is a 3-line programs. So we have this kind of built-in contracts you can think of as runtime types. So you write them as type. You can spin off your own, use an array and dictionary constructors. But they are, and use annotation as well, but they are checked at runtime. And it's useful in Nickel because we wanted to have schema definitions in the same language. And then taking inspiration from Q and the NixOS module system, we have a merging operator that is as well some kind of algebraic operation that allow you to combine recalls together, which is exactly the idea of matching those trees or graph actually, because you can have self-references together. So it's a form of unification, although Nickel is still incomplete, so it's not implemented as unification, but the specification probably could be that. So it's somehow like if Nix, Q, and type bracket had a baby, but that's not how we thought about it, right? That was not the idea. We just had some kind of design goal, and it ended up that way. A quick primer, so this is just to show an example. It won't be very important for the rest of the call, but I couldn't resist. So this is just a function definition, something that derive a port from a protocol. Protocol is given as an enum, a bit like C enum or TypeScript enum. And we use the type annotations. We have a fancy type system with row polymorphism, and I mean a structural type system that makes sense for JSON. And we don't specify the return type. We say, please infer it. But the point is that this small part really looks like some kind of OCaml, like it's a statically typed ML language. Nickel will insert contract to protect this function if you call it from dynamically typed code. And code is dynamically typed by default. So you have to put types where you want the static type checker to kick in. And then, a bit like in Q, you don't have a strong separation between schema, values, and a bit more, but still schema are just normal records with missing values. And we use this pipe operation to attach metadata, including contracts, to some fields. And those will propagate through merging. So I can never override extra.port with something that is not a port number. And port number is a custom contract. I didn't include it, but it's like a 5-line function that user can define. The other is a built-in enum types, and you can put a default value for protocols that depends on extra.port. That says that if you don't specify the protocol, I will try to compute it from extra.port. So as in Q, once again, records are recursive, so to speak. You can have data dependencies within your thing. And then servers using all the other yet to be defined values to produce something. And you merge that with the concrete values, which is more or less your actual high-level definition or configuration. And if you try to export that, you get what you expect in JSON. So for configuration language, a strong question that could be asked is, do we care about performance? And that's a question that we wonder at the beginning, because it's a very specific language. It's a scripting language. You don't run it as a server in an infinite loop. You run it once during deployment. Maybe your deployment is very long anyway. So we didn't want to care too much about performance at the beginning. Just tried not to implement features that would be obviously hurting performance, like breaking parallelism, for example. Let's try to keep it pure. But still, otherwise, optimizing along the way, but we didn't think too hard and say, okay, let's wait for people to complain and see actual cases that we can, investigate and see what we can do. And it turns out that, GCL people showed at their scale, but even without going Google scale, we do care about performance. So Nix packages, the repository with all the Nix package definition, takes 8 minutes to evaluate on CI. That's actually pretty fast. I'm suspecting they use a beefy machine because Nix is not very fast and the code base is huge. But it's still 8 minutes on each pull request, After I submitted this talk, and 1 month ago, someone came to me and said, hey, I have this code base in Nickel. It's like 24 KLOC plus 15 of JSON, so it's really not huge. It's taking 80 seconds to run. So it's a bit unacceptable. So we could bring it back to 3 seconds, but it's still a bit much. But so even on mid-sized code base, a DAL issue from a few years ago, but I honestly don't think this has been fixed because it's quite fundamental. Same kind of order of magnitude, less YAML to KLOC, 30 seconds to evaluate. So, performance is an issue in practice. And yeah, I haven't mentioned, but I think JSONet also had issues. And so what can we do about it? Well, if you have a slow program, the first thing you could say that, well, optimize the program, right? Maybe you're doing stupid stuff, you're having quadratic behavior, but you can only go so far. If your interpreter is dog slow, your program will be dog slow at some point. So what you can do is to optimize the interpreter. Do not change things like fundamentally, but have better data structures, implement some optimizations. And it can get you quite far. But at some point, if your interpreter is, for example, a tree-walking interpreter, you will hit some hard limits. And the general wisdom with scripting language is to go for bytecode compilation. And once you have a bytecode compiler, you can, apply optimization on the compiled version and up all the way to JIT. The thing is, from step 3, this starts to be a lot of work. You have to design the intermediate representations. You have to write a compiler, which is quite different from an interpreter. You have to write a virtual machine that operates on the bytecode. And especially point 4 is not obvious to me at all because, once again, this is why we have a specific workshop. It's a very strange, domain space configuration, and some optimization might not make sense. Nickel, for example, has lazy evaluation. It doesn't have any loop construct. You do that with recursive functions. But so title optimization don't really make sense in lazy evaluation. You don't have loop invariant called loop motion because you don't have loop. But you have other things like let floating code, and also you don't do a lot of computation on numbers, or you don't expect to, so you don't care about constant propagation. So it's not obvious at first to say like what can we take from the existing wisdom such as Python, for example, to apply here. So I propose it's not totally orthogonal. I'm lying a bit, but a different avenue at least, which is based on a very simple observation is that changes seems to be small and localized on your code bases. I mean, it's good practice at least to do so. And so then I would try, I mean, can we have something that take advantages of that so that reevaluation upon small changes is fast? And it's not, of course, you can, do the computations, all these API are public, so it's not a scientific proof, but it's just a small illustration on Nix packages. It's massive, it's like 2.5 million line of code across 28,000 files. And I just took the last 5 pull requests. It's all package updates, and it's like 9 line diff, 1 file, 11 line diff, 1 file. This one is 80, 80 line diffs, 1 file, 4 line diff, 1 file, and so on. And all those have to reevaluate Nix packages completely, which is not very efficient. And I had to scroll a bit to find the first one that wasn't just a package update. And it was the addition of a new package, and it's still like 44 lines out of 2.5 millions and 1 file. And we've mentioned that also before, in that when you work on configuration, it's a bit more akin to compilation than like running a Python script on some data, because each time you change the code, you interpret it. If it loops, you can stop it, and you get a result on fixed input and rinse, repeat. And what do compilers do? Actually, they have the exact same hypothesis, and they do incremental compilation. Compilation, sorry. So a lot of incremental X, so try to not mix them up. And yeah, so moving that to the interpreted world, it would mean that we could try to do something like incremental evaluation. And there's a more general setting out there in the literature. It's called incremental computations or self-adjusting computations, which is about efficiently recomputing a function after making a small change to its input. And as I think Marcus said, evaluation is a function from program to value, so it's trivially part of incremental computation. So that's great. We can look at the literature, and it seems to be somehow a solved problem, at least for algorithms. Usually the main application is more a specific algorithm, like you want to, I don't know, aggregate a lot of data and metrics on a use matrix, and if you change one row, for example, you want the result to be, but still, it's just an instance, so why not? And there is in particular this Adapton paper about composable domain-driven incremental computation, which is interesting because they provide some kind of language with built-in incremental evaluation. And also it's domain-driven, which really fits the lazy evaluation of Nickel. So yeah, there are differences with the other previous self-adjusting computation frameworks, is that in usual frameworks, what you do is, because you want to compute the result anyway, when you have a change, you eagerly propagate it and recompute everything. But that doesn't really fit domain-driven. So in Adapton, what you do is that you have you build at runtime a graph with dependencies between things. So here it's just a recursive calls to a map function defined standardly, as you can imagine in OCaml, for example. And each call depends on the previous one and on the X of the tail and so on. And when something changes, they just dirty the node and all the things that depend on it, but they don't recompute. Only when you request the node, like from the top of the graph somehow, then you start to look at, oh, is my thing dirty? Yes, I need to recompute it or not. So it decouples dirtying from recomputation. And yeah, perfectly fits lazy evaluation, at least from a distance. But if you look a bit closer, they don't really do what we want to do, because Adapton provides a language to write incremental algorithm in, and in particular, the programmer is in control of what is incremental on that. In Nickel, we would like it to be a total implementation detail. That, when you write a configuration, you don't care about this kind of complex things. You just want the thing to be fast. So if one thing, what we should do maybe is to rewrite the Nickel interpreter in Adapton. That would make sense, but not really to use Adapton as a base for semantics for Nickel. In Adapton, the incrementality came from mutations. They have an ML language with mutation, because if your language is perfectly pure and you only cache things, you have no reason to change input. Nothing changed actually. While in nickel, so there are actually some sources of incrementality, which should be the merge semantics when you override the default value, but that's not really the important part. I think what matters is the reevaluation, incrementality across reevaluation. And it's a bit different because what you change is the function itself, or the code, and not the inputs. And yeah, adaptant comes with this call by push value semantics, and it bakes the adaptant algorithm somehow, at least specification inside the semantics. And on the other hand, what I would like is something, once again, there's only one thing to remember is I want this to be non-invasive, as decoupled as possible from the interpreter, but both semantically and in the implementation. But we can adapt adaptant. And that's what we've called cache call by name for now. And if you, in particular, we would like to keep call by need is just lazy evaluation for those who maybe not into this kind of words. And call by name is a strategy where basically you recompute everything all the time from scratch. So it's totally stupid when you implement a programming language, but semantically it's actually one that has really nice properties. And when you think about lazy evaluation, you can actually see as a cache version of call by name. But it's just that it's a very, not very, but still specific version because you cache all let bound expressions and only them. And you only cache things. So that's why there's no notion of dependency or incrementality, as I said initially. If your language is pure, and you only cache things of type, of first order type, or zeroth order type rather, there's nothing that changes, so there is no recomputation to do. And so I think we can extend this to a generic notion of cache that is decoupled from the call by name evaluator and semantics. And even in call by need, when you formalize it, the formalization I know usually rely on something called explicit substitution, but the thing is that you represent the caching inside the language. And so once again, that's not something I want to do. I want the cache to be something external. So honestly, this is how I think about it right now. If I ever write a paper, I would have to do that more seriously, so don't pay too much attention. Those are draft ideas more or less. I haven't done the proof. But what's important is that I would have in my operational semantics an external notion of cache, a bit like a heap or a store when you do the operational semantics of an imperative language. But these things will be just a cache that sometimes you can ask, hey, is this value cached? Yes, give me, otherwise I just proceed to full evaluation. And it just, what the cache must do is, of course, return things that have exactly the same behavior as what you're trying to compute initially. How do we implement that? Well, in fact, call by need is already a very nice and somehow minimal interactive implementation of cache call by name. What I mean by that is we've looked into using adaptant to implement the interpreter, but the adaptant libraries that they provide, for example, in Rust and OCaml, they forces you to put things everywhere. The things that must be cached are function, so somehow you are doing you are passing continuations, and this is the usual naive way to implement an interpreter. When you say eval a plus b, well, eval a, eval b, and then I sum. Even a simple interpreter that is not a toy project is usually a stack machine, so you don't want to actually nest your function calls. But that's what call by need does. The idea is just that you have an API between the cache and the interpreter, and you just have a few back and forth, but they are rather minimal. What you do is that when you see something that should be cached, you just allocate a new node in the cache, saying, oh, I want this to be cached, and for example, you get back an identifier, pointer, whatever thank in call by need. When you see a usage of something that should be cached, well, you try to fetch it from the cache. If it is great, you just evaluate it. You just keep it. If not, you push a marker on the stack. So in lazy evaluation implementation, it's called thank complete frame, something like that in Haskell. But you just remember that, oh, I'm evaluating something on the cache, so I will have to update the cache later on. So you go on, and when you finally pop the marker, you update the cache. So it's a very simple interface of get, set, and allocate something new with a unique identifier, so to speak. I don't think we need much more, at least from the interpreter. The cache will have to do more things for incrementality, but the interpreter should be fine. Something that is not apparent in the semantics, but because somehow it's pushed into the abstraction of the cache and is very important and probably one of the most difficult problems I think in practice, is what I call a naming scheme, but you can think of it as hashing. So when you do incremental computation, like in Adapton on one program, you don't have this problem because you think that you cache, you allocate them in the cache, and then you get a pointer or an identifier, so you can always identify them. When you want to do caching across evaluations, you have to match the things that you get after modification to the things that were there before modification. And you cannot rely on names anymore. So you need to have a way to provide an identifier or name or to identify expressions from just the expression itself. And you can do something, I mean, the dumbest one is to just identify things that are physically equal, as more or less what call by need does. If you only cache things that come from the source code and say that everything that is generated during evaluation is not cached, that's a possibility. You can just hash the source code. And then you have, a whole continuum of different trade-offs, but the general idea that you want is my naming scheme should be hashing modulo some equations. And the ideal equation that you would like, of course, is like modulo beta equivalence, that things that behave exactly the same. Of course, that's undecidable, so you cannot do that. But you can do a lot of things in between and have to find the thing that is like the right trade-off in practice between, because this has a cost as well, so it has to pay for itself. And in fact, this notion of names is also in a follow-up of the Adapton paper, but once again, they don't care about automatically doing the names. The programmer has to come with the naming scheme, so to speak. So once again, maybe something to implement the interpreter in, but not going to help us for a language with automatic evaluation. So this is very much a work in progress. Actually, since Daniel left, I haven't had a lot of time to dedicate to that, but there was a bit of refactoring to decouple the evaluation cache from the virtual machine, I mean the thunk, abstracting the thunk somehow in some interface. Is almost done incremental merging, so as a stepping stone, we first wanted to inside one evaluation using incrementality so that if you override the default value or override a value in a recursive record, you only recompute what's needed. I don't think it's very useful because in practice, what happens is that you merge a lot of stuff and then you export. I mean, I don't expect that it's a very common workflow to, compute some values and override them, compute some values, override them. Usually, you just combine everything. But still, it's interesting as a first step. And yeah, the thing that we would like eventually to do is incrementality across evaluation. And the big thing is to try and to find the right naming scheme. Persistence is more of an engineering problem, like what is the format of your cache, how do you write the cache on disk efficiently and so on. But scientifically, it's not that of a huge problem. So yeah, the idea behind cache call by name is to have an abstract notion of evaluation cache. And we could even, and maybe you want to try that, to switch cache implementation depending on your workflow. Like maybe this is a program that you won't reevaluate incrementally, so you don't need the incremental cache, so I just want call by need. And that's something that's possible if your interpreter is, decoupled enough from the cache notion. You can try. And also the cache, at least in Nickel, will in fact implement part of garbage collection as well because it will hold value. And you can try different garbage collection or cache eviction strategies. And the important point is to keep your usual call by name semantics. You don't have to rewrite the semantics of your language. And it's important because in Nickel, for example, there is something we want to implement, but it's not there yet, called custom merge function. Whatever the details, this is something that is a really natural definition in call by name, because somehow you need to see the whole merge tree to decide how to interpret it, but not so natural in call by need. So that's the point that call by name can be usually the domain, I mean the frameworks that you may want. And also, yeah, with this idea of just having an abstract cache interface, we are trying to make it easy to integrate with an existing interpreter with minimal changes. So yeah, that's it. We have a bunch of projects around a nickel, and this is done as part of my work at Twig, and I'm happy to answer any questions.
Thank you, Jan. Maybe one or two questions before we move into the panel. Any questions? Yeah.
So thanks for the very nice talk. We have worked on incremental abstract interpretation in the past, and we were using tree differencing to determine the differences between two versions of a program that we were analyzing. So, and I didn't quite get what you were using in your talk.
So you mean to see the differences between
two successive versions of the program?
Yeah, so the idea would be to, I mean, at least for now, would be to not have any kind of diff mechanism between sources, but you just keep the cache of the last evaluation, so somehow all the values you've seen using the naming scheme and maybe some kind of strategy. You don't want to cache everything. Right now we want to start with record field, for example, and not let bindings. But so you have this set of expressions that you can identify using, for example, hash constings. That would be a probable first step. And then the second time you evaluate your thing, when you try to fetch from the cache, if you've seen the thing before with the same name or hash, then you would use that. So somehow we sidestep that and probably push it to the hashing, naming scheme. But maybe, I don't know if that's...
Yeah, anybody else? Otherwise, Ruben and Ilwa, maybe you can come to the front. Yeah. Yeah, so any questions for any of the three, or to start a nice discussion? No? Not? I have one for Ilwa, but it's kind of technical, but yeah, why not? We have some time to fill. So, coming back to the co-reference versus single reference. So there is this type per node, right? So which in feature structures you often use to merge in, and Q doesn't have that, but you could say that is maybe the reference, right? Like if you looked into modeling references like that, or?
Well, in Q you can label the nodes with the equal sign and the let, but they are only constants.
Sure.
And they are statically their scope.
Yeah.
Only on the and so yeah, you have it, but after, well, maybe we can go a bit further. I don't know what to.
Yeah, the idea is to map references not to the co-reference mechanism in some way, but to map it to the node type. So to the you call it sorting, I believe. So to pull in a type based on the node
so
reference.
Would like to put the labels on the nodes and make them types. I'm not sure I get what you.
Yeah, I'll maybe we should. Maybe going a little bit deep here for this conversation. But any other questions?
Yeah, I have a question for you.
Right.
Reverse question. Have you had any kind of performance problems with Q? I think the evaluation model is quite different, so probably that doesn't apply, but yeah, I would be glad to hear about your stories.
Yeah, absolutely, huge performance problems. So there is... So we actually now use a variant of the algorithm that Marcus like mentioned about GCL, which actually this was the second or third re-implementation or something like that, which actually improved things a lot. But during that re-implementation, I made a very, very bad error that's now sort of bugging Q a lot. So now there's a new re-implementation coming up fixing that. But basically, it makes disjunctions are theoretically a polynomial In theory, if you use discriminators, which almost all use of disjunctions are, then you can make it linear. But the current implementation, due to some boo-boo I made, is exponential, so that's definitely a problem. But it's not super hard to fix. The old implementation didn't have this problem, and so we know that the naive approach kind of works fine. But yeah, there's definitely, so graph unification in the old type feature world is linear, but with disjunctions and some other things that we have, it does get a bit more complicated. But you know, like a lot of times it boils down to memory allocation. So again, a lot of the graph feature structure algorithms, you can use this mark release mechanism, right? So you basically don't have to allocate any memory ever, right? And you don't have to deal with garbage collection, but we haven't quite figured out yet how to carry that over to Q, but that is definitely something we want to try. Yeah.
Similarly, in that vein, if I remember correctly, Q works in like a directory structure where all the files are evaluated together.
Yeah.
Like, have there been issues getting, or with users being discouraged from having like all the files and stuff that they would want because of like unification slowdown and stuff like that?
Yeah, so the so there's two ways that files are merged, right? So one of them is at the package level, if it's in the same package, and then you have this directory hierarchy. So we thought this was a nice model for it's basically like an ACL model, right? Like a nice model to structure and organize. But it turns out that different users, we had some pretty wild use case of Q that really demand a very different directory layout. So there is really not one directory layout that works for everybody. So we're trying to now to sort of make this, you know, more externally definable, but simplify the model where you just have more like a Go package model where you unify within a single directory. But the unification within a single directory based on packages, that works fine, actually, yeah. Any other?
Yeah, I still had another question for Jan. So have you looked at the kind of changes that people make to their configuration files? So you mentioned that they're often like 2 lines long or something like that, but did you have a look at the kind of changes? Are these constants that are being updated? Or because if you have an idea about the types of changes people make, you could also hard code the incremental evaluation for those type of changes, and maybe that could also realize the speed up without going for this more general adopt-on approach.
Yes. So honestly, no. I mean, we have looked a bit into it, but not in a proper scientific way, which is a bit of a shame because I think it's probably not too hard to automatize. On the other hand, I think it can. I mean, so I have the experience. I'm not really a Nix maintainer myself, but I have one. I mean, I have Theophan in my as a colleague who is one of the Nix maintainer, and I've seen what they do. They have some kind of evaluation cache for the so-called flakes, and I've seen, and it's very specific, you know, it's just like some kind of, I think, top-level values when you enter the project. But I've pair programming with him, and I've seen that even for that is quite specific and restrained. The implementation, I mean, the caching leaks in the implementation is very not natural. You have to add call to the SQL, I mean, to the SQLite databases inside the evaluator, and it's really dirty. So I believe that whatever we end up doing, I would like to have a proper, formal, it doesn't have to be very formal, but at least a proper high-level generic approach. And then, probably we'll tune this approach, especially with deciding what we want to cache, so granularity and what is a naming scheme, I think offer already a lot of room to optimize for the specific use case. So in any case, I think I want the general approach to have caching. But yeah, I think it's something that would be very interesting to do and overdue actually. So, but I haven't done it yet.
So I have a very open question, so sorry for that, but I think if we would find ever an answer for it, it would be useful for all of us. So Jan, you started the talk with like, ideally we would like to have JSON, but that seems not to be enough. And then I think across all three talks that we just saw, like the common thing was we need to add something for computation, some functions or something that goes beyond simple JSON. And I'm wondering, like, okay, so we introduce now computation that we know from programming languages, but still there's, like the common thing is to try not to make it a full programming language. Ansible seems to even try to prevent that in the marketing. So we need to compute, but we don't want to write real programs. So do we kind of get a better understanding, or do you have a better idea of how we could describe actually what we want to compute there? I mean, it's something based, it's configuration based on configuration, but it seems to be not as general as we want to use programming languages for that. So do you have a better idea how to make this problem smaller than, well, it's just programs?
So in a few, surely. That's a very good and very hard question. I mean, I think everybody in the room is not doesn't agree about what is configuration and what is not. So, yeah, I mean, Nickel is a programming language. It's just specialized, but I can't say the you can embed I mean, it embeds an ML more or less in it. So I can't say it's just configuration. But I guess that's a domain of application. I feel like what you do usually when you, I mean, what the connecting points, at least from the small pieces that I've seen, is that you want to describe usually graphs. In build system, you want to describe, and I mean, data represented as graphs. And in build system, you need a dependency graph. In a configuration, those are just this tree of values. But it's not exactly general graph either, but yeah, there is an idea that you want to define and act a bit on a graph with data inside, but that's not a very precise formal definition.
I'll come to you. I have a respond to that as well. So first of all, there's two different ways of pulling in computation configuration, right? Like what Jan described is like, okay, let's do it within Nickel. What Eloy described is like, okay, there's an interface to the outside world that's formalized and described and put in. So that's one separation. But the types of things that are computed, it can be something very simple, like a validation of an some you know, like URL or whatever that's a little bit too complicated to just do it in a more simple way with less than or some range or whatever, where you need to do more computation. But another one that gets more tricky is if you have a server that has very complicated parameters, and you need to compute these parameters based on some inputs. And you could put that in a server, but for pragmatic reasons you can't, and you need to have that more flexible and more being able to do it at deploy time. And then you really have a piece of code that doesn't necessarily need to be configuration, but it really needs to be defined at that level. That's one example. Does that help? Or yeah. Okay.
Just a small note on whether we should actually call all configuration languages general programming languages. We try to understand why do we have so many issues with the configuration, and one of the reasons we think is that there is a different level of trust to the configuration and code. Like if you think how code is being deployed, how people are treating code when they want to push to production, you will see that, for example, it's normal to write tests to code, and it's actually expected. Like, where is your test? It's probably if you don't have a unit test on your pull request, everyone will raise an alarm. But for config, it's fine. It's like, whatever. I'm changing this URL. I don't know whether it's going to work or not. Let's push it and see. And at the same time, we're pushing configuration way faster. Like, we need to run the code through the entire CI/CD pipeline. We are pushing this to staging. But interestingly enough, the differences between staging, production, and test environments, they're all encapsulated in configurations. So we are not using the same guardrails for configs and for code. And maybe if we're going to treat configuration as code, we'll see way smaller number of issues. Maybe, I don't know.
For a moment, I thought you were going to say that code that is in configuration is code that we really don't want to test, but, but that's not what you're saying. Yeah, I mean, I totally agree, right? Like a configuration should get the same kind of scrutiny and testing and validation as code should. Absolutely true.
To add to that, and coming back also to your question, is that in a certain sense code is simple to test because we have functions, which is basically an abstraction that can be applied independently and stuff like that, whereas with configuration, usually in configuration languages, we try to avoid notions of functions, which in the end makes testing harder.
And another thing is if you compose configuration from these multiple aspects, like you have some policy here, some policy there, some things that you combine, like who's responsible for the end-to-end testing. There's also that, right? It's a different sort of organization than you typically have with code, which is more top-down.
And I would add that testing is also very dependent on the runtime. I mean, on the things that exist at deployment time. So there's something that are very hard to test before you deploy when you just look at the configuration, I believe. I mean, just looking at the YAML, you cannot always know that these things, in fact, because there is some state in your deployment that this container exists, will break up, right? It's a dynamic system, and I think it's harder to know what to test on the configuration. I mean, you can test. You couldn't do validation, but it gets harder when you try to see how it interacts with the actual live system.
Maybe about how much computation we want to add to JSON. I think we should admit that configuration is complicated and that we are programming when we are configuring. Like in the previous session, I talked about some kind of compilation process when you're configuring. And so in a configuration language or in a configuration framework, so there is the data that you want to represent as key value pairs, and then there is the computation. And when designing a language for configuration, well, yeah, there are this dichotomy between functions and relations and predicates, and how much you want to embed in both words in the language. This is crucial, and I think Q embeds some of relations and keep the functions separated from Q itself, and so yeah, that's some part.
All right, thank you everybody for attending. It's time for a break, I think. And
that's mine.
I don't know what they do, so.
Yeah, just to get a feeling for how much.
Are we on mirror? Okay.
Eating even few meals of processed food didn't go well. This is mirroring or no?
No. What am I thinking?
Right, I was hoping my window manager would do full screen, but it's not. Cool.
How do you change this slide?
We have the presenter view here. So,
Okay.
which went away?
Okay.
You gotta do presenter view again.
I mean, just go the other direction. But I was really thinking about moving all references
Go away.
as source because it's. Well, if you
Okay. So we got the presenter view here, and I'm skipping the agenda.
Yeah. So I can just do this.
Yeah.
So let's say we know
Okay.
the results.
Cool. I'm gonna lock the computer and.
All the notes that references point to. And
Coffee?
then basically
Again? Stop. All right.
So 22 minutes?
Yes.
Total?
Yes.
And let's try to stick to 15 minutes.
I'm thinking I'm going to go faster than I expected, but I'll still keep myself slow. I'll try to slow down, engage the audience. It's been a while since I presented. I used to present quarterly at the... Close the chats. Close the chats. Feels like such a big investment for like 15 minutes of presentations, right? But it's practice.
Yeah.
Practice for us, but it seems like a lot of investment for Google. How many of us are there? 1, 2, 3, 4, 5, 6. 6 of us. Which one's your order?
So welcome back. We will now move to the next talk by Farhan and Vikram about applying configuration diffing for production safety.
Hi everyone, thank you for coming to the last batch of talks. My name is Farhan. I'm a senior or staff developer now at Google.
I'm Vikram, and the technical lead for config safety in Google.
And today we're going to be talking about configuration diffing. It's a novel practice at Google, grew up organically, and I'm hoping to introduce you to it. So in this section, I'm hoping to explain to you why this is even a problem that we want to solve and why configuration at Google requires this novel solution. So number one, as everyone has heard so far in the discussions we've had with Marcel and Marcos and everybody else, Google's primary configuration language is Turing complete and declarative with very complicated control flow and very unique reference resolution. So it's often difficult for developers to do a two-person review where you're looking at someone else's code change and trying to understand what the outcome of that will be. Number two is a similar issue. GCL code is difficult and sophisticated, so those intermediate developers that Marco spoke about, they tend to write abstractions and systems that more casual developers use to actually do the configuration. So let's say I'm a sophisticated developer in GCL. I'll build a framework for my team that allows them to take a set of runtime parameters, a set of scaling parameters, a job type, and mix all those together. And I create the abstractions for them to be able to do that so that they can mix and match and create their custom deployment. But those abstractions are often leaky, especially because of the semantics of the language. So we often find that those abstractions tend to break when developers actually practice them. That leads to more problems. And last but not least, and as we've discussed as well here, even though there's a significant amount of configuration code, we don't have a robust testing culture. And so we lack a lot of the standard solutions that other languages provide. So those are not the only problems we have with configuration, but those are the problems in the scope of the solution I'm hoping to present. The solution we have designed is called configuration reports. It's multifaceted, and Vikram will explain more about the characteristics of the solution, which make it a good solution. But the characteristics I'd like to speak about are that it's fast. The reports are often ready before the reviewer is available, and we tend to present these at the code review stage of a developer workflow. They're ubiquitous. They're universally available without the user having to provide any input. They're structured. We render the reports with the knowledge of the output format and can offer inline feedback about the data types, encoding, and more. They're authoritative. We aim to remove any false positives, and our users can definitely rely on our reports. They're not second-guessing the output that we provide. And last but not least, they're very easy to use. We find that people want to use our reports. The problems I mentioned just a second ago, I'd like to explain how config reports actually resolves those issues. So for number one, the fact that it's a Turing-complete declarative language with odd resolution rules. We bypass all of the complicated semantics by presenting to the user what the compiled output is instead of showing them what the source code is. That way, the user doesn't have to understand or do the mental gymnastics required to understand what the change is actually going to manifest as. And that also applies to number two. We don't need to deal with the user abstractions. We don't need to deal with the frameworks that those sophisticated developers have set up. The code reviewer and the author can actually just look at the report and boil it down to the data structure of the underlying production system that they are familiar with. In Google's case, this solution that I'm presenting compiles down to the Borg service proto, which most developers know and is fairly easy to understand. Lastly, because config reports are available automatically for every single change, and we do offer some customization to users, the lack of unit testing doesn't bother us as much. We would still like to have a testing culture at Google, but its absence doesn't negatively affect this solution.
Thank you, Farhan. So Farhan went over like what problem we are trying to solve and our solution to the problem. I want to provide a very high level view of how the config diffing works, and also go over some of the impact metrics that we have collected with config diffing. So at a very high level, configuration diffing inside Google, irrespective of the type of configuration, can be broken into three pieces, right? So the first piece is the dependency management. This is very important in Google-like environment because we have a single source repository of all code and config. And given a language like GCL, where there is a tree of import dependencies even between the files, as part of any change, you could be editing any file in the tree, right? So the first step is figuring out even what are the leaf configurations that are affected by your change, right? So first we do a dependency analysis step to say, all right, you change file A, that basically is now affecting configs 1, 2, 3 kind of thing. Right, and the second piece of the configuration diffing solution is the execution engine. So once you have this collection of leaf config files, we can then evaluate it depending on the type of, the subtype of the configuration. So this lends itself well for like parallel execution, like our distributed systems. That's what we have. We have like a multi-tenant like evaluation system that, depending on the configuration type, can evaluate the configuration, the final value of the configuration. In Google's case, it's essentially a protocol buffer, right? And the third piece is presenting it to the user, which is also very important. As Farhan mentioned and showed, we have the config report system, which gets triggered automatically whenever the user is presenting a change for review. And also we provide the report as a diff between the old state and the new state, so that it's easier for the user to, or the developer to understand what exactly they are changing. And on top of that, we also provide some more convenience features, like if your change is actually affecting, let's say, even hundreds of leaf configurations, as long as those configuration diffs are similar, we group them together so that the developers know, okay, they don't have to go through 100 diffs just by looking at one representative diff and then saying, oh, okay, all of them fall in the same bucket. They can be sure that the other 99 also follow the same pattern, right? So this is from just from the tooling perspective. From the developer workflow perspective, this is the high-level user journey that the developers go through. So whenever you create a change in your configuration, you create a change list with the changes. And the configuration report is automatically generated, which is very important to note. Like, they don't have to do anything manual to generate this report every time. So a config report is available as soon as they present the change. And at this point, there is an opportunity for the developers to go. Depending on what they see, they might be affecting configs they didn't expect to change, or the config itself might be changing in an unexpected way. So they can go back and edit it, and then they come back to stage 2, and then they present the change to a second reviewer who can then provide like inline comments about similar issues, whether they are seeing unexpected changes in the config. And when everything's fine, the config gets submitted, and that gets deployed, automatically pushed to our production systems based on like the Google best practices for production systems. So the last part of this talk is just going over the impact of config diffing. The first is an anecdote. It was written by Keith, who's a developer, who's said, I often express a config report as the single most effective tool we have to help to manage the complexity of running thousands of services. In terms of numbers, we have the config diffing reports available to like 96% of all config changes at Google. The 4% are more to do with teams having their own weird config system that we don't support. And 67% of these reports contain diffs, which means the majority of them have an intention to change something in production. The others are a combination of just refactoring or cleaning up stuff that doesn't affect the actual output, the final output. Something interesting to note, as of now, we see like of the reports that contain diffs, 21% of them are viewed, or only 21% of them are viewed. In contrast, we do see that 65% of the reports are viewed if we have flagged an error as part of the diff generation process. This is something we are taking into account to see how we can add more automation to raise the warning level beyond just build errors, right? depending on the domain, are there more analysis that we can use to make the users look more closely at the diff reports, right? So that's something we want to do in the future. We also support like custom workflows, like saying, oh, for this directory, any diff should be blocked unless it's closely reviewed and things like that. Those are like very important, but not significant as of yet. So you want to take away?
The last part of this, I wanted to talk about if you wanted to implement the solution for yourself. Here's some of the guidance that we'd like to offer. So first, our solution started as a command line app. I believe it's at least 10 years old now. And the initial ask was, I've got this change and I want to know how it'll manifest. Can you evaluate both left-hand side, right-hand side, and give me a diff? And then we had, back then we had maybe like under 100,000 configuration files. Now we have many orders of magnitude more than that. So the next feature that was asked was, can you evaluate the dependencies for me? And so then the evaluation scaled. Then we were asked for a UI, and then we were asked for that aggregation feature that Vikram mentioned. And I guess the point of that is don't start at the end where we are. You can start small, offer the command line application, and then build on top of that as you start to see success. For number two, you should make the config reports and configuration diffing a part of your developer workflow. One of the most critical features we've had recently is we've tried to embed everything we do into the canonical toolset. And if it's outside the toolset, the numbers that Vikram presented would be even lower. People don't want to leave their existing tool sets, tool bases, the tools that they use, and go to an external source. They want that in their existing workflow, so maintain that. Lastly, the dependency management works well at Google because of our mono repo. If you have a distributed code base using multiple Git repositories, you have very tight controls on source code, this might not be the best solution, but you can still apply some of these practices if you were to convince everyone to keep their configuration centralized. You obviously wouldn't want secrets in there. That should be independent of configuration, but bring your source code together and enable this feature set. That's all. Thank you. We can take questions now or wait till the end.
Thank you. I think we have time for questions. Yeah, completely. Yes.
Yeah, so if you have a lot of similar diffs, you already mentioned you grouped them, but is there any way, how would you represent that to the user, right? Because it might still be relevant which, where all these differences occur, even if they're similar. So it's sort of a matrix. Is there a particular representation, or is that?
This? I don't think we need a mic, but.
I mean, so we do present the diffs for all of them. I mean, the basic algorithm is to just look at the hash of the diff, and if it is the same, group it together. After probably munging certain fields, which depending on the config, let's say for a bar config, a cell name is probably not important, right? We want to still group the diff together, even though the data center location is different, right? So we do provide the full list of all the configurations that are changed that you can go through, each one of them if you want, but provide like the sample of the diff that you can see. Yeah, so.
I'd like to append that. So we have, if I recall, there's at least 2 or 3 different systems using a similar algorithm for grouping their diffs. And they use different units of aggregation. One aggregates by job. The other one aggregates by file. So we have the option to present it either way.
Any other question? No.
So I'm missing some details, I think, here, or maybe we have a different mental model. So if I'm changing a line in a configuration, I change some configuration value. What is the diff that you're creating? Is that through some sort of impact analysis you're doing? That you're saying, if I change this value from 4 to 6, let's say, that affects the code that is being executed? Is that sort of? No. So can you expand on that a little bit?
So given a language like GCL, right, so I'm trying to base it on what we have seen so far. There could be other computed fields that are dependent on, so just a source code diff is not sufficient. Right, and of course you can have lambdas and all sorts of things. So a source code diff doesn't provide like a idea of what is the final impact, right? So you have the
So this stays within the GCL. So if you change some value, then you have some computed fields that are changing, right?
Yeah, yeah,
okay.
and like there could be also a lot of different leaf configurations that are using a common template.
Gotcha.
Right?
Okay.
So,
Maybe one additional clarification, if you compare it to Q or some of the other languages that were shown here, is like, what if you expand everything to JSON fully, and then compare the JSON before and after?
Gotcha.
Marcus previously mentioned about GCL that the final goal is to compile everything to proto messages, and that's actually what will be displayed.
Any other question? If not, I have one. So, you know, from a very far away, it's a bit like if you were comparing the diff of the result of the compilation of a language like the assembly. Of course, assembly cannot be read. JSON can, so I guess it's much more readable. Still, I guess the idea of having high-level languages is that a small change can actually compute to a big change. So does it happen that the diff in the source code is very small, but the thing to review is very big? And if yes, what can you do about it?
yeah, I mean, I don't think we have the metrics for that. So I've just said based on like gut feel.
I'll give an anecdote. Marcos frequently makes changes that affect 700,000 files.
Yeah, I think that is number of files, but
right.
Each diff itself usually is small, right? And then we have like, just like code diffs, we have collapsible areas where we collapse things that are similar in the file and then show only the diff part, right? Just anecdotally, like we see in each file or each final config, the diffs are usually small, right? But the number of files might be large.
Better mental model than comparing the assembly language would be you ran all those programs and capture the standard output of those programs. And then that's what we're diffing.
Makes sense.
So I had a question about the way you cluster the diffs. So imagine that you had a foo.java file, which was renamed into a bar.java, and that file was referenced across different configuration file types, a JSON, a GCL, something else. Would those changes be clustered because they're basically foo being renamed in bar? Or would you keep them apart because they're concerning different configuration languages and types?
So I'm trying to do the math in my head, but I think in that case, you would only get the diff on the foo file. You wouldn't get the diff on the derivatives or the children that are dependent on it.
No, I think, so we have like
Because
3
there's no
different
contextual change.
diffing tools depending on certain parameters, like whether we have certain systems where the config file itself is generated by build step, where a different tool actually picks up the change to generate the diff report. I think it's an implementation issue that currently we have it as 3 different reports actually with their own bucketing. But our ideal vision would be to do bucketing across these tools and stuff like that, but we are not there.
Hi. On one of the slides, you mentioned that only 20% of the diffs are being viewed by developers. Do you know why that's happening? At least from the student perspective, I really like to rely on them to say, oh, well, this is what my teammates have been working on, and now I know what to work on next. Is it a lot different in like the dev world?
We have guesses as to why developers and reviewers aren't checking the output of configuration. Perhaps they think the changes are trivial. Perhaps they are the sophisticated developers that don't need the report to understand how the change will manifest. Or perhaps it's just extra friction in their workflow that they're not willing to pay the cost of.
Yeah, I think this is something we want to improve in the future, but I think it will be based on some more automated like analysis or linters even kind of saying, raising the warning level at, it can be even something very generic, right? It can even say, oh, the diffs don't look like the code diff, right? The diff on the final output doesn't look like a code diff. This is something you should probably look into. Because many of the cases, it might be almost a one-to-one mapping sometimes. You just change the string, and then the output is changed string. They don't care. Yeah.
I just want to clarify. It's not saying that... I don't think they're saying that the people aren't viewing the change in the pull request. Right, it's just that like the safety measure of the config report, the people aren't looking at that. Yeah.
Just to follow up on that. So maybe to clarify, is there a summary that they see before they have to click into the report? Where
Yes.
they, yeah, so that might be a reason why they don't click, right? Just to, yeah.
Thank you. Any other question? We still have a bit of time. Not really. But if not, then I can call the next speaker. I think it's Daniel, and we'll talk about how to test configuration as code written in general purpose programming language, I would say.
Cool. Can you mirror that somehow? I guess it's the staple of the day that everyone has problems with mirroring. Does anybody know the shortcut to mirror filmmakers?
Wait, it's under huh? You're in the wrong. Display. Yeah, it's under display.
Yes, I don't have a curve on that. There it is.
Command F1. Command F1.
F1 you need to put in the function.
Beautiful. Okay, sorry for that. Here we go. Great, amazing. Yeah, welcome everyone. I'm Daniel, and this is Create for Speed Comprehensive Infrastructure as Code Testing. This is joint work with David, who's sitting there, and with our supervisor, Guido, who's sitting back there. Well, you all know this news. You all know outages. They are annoying. They're expensive. They happen to the best ones. And especially in the first session, I think David and Corinna had very detailed stories on how things can go horribly wrong. And as we especially at this workshop know, but also through various studies in industry and academia, is a lot of these outages are caused by configuration. Yeah, so this is an uptime study that showed that 40% of the outages they looked at was configuration caused actually, and not by the software. And this is a paper from 2016 that found 600 big outages, which were basically caused by configuration. So if we want to get our systems not to have big outages, we need to actually look at the configuration of these systems. And today we don't do that manually anymore. A lot of that is automated in infrastructure as code. So to get our configuration right, we should look at our infrastructure as code programs that we actually write. And today we looked a lot at how to get languages now for these configurations. We take another look on it. We now don't try to make languages for the configuration. We just try to use programming languages and write actual programs which then express this configuration. And that kind of technology we call programming languages infrastructure as code. And it's today already production ready, available in tools like Pulumi, AWS CDK. There's meanwhile also a CDK for Terraform, and we have our own small solution which is called Muse. Yeah, and in these infrastructure as code solutions, you actually write real programs in general purpose programming languages like Python or TypeScript. And these infrastructure as code programs are real software. So we would think like you can use all the tooling, all the technology, all the software engineering best practices that we have, know, and love. And if we talk about quality, one of them would be clearly testing, right? So if we know testing for software, this is now software, let's just do that testing. Well, there's a problem, and that's what I mainly want to talk about today. Testing these programs is a bit different from systems that we know. And after I hopefully was able to demonstrate you that this is indeed different and the challenge, I want to talk about our solution to it, which is automated configuration testing as an abstract framework, and then our instantiation of it for Pulumi TypeScript, which we call Proti. So let's get started with a small example. We want to develop now a small program that shall be a static website that is hosted in an AWS S3 bucket, and that website shall show one of the 3 words we have defined here in the array, and we want to randomly pick which one of these. How that works is we write an imperative program that through the execution actually defines a target state declaratively that then is handed off to a deployment engine that does the deployment for us. And the target state in these deployments is a directed acyclic graph where the nodes are resources and the arcs are dependencies between the resources that order the deployment. And for our small example, our small web page, this would be the target state. We have 3 nodes. We have the AWS S3 bucket. We have something that gives us a random integer. And then we have the index object that we put in the bucket and that we configure with this random integer. That's how we get the arcs. So how does the program that generates looks like? So this is now Pulumi TypeScript. For each resource type, we have a class, and we define a node in the target state by instantiating an object from the class. So what we do here in line 3 is we instantiate an object from the S3 bucket class to define that node. Similarly, we do that with a random integer. Here you can also now see when we call the constructor, we can give it the configuration of that resource. So in this case, we give it a minimum and a maximum value for the integer generator. And the same we do again for the bucket object, for the index. To get that node in the target state, we again instantiate an object of the resource classes type. What is missing now is still the arcs, the dependencies. There's 2 ways to define them. One is explicit by referencing an existing resource object in new objects on configuration, and we have that here with a bucket. So that's how we get the right arrow, not arrow. And the other way is doing it implicitly by having the object instantiated in a code block that depends on output configuration that is available on an object after deployment. And that's what I show you now here. So what we do in line 9 is we take our random number generator, the object RNG, and post-deployment, the randomly drawn number is available in the result property. And we register with this apply a callback that is executed on this post-deployment value. And because our bucket object is defined in that callback, we get this implicit dependency, which is the left arc in our target state. So this is a regular imperative program that defines that target state. And we can hand that now to the Pulumi CLI, which executes that. This is how it looks like. Takes a bit, creates the resources, and eventually, ta-da, we get our website. Everything is fine and working. We did this exercise and didn't just click in the console because we want to do something, well, that is actually nicely defined and re-executable, right? Reproducibility is a big reason for infrastructure as code. So if we do it again, we expect that we wait again, roughly 10 seconds, it creates some objects, and then we hopefully get again our nice website. Not in this case. And this is particularly bad because some resources got created, some didn't. And, I mean, it worked the first time. This seems to be even an error that doesn't only happen. This is an error that sometimes happens. So that is bad. So let's look at the error message. So what does it state? Cannot read properties of undefined, reading to lowercase, in line 12. If we look at line 12, okay, we call to lowercase on what we get from the array. Words ID is undefined if we actually made an access out of bounds. So our array has 3 elements, so ID seems to be not 0, 1, or 2. So where does ID come from? It's the parameter in the apply callback, and that is the post-deployment value of our random number generator. So we have to look at the random number generator configuration, and we see we configured it from minimum 0 to maximum words length. Words length is 3. So we just did a misconfiguration here. That's the error. We set it to draw a number from 0 to 3, but 3 is an invalid value. We get the index out of bound problem here. So that was a bug. We fix it by adding the -1 here. And this is a bug, I mean, one-off bug or index out of bound bug. We know that from every software, yeah? Right? This is nothing special, but we also have it now in infrastructure as code programs. And in classical software, we would say, well, this is a common problem, but we have techniques for that. And one common technique, I would at least argue, is testing. So if we do testing for traditional software, we now have the same problems here. Let's do testing. And that's what we thought too. And started off with looking at which testing techniques are actually available for these kind of programs. And we found it's very similar to what you have for traditional software. We ended up getting a testing pyramid with end-to-end testing at the bottom, some intermediate steps of integration testing in between, and on the top we have unit tests. And unit tests are quick and can be frequently executed locally, and end-to-end testing is the slowest version. You saw even for this small program, it took already 10 seconds when we executed the CLI. If you have complex deployments like with databases, Kubernetes clusters, whatnot, a single execution easily takes minutes up to hours. In practice, that's really the case, up to hours. So as a developer, what you usually want, traditional software, and I would argue it's the same for infrastructure as code programs, that you find as many bugs as possible with unit testing. So you want to have unit tests to find bugs as early as possible because these you can execute frequently and cheaply. So we thought, well, do infrastructure as code programmers actually do unit testing? And to answer that question, we had a look at all public Pulumi TypeScript, or generally all Pulumi programs you could find on GitHub. That was roughly 13,000. And then we tried to figure out which of them use unit testing. And we found out it's pretty much almost no one. So less than 1% actually had a single unit test implemented. Yeah? So even the ones that are mentioned here doesn't mean that they do proper unit testing. It just means that they have one unit test. So seems like there is an issue. There is a gap. But where does that come from? So, and to understand that more, let's perhaps look deeper into what is actually going on. How do these programs work? What do we have to do in unit testing? And if we look again at our example, we have that now here on the left side. What our program does in the regular execution is it integrates with the cloud, yeah, because it shall, through the execution, deploy something in the cloud. And what actually happens in our concrete example is we first started off with generating an input configuration for the bucket, for the AWS S2 bucket, and then we called the resource constructor, and that sends the input configuration for that bucket to the cloud, and then the cloud deploys that bucket and returns the output configuration of that bucket. And this output configuration is then available on the bucket's object in the remainder of the program execution. And then the same happens for the random integer. We created an input configuration, sent it to the cloud deployed the random integer, and returned an output configuration that is available in the remainder of the program execution. And then the same happened again for the bucket object. Now, this is what happens if you really execute that. It integrates with the cloud. It heavily depends on it. That's the slow part. In unit testing, we want to get rid of the cloud. So we replace it with a mock. But the mock itself now has a role. Yeah? It plays the cloud in our tests. And let's make explicit what it actually has to do. The first thing is it has to return for us, for every input configuration that we give to it, a realistic output configuration. Why does it have to be realistic? Well, this output configuration can be accessed in the remainder of the program execution, so it's actually test input. So it's really crucial that this output configuration makes sense because this is what we test our program on. So eventually, this mock is a test generator. The second thing that we most likely want to have is we also want to make sure that the input configurations we get are actually sensible. Do they make sense? So we want to have some validation logic. And in testing terms again, this also means that our mocks are test oracles. Yeah. So it's actually quite involved. Yeah? We have to mock, okay, that's one thing, but we have to implement good test generators in there and good test oracles. Okay, now we know that, let's do it. Let's go back to our example. So we start with a simple unit test. This unit test just configures now Pulumi's runtime to use a very simple mock whenever we define a resource. This mock is very simple. It just returns the empty state and doesn't do any input validation. In line 14, 15, we just execute the program and wait for its termination. So this is 16 lines now, as long as the program. However, if the program would grow, the test would stay as long. However, this unit test is useless. It's completely useless because we only have one test in general that we can test with it, and that's the one where all output configurations are empty, because we always generate the empty state. And we also never validate any input configuration. So let's solve the first problem first. Let's make this a sensible test generator for our program. Yeah? So this is now a minimal extension to make this a sensible test generator. It only returns also now test output that is really used in the remainder of the program. If we really would like to generate complete output configurations, this would be even longer. But now we have a suitable test generator. But we're still missing input configuration testing. So to have input configuration validation, let's add more logic. And now this is also a beautiful test oracle. This is now a decent test, 50 lines for 14, 15 lines program. But I have bad news. If our program grows, this unit test is very likely to grow even faster. And it's also more or less, not that idiomatic because it basically re-implements all logic that we have in the program, but in not so nice. And even worse, it re-implements logic that is actually not implemented by our program, but by the cloud or its providers. So obviously we have high coupling, we have a lot of code. This is just a lot of development effort and super slow. Yeah? So no wonder, at least from our conjecture, that nobody does that. So how do we get out of there? I mean, that's the problem. Let's get to the solution. And our solution is, let's automate. Let's try to automate as much of this as we can. And the conceptual framework that we came up for this is automated configuration testing. And what we do there is we have our infrastructure as code program. And at the core, we automatically mock all resource creations. And obviously, on a technical level, high level, this is very simple. But as I showed you already, this test generation and test oracle implementation, that's not trivial. And that's also why we don't do it in the framework. We have plugins for that. So we have a plugin interface for generators plugins. And the single task of these generators is to provide for every input configuration a suitable output configuration. And in these generators, the idea is to implement generalizable, reusable test generation strategies such that you can once implement such a plugin and then reuse it across different programs. Even further, you can move the effort from the program development or from a company towards the community. The community once comes up with good plugins, and then everyone can use them for free. And similar, we also have a plugin interface for oracles, where the idea is that these are plugins that validate input configurations. Again, the idea is the community comes up with great oracles that are reusable and generalizable, and then everyone can use them for free. And at this degree of automation, we have fully automated test execution without writing one line of code. Now you can write your new infrastructure as code program, and without writing a single line of testing code, you can test it on many, many different configurations through reusable plugins that the community provided for you. This gives you a head start for free, basically. Still, there may be properties, of course, where you want to leverage application-specific knowledge that you have, where you want to narrow down test generation or want to have a bit more precise oracles. And also that we want to make easier, and for that we provide inline specifications that allow to use very, very small annotations to have application-specific generation and oracles in there. So this is a small example snippet where in red we have these annotations. So in line 9, for example, we annotated that the output from our random number generator should be generated with a ps.integer RNG range. That's an arbitrary that we configured, where we basically override the test generation of our generalized plugin. In lines 15 and 16, that's an example of an annotation for an additional oracle check. So this is basically an additional check that looks whether the content that we deploy on the index page is empty, or basically it ensures that it's non-empty. Yeah. Okay, so this is the overall framework. The idea is to move the hard things into generalizable plugins that the community can maintain, share, and ideate on, and then have a framework that puts all of this together and allows you to test quickly many, many different configurations without writing a single line of code. More concretely, we implemented this for Pulumi TypeScript in a tool that we call Proti. We have a website for that. It's public on GitHub and on NPM. The QR and link for that is on the last slide of this talk. But what technically Proti is, it is a set of plugins for Jest, which is a popular JavaScript, TypeScript testing framework that originated at Facebook. And basically Proti is a runner and a test runner and a reporter for that. And the core of Proti itself reuses a library called FastCheck, which is arguably the most popular property-based testing framework that is currently available for JavaScript, TypeScript. That's the basic framework. Of course, where we really get like traction, where this becomes really useful, is the plugins. And we have here first plugins now that are type-based. What we do there is we use type schema descriptions that are available by default for all Pulumi descriptions. And we use these type descriptions to randomly generate reasonable output configurations. And our input validation, our Oracle currently checks all input configurations that for type compliance. Of course, this is very simple, but it seems to be already very effective. We found it to be effective already. But this is exactly where we have now our future work. Yeah, so having more sophisticated oracles that implement better models and using more sophisticated test generation strategies that use techniques like symbolic execution, concolic execution for better test generation and guidance. That is where we want to put future work into, and hopefully also hope for the community to chime in. Yeah. We evaluated Proti so far for various questions. Very briefly, we evaluated it on various variations of the example program that I showed you. And through that, we could find that Proti can find bugs reliably, even in cases where the bug sometimes shows up, sometimes doesn't. We ran Proti on all the Pulumi TypeScript programs we found in our GitHub study. That was 6,000. On roughly 40% of them, we actually could execute it without doing any change or trying to understand the program. So this shows Proti can be thrown at programs in the wild. And if you put a bit thought into it, most probably also in a lot of the other 60%, it didn't run out of without putting too much thought into it. Proti typically needs for a single test execution something between 100 and 300 milliseconds. So it's arguably pretty fast. You can run it in tens, 100 times on a program within a minute. That's no problem in practice. And we also had various tries to implement small plugins that reuse existing tools. So we had a very naive integration with the Radamsa fuzzer and with the Daikin invariant detector that showed, yeah, our plug-in interface is powerful enough to use existing techniques as plug-in in our approach. With this, I'm at the end of my talk. I provided to you a little example of programming languages infrastructure as code. Then I hopefully convinced you that testing these programs is a bit different and especially more effortful than for traditional software. That's why most likely nobody does it. Then I showed you our conceptual solution for that, a framework called automated configuration testing, which automates all this effortful mocking and moves the hard parts of it, the test generator and the Oracle implementation, from individual programs towards the community, leveraging reuse. And our implementation for it, which is Proti for Pulumi TypeScript. There's the QR in the website if you're interested. And at the end, I quickly summarize the evaluations we did so far. Thanks for your kind attention, and looking forward to your questions.
Thanks a lot, Daniel. Any question? Yes, Marcus.
So if you're now using the Pulumi schema, I'm not entirely familiar how they're represented, but is it then still really tied to TypeScript, or could you very easily also support the other languages?
So the schema is language agnostic.
Exactly.
So that's the same for all languages Pulumi provides. So conceptually, we could provide any language. Our actual implementation for Jest is very bound to TypeScript because it's written in TypeScript, it's running in Node, but you could easily re-implement it conceptually for Python or for Go or whatnot. Okay. So the approach is language agnostic, the implementation is specific, but the idea with the Pulumi types is also language agnostic. That would work for Python, Go the same way.
Yeah. So I'm not sure why it's then tied to TypeScript. The language in which it's implemented shouldn't matter, right? Like if you have the Pulumi evaluation side generates, because under the hood, Pulumi is fully data-driven and declarative, right? So you could just interface at that level, or am I missing something?
Yes and no.
Okay.
So it's, I think practically from an implementation point of view, we mock directly in the program. So we mock still in TypeScript. You would be right if we would mock in the deployment engine, which would be a step later. So it means, so practically what Pulumi does is when you instantiate an object, there is a remote procedure call. It's actually gRPC to their deployment engine, which is implemented in Go, and that does then the interaction with the cloud. And we don't mock in the deployment engine, we mock before that RPC. That's why our implementation couldn't be reused with Python at the moment.
Yeah. All right.
Just hacking the question, but follow-up question, why don't you mock at the deployment engine level?
For performance reasons. gRPC is fast, but not having it is faster.
Fair enough. I don't remember, Alex.
It's very similar to what we are doing and what we're going to talk about. But as far as I understand, most of the oracles will be able to catch only intentless, or will be able to perform only intentless validations. I mean, there should be a clear distinction of whether this particular state is invalid. What if there is a state among all valid states which is not valid for this particular developer? Do you know how your framework can cover this use case? For example, I will give you an example. I want to deploy a container, and I want my application to have enough memory in this container and some overhead. But this overhead cannot be defined in my language because there is no place for this language, for this thing to be defined.
I'm not 100% sure whether I got the question, but it sounds to me very similar to a general problem you have with policies. And actually one idea that is very close now is because policies are available for Pulumi, for example, they just released again new sets of best practices as policies. And one idea is to also implement an Oracle that actually uses these policies as a model. And then you could implement an Oracle plugin that uses your own policies, and perhaps you have a policy implemented that says, well, for this environment, we have a bit more leeway, but in general, we want to have only up to 2 gigabytes of memory. So that would be possible, but eventually you would have a parameterized Oracle, in this case, parameterized by a policy.
Nice talk. Oh, I just have one clarification question. So you mentioned that you ran Proti on a lot of real-world code. What does that mean exactly? Because there were some repositories, and then it turned out that only 1% of them had a unit test. So did you automatically create mocks for those unit tests, or did you automatically generate new assert statements? Or
very good question. So we automatically mock every resource creation. So that means we don't need any existing testing code to find out what we mock. How this is implemented generally, Pulumi, we have a very simple mechanism to automatically mock all resource creations independent of whether there was tests or not. Assertion statements, so that's the question for the oracles. So the oracle that we applied was our type-based oracle. So we basically checked, do all configurations that are actually configured for resources comply with the types that are expected. So this is only a rough approximation because these types are very, very coarse, right? There's strings and numbers, but formatted strings, or whether the number is now an integer or a float, to that precision we don't get. So that's also why I'm a bit defensive in saying we could show these programs are correct or not. What this experiment showed is you can use Proti with that, with these programs out of the box. When Proti shows a bug, it's very likely that it's an issue. When Proti doesn't show a bug, it still, I mean, eventually it's also testing, it still doesn't say that the program is correct. You may need better oracles.
How often did it say it was a bug?
It was roughly a third of the 40% that had found a bug with that simple oracle already. Yeah.
Is there any question remaining? If not, we can move on the next talk with Alex, who will talk about testing Borg configuration at Google.
Almost. Oh, wow, okay. So this is the last presentation from Google, just because it's just the last presentation. Anyway, my name is Alex. I'm going to talk about testing for Borg, and it's surprisingly similar to the previous talk. And I'm wondering whether there are other ways how to do this. Maybe there is only one. Well, who knows? Okay, so first of all, there are a lot of Googlers there. There are a lot of former Googlers, but I don't think everyone is familiar what is Borg. So Borg is our client management tool. So this tool is responsible for basically running the entire Google. It manages all the jobs, all the cells across the world, and it's running all over thousands of jobs 24/7, 365 days per year, and everything is configured via configuration files. So Borg configuration. As you know, like multiple talks about this, we're using a special language for this. It's called BCL, which is a dialect of GCL, and we really love our abbreviations.
As it was already said, it's fully Turing complete. There are a lot of ways how you can tweak your jobs. It basically looks like that. At least that's my mental model about this thing. And because of this, and it's very complex, there are a lot of ways how you can break it. Borg is a very flexible system by itself. And when you're trying to apply a very complex configuration language on a very complex system, a lot of ways how something can go wrong. And the problem of our problem is not the complexity of the language itself, but the way how this complexity being acquired. The configuration typically starts small, and like we can imagine this kitty, and then it grows with the config, it grows with the application. There are multiple teams for the application, which is 5–10 years old. You can imagine how many teams were working on this, how many developers, how many policies were implemented, how many outages were mitigated, and then like every day developers submitting more and more stuff into this, and then eventually get something on the right. That's actually a copy-paste from our code. You can see there's all the imports, and I think there are 2 pages of this down the stairs. So complexity, how do we deal with these things? And configuration language is kind of, I don't know, but how do we deal with this stuff in the code? So in general languages, we're mostly using tests. So mostly unit tests. How we deal with configuration languages? We try to do the same thing. We have unit tests. We have integration tests. We have this testing, which was, we had to talk about this. And we have a couple more technologies. But configuration is a very special subject. Nothing of them worked very well. So unit testing. Very well-known concept. Same language. Everyone knows how to do this. Multiple implementations. Everyone has an experience, as I said, but it doesn't work. Our language is optimized for configuration. People know how to read, how to write configuration, and language is actually hostile to writing code. When you're trying to write code or test, in this particular case, language will fight with you, and it will not allow you to do anything easily. The language itself is hermetic, well, more or less, and because of that, it's actually tests. They're not very natural, because when you're writing a test for your configuration, you're not looking in configuration itself. You're talking about the system, which includes your code, the system where the code will run. In our case, it's Borg. So it's kind of hard to write something really, really precise. And on top of this, our config files are using different domain models than our Borg system. So when you're writing tests for your config, you have to use different terms and different models inside it. The differences are not that huge, but they're there, and it's actually hard. So you might think configuration is hermetic. OK, so what you're going to do? Let's try to use another test, integration testing. They're not hermetic. Great. A lot of benefits, end-to-end system tests. You're actually testing your configuration with the code, and sometimes within the system. Awesome. It's very well-known technology. It's like every company has their own integration testing framework, maybe more than one. Again, funny enough, there is a discrepancy always between development, test, and production environment, and this discrepancy is encapsulated in configuration. And you're testing configuration for like being correct for production, but actually you have to use development to test environment, which is not really great. On top of this, integration tests are very fragile and they're very slow in most cases. So yeah, too many moving parts. By the way, none of these things works if you didn't notice that. New technology, which we were talking about this, diffing. This is not an actual screenshot from our system. It's just some deep screenshot I found on the internet, which has correct license. But anyway, it works really well on small changes. When you know what you're doing precisely, it works. You can actually look in your change and you understand what's going on. Or when you understand the domain, when you know the domain you're trying to apply your change, you can do this. It can block unexpected changes. When you're making a change in your configuration, you don't expect something should change, and then you see the change, you can block it. Unfortunately, there are a lot of problems with that as well. Developer's input needed on every step. Every time you run it, you expect to have a developer looking at your diff. So no developer, no results. There is a problem with the CI/CD integration pipeline, CI/CD pipeline integration. You can do this at IFI. I don't know. I'm not a big fan. Large changes are challenging, so you have to invent special algorithms which will collapse changes on multiple files so they can be presented to the developers. And from my point of view, the most important downside of these things is it doesn't make the the knowledge transfer. What I mean by that is you have to teach every individual developer how to read this particular div. So the knowledge transfer is very problematic, I want to say. Whether in code, when you submit this once, and like everyone knows what to do with this. And well, developers are not as reliable as code. Some observations. Why do we have these problems? Why developers, with all these problems, why they actively resist actually writing tests for configuration? First of all, developers are very utilitarian. They want to solve problems with their systems. I'm responsible for this system. I want to solve problems with this system. I don't want to write tests for it in other esoteric language I have no idea about. They're not domain experts, especially for Borg. They have no idea what's going on Borg. Borg is a very complex system. It contains myriads and myriads of knobs you can tweak, and like, people don't want to know about all of them. As I said, they want to solve their problems. Developers are not experts in the configuration language, and Marcus was actually mentioning this. They don't know how to write GCL. They copy-paste most of their code in very many cases. They don't know what to do when something is going really, really wrong. And most importantly, configuration doesn't deliver features. So we are not getting paid for this. So business doesn't care about this either, so we have to deal with this as well. But interestingly enough, we do have experts. There are very many experts, especially in our case, who, and these experts do have knowledge, do have domain knowledge, and they do have configuration language knowledge. The problem is they don't have knowledge what developers have. They don't know what developers are trying to achieve. Interestingly enough, domain experts are providing this knowledge via configuration. So we have configuration in the first place because we want to let domain experts to give developers a tool how to configure very complex systems. So we do have a way how to share this via configuration. And I'm running a little bit ahead, but anyway. There are some ways how we can connect developers and domain experts. Typically, we can coach people, and we do have courses for GCL internally, and we have some success as far as I understand. We can have documentation. Mileage will vary. People typically don't read configuration. But from my point of view, the most efficient way how we can connect domain experts with developers is through the code. So we should manifest the knowledge which domain experts have as the code, and then we just need to find a place where we need to apply this code. So let's get back to Borg again. Take at the top left corner of the diagram, this is how Borg is being controlled. This kind of infrastructure as code approach. Everything is configured through this thing. This is a simplified version of this. We have configuration files, configuration file which has been written by a developer, then control tool which executes one way or another this configuration file, and then via RPC talks to the client cluster manager. And basically the RPC connection is just data. Like when you're looking at the RPC interface, it's just someone passing data over the wire. So that's not real code. On the left, it's kind of YAML dialect, something like that. So we have a Java server, which is being deployed in our cluster, and it's being configured through the cluster manager as a job. And then this job is being deployed. Let's talk about experts. What experts can actually tell us when they're gonna look at this particular configuration? Well, servers indeed uses Java, so Java expert can actually chime in and tell us what's going on. JVM is running in server mode. It does have external connectivity, but it doesn't have enough memory on the container to feed the server. So just not enough. Java is asking for 12 gigabyte, and you have only 10. This is why it's important to look at actually the final results, at what we are getting at the very end. That's a default, which is being defined somewhere outside of the configuration itself. So you cannot reason about what's going on inside your configuration by looking at your configuration solely. You have to know how the configuration is being interacted with the environment at large. So that's why, by the way, hermeticity tests are limited to the capabilities. So in this case, error is obvious, but we have way more complex validations. For example, all used flags on the binary are actually defined. Like, you have to have the binary actually to check it. Or like, are you running the latest binary, etc. These are examples which we are capable of doing, like validations of we're capable of doing now. Some of them are hermetic, as you can see, but very many of them have to interact with the environments. So we are trying to keep our framework as friendly for the developers as possible. That's why we are using all the familiar technologies. So we know that developers will never try to use one esoteric language. So we decided, okay, we're going to go with just build files. We're using Bazel internally as a build tool. So everything is Bazel, everything is build files. And we're providing a capability for experts to use general programming languages instead of trying to feed their knowledge into our GCL dialect, which is possible, but it's hard. And developers actually, it's very easy for them to apply this test. So we have very low entry barrier, so we can just take it from the shelf, the validator, and then apply it, and everything should work. But there is one more problem. As I mentioned, experts cannot write validation for every user. We cannot scale them this way. So we have to provide experts an ability to scale up their knowledge. And we decided to fight fire with fire. So we're fighting with configuration. Let's give experts configuration, so experts can actually configure their stuff. That's how we're trying to deal with the scalability of expert knowledge. So experts can actually write a validator, which can take some information from the developers, basically their intent. What do they want to see on their validation? I want to check jobs which are only going to production. I want to have some headroom in my container for some reasons, I don't know. So that's how they can tell the validators what they expect to have on the wire, but they don't need to know about the domain. They don't need to know how this thing is being defined in the final version of the domain. They don't need to know what are the defaults. They don't need to know any of this, but experts do know, and they can manifest this as code. So our approach works not only for individual tests, but we can actually create different profiles. Like previous talk were talking about oracles. That's our approach, I guess, to this. These validations can be defined not only on a single individual config, but they can be defined against whole organizations, the whole set of all the configs across Google. So we can actually say for all files, we should have this thing to be true or be valid in our case. So that's our approach, how we want to scale up experts and test code, work configs, Google. Thank you.
Thank you, Alex. Any questions? If not, it's not. I mean, it's not really a question per se, but I think it's interesting because the whole session was about testing, and you could see validation or contract as a way of testing things. In fact, I guess you can probably in Q or in Nickel and code test as a validation step or as a schema. But yeah, I wonder if there is any difference, and if yes, what it is. I get the approach that we try to take with contract is that it's built in the interpreter, so it's better equipped to track the probabilistic values. So if you if you build a contract from array and Ricard constructors that is able to say, oh, this is a value that is offending. But on the other hand, I don't think it's really nice for whole configuration testing. I mean, you can always slap a type at the top level of the configuration, but then just a test. And so it's not really a question, but I wonder what are the differences and which one is more adapted to.
I don't think we'll get rid of unit testing in our GCL or BCL. We're still going to have it. Like you saw that we have multiple imports, and every import is basically it's a library. And people are using some stuff from this library to achieve some results. And when you know, and you can isolate an abstraction, you don't, without the intent, you can test it without the intent. That should work, you know when and how it should work in certain cases. You can write a unit test suite for this particular library and cover it with tests. But for leaf configuration, when we actually doing actuation of the service on Borg, we don't know the intent without actually some hints from the developers. We can probably use some heuristics in some cases, but not always, and I think it's rarely the case.
Okay.
Hi, yeah, I think this talk is actually tackling a very similar problem that my talk, as you started. I was wondering, like, our core idea to solve the problem of testing being too much effort for individual projects is pushing it as much as possible to the community to leverage reuse and having low effort to no effort for the individual project. You right now go the other way around. Like you say, we want to do it for everyone, but we need their input. But what is your experience like? Or how hard is it in practice to get this information then?
It's hard.
And do you have any ideas how we get?
Not yet.
Can get through that? Because, I mean, having these mechanisms is definitely very important and certainly necessary up to a certain level. But if nobody uses them, then we really have a problem, right?
We do have some ideas how we want to basically evangelize these things, mostly through policies. I think policies will be our entry point in how to promote these things. Back to your presentation, we don't see very many intentless validations. In very few cases you can actually say whether this particular case is fully invalid. And in very many cases, because we own the entire stack, we can embed these validations into the control tool itself. So the control tool can prevent things from happening outright. So we are pretty safe there. Most of the validations we are expecting to see, they will be intent-based. You have to know what users actually want to see.
Actually, I'm wondering a lot about this statement. For a certain reason. I mean, especially in public clouds, perhaps this situation doesn't fully apply to Google internally. But in public clouds, it's very easy to configure your network, for example, in a way that your system works perfectly, but not only you and your system have access to your database, but the rest of the world as well. And there's tons of best practices for AWS, Google Cloud, whatnot, configuration that is just best practices that can be codified, that just look, well, do you really not have your subnet public on the web? Do you really not have only HTTP accesses between your servers? Do you really not have a passwordless database hanging around? Yeah?
No.
And these general things seem to be pretty effective and needed in practice, up to the fact that Pulumi makes a product of it, of having just these policies codified.
I agree, but we don't have a public API.
Okay, so it's not a Google problem.
As I said, a lot of the things which you need to fight with, we don't have, because we have an internal control tool which is capable of making things safer for us. And all the stuff all the cherry picking is done, so we have to deal with other problems now.
Hi. Just for clarification, these validators, are they operating on the abstract syntax trees of the configuration files?
No, they work on top of the data.
On top of the data,
yeah.
Okay. And do they ever get access to the actual configurations themselves? I mean, the runtimes?
We try not to do this.
Yeah.
There is a backdoor, but we are encourage people not to do this.
So it's more linting.
Yeah. Well, it's actually opposite. The linting has access to configuration, the source files, and our validators, they don't. They work on top of the data, which will represent the service on board.
You're hallucinating questions. I might have another question for Daniel. I'm not sure if you covered that, but yeah, you say that the type are quite coarse. For example, if you have a string in your API, but actually what you should get back in practice is a URL. Do you have, or do you plan to have a way to parameterize that? So, for example, for the user to provide a generator for more specific types, typically URL as a...
So yes, I think this is a very common problem because so the types that we have, for example, from these Pulumi types are the JSON data types that you have. Yeah, and, I mean, you can't even say this is a port that should be an integer from 0 to 65,000. And I mean, there's two levels to tackle this problem. One is on a systematic level for everyone, and that would be having more precise models actually, and being able to encode this for the entire cloud. And that would be idiomatic, because then everyone gets it for free. And actually, Jürgen has a student that is pretty much looking into that right now. That would be the idiomatic solution, but also pretty hard, because getting these more precise types into the technology, and then also someone just implementing or defining that model for entire AWS, Google Cloud, is a lot of work. For individual projects, we have a mechanism, and that was these inline specifications, which I very briefly skimmed. So if you have a specific point where you want to make sure this is indeed a port number and not just a number, then you can add a small accept this value to be, and then you can implement a predicate. And then this check will be ignored during normal deployment. But if you run it with Proti, we will check every concrete value that we get for this predicate. So we have a mechanism which is arguably a lot of effort if you want to do it for every value in your individual program. So it's not idiomatic, but you can do it. And it's not too much coding, but it is some effort. And the more conceptual solution, hopefully, we see in the next 5 years.
By the way, if I may add, like one of the ways how we can introduce intent into your system as well in your validations, you can let your users to configure your oracles. You can let the developers to pass information into oracles to basically tell how oracles should do the validation. So in this particular scenario, you will have pretty much the same story as we have. Like we are capable of supporting both intent and intent-less validations, and like you can expand into intent validations as well.
And
actually, this is just a terminology. Okay.
It's more efficient, yeah.
So it's just a terminology question. This distinction between intent-less and intent-full, I find that very nice. Is that terminology you came up with, or is that already established? Okay. So let's make it established for now.
Okay.
Yeah? Okay.
I agree.
I really like it. Okay.
And concerning like what you said about schema, I don't remember if it's Terraform or something else, but we try to auto-generate like nickel contract from stuff like JSON schema or whatever. And it's often very sad because the JSON schema is very basic. I mean, I think it's more or less the TypeScript types. But usually in the description, you have an almost machine-readable additional information. So I don't remember which system it was, but you had like this must be a natural number or a list that is of length something. And it was, you could almost transform it so that the information is there, but yeah, just that the model is not powerful enough to express it. So that's yeah, exactly, for LLM. Yeah, okay.
So one comment I'd like to make after watching Alex's presentation is both the configuration diffing solution that we presented and Alex's testing framework interface with the developer at the data level. We present the data output, the tests run on that data output as well. And I think one of the reasons, as someone asked about why are solutions not being utilized as much as we'd like, is potentially because of that gap between domain experts and the developers. Maybe that data model works and makes sense to those domain experts. And over time, we'll probably have to find a way to make that also be more meaningful to developers.
And it reminds me, so it's a bit different because it's not about testing, but I think the idea behind, but probably Q as well, and something in Nix that is called Nix OS module. So what you use to describe the configuration of your system is exactly the same idea, in that as a user, you don't want to understand how to generate a /etc config file, but you just toggle high level. I want to enable SSH. I want to enable this complex service. And then the people writing the actual modules are domain experts that know how to derive this thing from the high-level knobs. But yeah, I guess the idea is that users don't have to interact with this part of the system, ideally, and just stay in the high-level configuration.
One more comment. So one of the applications of config diffing that we didn't present is for large-scale changes. Now, if a developer is making a change to source code and they're already describing their intent, but when you're dealing with hundreds of thousands of files, the person who's making that larger change can potentially describe their change in a different abstract language. What would you call that? Like start block. Just I intend for this value to change to that value. And if I can describe that intent, sorry.
Providing a domain-specific language to describe the change in the output.
Right. So if the person making the large change wants to describe their intent and what their expected output is, our tool can also be used to automatically reject changes that don't fit that mold if they're doing something unexpected. You can speak to this.
Yeah, I mean, very close to that. I mean, one concept that we get in the kind of technology we look at is also that you can build actually higher level configuration abstractions by reusing OOP mechanisms that we have in these languages, right? So we can implement our own component resource class, which in the constructor then defines other resources. But with everything OOP, and I mean, Marcel has very strong opinions on that composition over inheritance. This is also makes it very easy to obfuscate things. But this is actually something that people use. BMW, for example, I talked with people there last week that use that very heavily. They have an internal platform team that basically builds the abstractions BMW developers actually care about on a very high level and provide them as a shared library. And that seems to work very well because it hides a lot of the configuration details from these developers without obfuscating them.
Mileage may vary.
Question for you. So Alex presented some of his validators. Do you have any examples of policies that you've seen implemented?
Yeah. So I mean,
are they similar to what Alex presented?
I would say they're more general. It's really things like your AWS 3 bucket, does it have the switch I'm public on the web? Is it off? Yeah. If you define a CIDR, is it not on 000, but is it more specific? Mm-hmm. If you define a subnet, do you attach an access control policy to lock it down, basically? Yeah. So it's really on this very general level. However, this seems to be needed in many cases because people forget it.
Yes.
Or just don't know about it. I mean, that's even worse. Like, the cloud is very easy to use for everyone, and still it's very complex. And the documentation is also, I would say, in general, incomplete and not very accessible. So it needs a lot of experience to use the cloud safely, but everyone can use it. So having these as a safety net is just a generally good thing. Yeah.
We got a question back.
So the first presenters of this session presented a diffing tool, so to speak, and the last presenter presented a validator tool. And I was wondering, has there ever been a need to validate the changes and the consistency of changes? Because that seems like would be a nice collaboration between the two teams.
Yes.
Okay.
They're all actually friends.
Okay.
One of the, I'd like to comment, and Vikram, you should chime in. One of the things we're trying to do is, Vikram's team also has invented a set of additional debugging symbols that are appended to the output, which can also, you know, like what a debugger would do is to tie it back to the source, where the output came from. And using that, they're able to build additional analyzers, which, and if Vikram can give an example of that. One of the ones that might.
I'm trying to see how to translate it into like.
On top of this.
On top of it.
Not every question we can answer, unfortunately.
To some public. But yeah, as I was saying, actually, one of our strategies to improve our 21% number is to have like analyzers run on the diff output. Right, so that we can do automatic like basic checks based on the domain, saying this sort of transition is actually not allowed. And for transition checks, we need both the older value and the newer value, unlike like regular unit tests where you just have the new value. Right, so yeah, we are definitely looking into something like that.
I think it's almost, I'm very interested in having, so we had a lot of examples of things that crashed because of configurations. I had a part of the list, but not all of the list, so I would be very interested in gathering those examples because, you know, that make for nice paper intros. But we can do that at the end. So yeah, it's time to wrap up. It was really nice to be for the first time in person. I want to thank Jürgen, Marcel, and Mark as well. And me for organizing, and this young person as well who put up with our strange domain. Yeah, I think we wondered if we are very interested in continuing this workshop or this meeting, whatever the form. But we wondered if, like, every year was a good, was too short or not, or every 2 years would be a better frequency, and we were interested in getting your input on that. Would you come back next year if we were to do exactly the same thing, or would you have not enough things to to show?
1 year sounds okay.
So yeah, there are two options that I had in mind, and we can talk about it, obviously. So OOPSLA next year would be in Los Angeles, which interesting, but a bit far from all the organizers, at least. There's eCube and ISTA in Vienna next year, which would be nice for me. Is that an option at all? Like, do people want to come to Vienna next year? September? Yes, I see some nodding. All right. I think that's something we can talk about. If you want to help out as part of like organizing or program committee, please let us know. Talk to us. There's one more thing I wanted to ask. Is there anything else? Yeah, Marcel.
So related to this, I think what I've heard from Marcus also, there's also interest to really start establishing more of a configuration field within academics in general, like starting lifting it. So basically continuing the whole Dagstuhl story and sort of building on that and expanding that. That would be nice, just as a.
Yeah. So their Dagstuhl is a high overhead option. Like getting this stuff into Dagstuhl was like this whole process. Yeah. There's another one that I think is interesting because it's in Japan, which is called Shonen. The academics here will know it. And another one that is a bit more lightweight is in the Netherlands. It's No. It's a format like Dagstuhl. It's in Leiden, and I forgot the name right now. Does anyone? It's some center. It's the Leibniz Center, maybe? Yeah. So there's some more lightweight form of organizing these kinds of things in the Netherlands, I think, that would be interesting. So that we can pursue that potentially. And Conflag can continue as you know, as a one-day thing. The other option is to have 3 or 5 days. And you know, it was really good at Dagstuhl. That's maybe something we can do every 2 or 3 years, right? Yeah. Is there anything else we want to bring up?
And then how to also think about how to then move that further, right?
Yeah, I guess a mailing list should be in place at some point. Like we have the Dagstuhl mailing list, but if you want to expand to this audience here too, maybe we can have like a Google group or something. I think that could be interesting.
That's going to be nice. Yeah. I really want to see the fundamental research on what is the difference between code config and data.
I think it will be an opinion piece more than the fundamental.
You need to start somewhere.
Yeah, exactly. Then maybe I have one more ask, because this is the first in-person Conflang. We had, like the predecessor to Conflang was called SE Config, Software Engineering for Configuration at ASC, and we had a very nice group picture. So everyone who wants to join, I would love to have a picture here in front of the TV maybe. Yeah.
Who's taking the picture?
The student volunteer. Yeah, you should be in there, yes. No, but you were here all day. Come on. You were yeah, you guys are very nice t-shirt. Yeah. You can also zoom out if you want. If it doesn't work. Yeah.
Okay, there should be a good one.
Perfect. Thank you.